Dear colleagues, I'm very glad to meet you at the first international workshop on computer modeling and intelligent systems, CMIS-2021, held in Zaporizhzhia. This year, we have pandemic of COVID, and we organize this event only in remote mode, but our physical location is National University Zaporizhzhia Polytechnic, and this event provided by the Department of Software Tools. We have support for this event of the Freshcode company, which provide us licensed Zoom account. This event is related to several international projects supported by the European Commission and German programs. It's European projects BioArt and Workforce and DAD project WiMAX, but our event is open for every scientist who want to participate and not strongly dependable from the projects. It's our partnership only. You can see our program committee and local organization committee. We join scientists from different universities worldwide, and I hope that each year we will improve our PC stuff, and it will be more powerful to analyze every paper. You can see at the next slide that we have this year submissions from 21 countries instead of 12 in 2020. So our workshop growing up, but the number of submissions this year were reduced because of maybe more specific topics of our workshop, and we have a strong paper selection. So we select for presentation only 44 papers instead of 83 in 2020. So we have more strong regulation of paper selection and more effective process. I hope that quality of our papers will be better than comparable of the previous years. It is important for us that this year, CMIS 2021, is devoted to several anniversaries that we have at our university. First, it's 120 university of our university, National University Zaporizhzhia Polytechnic, that was founded in 1900. It's a third anniversary of founding in 1991. The software engineering specialty now it's provided by the Department of Software Tools, and 25th anniversary of the first graduation in 1996 of students on this specialty too. So this year for us is very special that we have several anniversaries, and we devote this event to celebration of these anniversaries. Now we have a schedule for online presentations, and we can provide small changes if they will be needed, but I ask all of you try to take into account our reglement. We have approximately 10 minutes for each presentation and approximately 5 minutes for questions, answers, and discussion. So let's be effective in time, and I think that we can start our meeting from the paper 2. If somebody want to say their presentation more quickly, it will be good. If we need to change an order, please say me about it. Nobody any changes? Okay, so for the paper 2, now I will give permission to provide demonstration of presentation, and I propose to the authors of this paper to show their presentation. Long-term forecasting method in supply chain based on artificial neural network with multi-agent meta-heuristic training. There is no authors of this paper. As for the...
I am not said the demonstration. No.
You want to say only?
No, screen.
I provide allowing. I make how to say? I allow demonstration of screen. Maybe I need to. I need to stop my presentation.
Oh, yes.
So please.
Can you see?
Yes, please. It's your time.
Long-term forecasting method in the supply chain based on an artificial neural network with multi-agent meta-heuristic training. Purpose and objectives of the research. Purpose of the research is to develop a method for long-term forecasting in supply chain. Objectives of the research: analyze existing forecast methods, propose a neural network forecast model, choose a criterion for evaluating the effectiveness of a neural network forecast model, propose a method for determining the values of the neural network forecast model parameters based on multi-agent meta-heuristics, perform numerical studies. Problem statement. The problem of increasing the efficiency of long-term forecasting in the supply chain is reduced to the problem of finding such a vector of parameters which satisfies the forecast model adequacy criterion, delivers the minimum of the mean squared error, the difference between the model output and the desired output.
Professor Fedorov, please close the gallery of images on your screen, because it, how to say, cover your presentation. You need to delete gallery of images of our representatives from the right side.
Okay.
No, it's we see gray rectangle. Oh, okay. Okay. So please, you can say.
Creation of mathematical models of an artificial neural network for long-term focus. The structure of the model based on a fully connected echo-state network with a cascade of unit delays for an input layer neuron. Type 1. The structure of the model based on a fully connected echo-state network with a cascade of unit delays for a neuron as input and output layers. Type 1. Type 2. Long-term focus model of the ESN. Type 1. Initialization, focus, initialization as the outputs, as the neurons, as the input layer, calculation as the outputs, as the neurons, as a hidden layer, calculation as the outputs, as the neurons, as the output layer, Long-term focused model is in ESN type 2. Initialization focused. Initialization of the outputs of the neurons of the input layers. Calculation of the outputs of the neurons of the hidden layer. Calculation of the outputs of the neurons of the output layer. Criterion for evaluating the effectiveness of a neural network model for long-term focus. To determine the parameters values as a CSN model, the criterion as a model adequacy was chosen, which means the choice of such values as the parameters which deliver the minimum of the mean squared error, the difference between the model output and the desired output. Graph of the dependence of the mean square error as a focus on the number of hidden neurons. Comparative characteristics of distribution types used in the SVD method. Comparative characteristics of neural networks for long-term focus. Conclusions. The article discusses the problem of improving the efficiency of long-term forecasting in the supply chain. To solve this problem, the existing forecasting methods were investigated. These studies have shown that by far the most effective is the use of artificial neural networks. To improve the quality of the long-term forecast, an ESN neural network was chosen, modified by introducing full connectivity and cascades of unit delays in the input and output layers, and in the course of a numerical study, the structure of its model was determined. The experiments have shown that with 16 hidden neurons, the value of the mean squared error does not change significantly, and the selected network gives forecast results with a minimum deviation. A method was proposed for determining the parameters values of the proposed neural network model for long-term forecast. This allowed to ensure high speed and accuracy of the forecast. The proposed methods are intended for software implementation in the MATLAB package using parallel computer toolbox, which speeds up the process of finding a solution. The software implementing the proposed methods was developed and researched on the database of the logistics company called Ukraine. The conducted experiments have confirmed the efficiency of the developed software, allowing to recommend it for practical use in solving problems of supply chain management. Prospects for further research are in applying the proposed methods on a wider set of benchmarks. Thank you for your attention.
Thank you for your presentation. Dear participants, if you have any questions, please feel free to ask. Keep that you need to use microphone if you want to ask something. So if there is no any questions, I want to ask that there are different methods allowing to build neural networks and methods related to different problems like classification and, for example, prediction. You propose a specific how to say, technology, and we need to understand its comparison with other methods existing. What key features of your method that can show us that it is more useful comparable to the other existing methods, please?
Our methods need more small computational complexity than gated recurrent unit or LSTM neural network. And our method used metaheuristic combination simulate an alien and particle swarm optimization. For learning, for small computational complexity and more high speed learning neural network.
Okay, it's about how to say internal structure of your method, but if we will speak about external evaluation measures like time, like accuracy, etc., your method is more effective in time, is more effective in accuracy sense, or maybe in other sense. What is the key reason to use your method comparable with others?
Yes. Criterion minimum MSA as a focused у нас and computational complexity. Comparison with full LSTM, GRU, or
so generally your method should be faster.
Yes, computational complexity more small than full LSTM, GRU, and DSN.
Okay, thank you. Maybe somebody other want to ask a question?
Yes, I have one question, Ivanov Sergey from the Zaporizhzhia National University. Question about data that you use in your model. What data do you use to train neural network?
Ecole used data for Ecole Ukraine, from Ecole Ukraine.
Thank you.
Other questions, please? So if there is no any other questions, I thank for this presentation to Professor Fedorov. And we have next paper. It's a 6 ID formal models of question answering machine. So please, authors of this presentation, does anybody present here from the authors? If no, then we will speak with authors of paper Modeling the Dynamics of Information Panic in Society, COVID case. Please.
Yeah, it's my paper. I just started. It's okay, you can see my screen or not?
We see you, but we don't see your presentation.
Strange. I need access, just a moment. Yeah.
Okay.
And what
Yes.
about now?
Yes, all okay. Please.
Dear ladies and gentlemen, my name is Sergey Bushuyev. I present this paper with my colleague, Professor Bushuyeva, Anishenko, and Bondar from Kyiv National University of Construction and Architecture and Odessa National Marine University. First of all, I would like draw your attention about current trend in modeling COVID-19. I print out maybe 9 articles in this topic because it's very complicated topic. We start publish an article at the beginning of previous year, but now we are looking that the problem become more and more complex than we look before. The global trends in modeling COVID-19 define 2 items. Due to the rapid development of information technology, a new association has emerged, which is a computer system and networks more deeply in innovation activity, artificial intelligence, cloud technique, database, big data processing, and emotion intelligence. I draw your attention about emotion intelligence because now we have the problem with that. The trends such as presenting is growing and expanding, so that there is a need for a new organizational or innovative behavior with both involvement in information technology and management of the complex system like infodemic, panicdemic, and pandemic COVID-19. Before that, we talk about only pandemic. After that, at the spring 1919, World Health Organization introduced now new term, infodemic, information influence on the society and each of people who live in this society. For simulation of the system, we use so-called energy entropy concept because we touch huge uncertainty, and we remember that in approximately in 15th Shannon introduced information entropy with a special measure, but we extend this approach and say we use energy entropy concept. Consider that an organization is open with energy circulation due to information, material energy exchange with the external environment. The energy entropy is a characteristic of functions of the state of organization reflected to effectiveness, its business process, and interaction with the external environment. In this case, the entropy of the organization formalized and the main provision of energy entropy theory of organization are described. In the project management of organization is a field of knowledge when it is impossible to establish numerical parameter or function law by analogy with experimental size. The formalization of energy entropy was carried out analytically. The expression for energy entropy was obtained based on the energy balance of the organization with consideration, justification of both the ideological and mathematical component. Organization and energy entropy. In this study, we understand that we have to do with organization of different size and different type. For instance, Ukrainian society is organization, university, etc., etc. In this case, we use our society as an organization, and now we are looking for apply energy entropy concept to simulation. The process which we call panic in the society according COVID-19. Now we have maximum maybe panic in our society because we have not any vaccine, and we expect that the third wave of the COVID disappeared without any action from our state. Such consideration determined by universal law of energy entropy theory, which is the case associated with special cases of system which have a social component. How entropy formed in organization? In this picture, we see on the top level organization with some managerial function. We have internal structure of organization. We have a base of organization. That means we have society. We simulate development, and we simulate support according to COVID-19. All these elements are business processes. On the lowest level, we have marketing and logistic, external structure, and consumers. It's all population of Ukraine, which live in COVID-19 society as an external environment. In this picture, I would like explain how to infodemic or social media and human communication form information panic. As usually, initial of information panic is mass media and social media in Ukraine. We have social network, Facebook, and many different social networks, which collaborate and communicate maybe half of our population. And after that, we have information panic, and after that, we have panicdemia, which is has negative influence to the state of pandemia and infodemia in our society. This is a logical relationship of various states of society from the position of information panic. We have the entry fear generation event. For instance, third wave of COVID-19 in Ukraine. We expect that the growing negative information, and it's happened. We have so-called value of this information. We try reduce negative information, but infopanic go in parallel, and we return to normal state after the finishing third wave of corona crisis. And in this case, now in our society, we have chaos, unfortunately, because I have a feeling that nobody have not managed general situation in our health system and in our public management system. We simulate different with different cases and entropy dynamic, including information entropy. We say we have different parameters of which influence of the information entropy. On the vertical axis, we have a vertical entropy, and the horizontal axis, we have time, and we have 4 options, and 4 options of entropy. This simulation in this equation, and its option give us more negative result because uncertainty in the society and panic in the society growing maximum. And now we have to simulate dynamic of entropy for different dynamics and information entropy with different models. We have same situation, and we saw that we can manage the first option as a first option, minimum uncertainty in the society using this equation. Why we talk about panic in our society? We can see dynamic of indexes. We call it I panic. It's indexes with directly depend with entropy of organization, which is our society, for different scenarios. And in this case, we have simulate 4 scenarios, and we look what happened in each wave of pandemic in Ukraine. We have level of entropy and level of panic. A conclusion: entropy is a measure of user loss of energy is adopted the success to state of society in the process of increasing negative information impact. Introduce into consideration an indicator of information panic. We find out direct relationship between the level of entropy, uncertainty of state of society, and information panic based on the change of entropy. The influence of various dynamic of information, entropy, and energy low the society movement and growth of goods of the entropy, and the indicator of information panic is analyzed with a calculation exam in conventional figure. The main state of society is the process of entropy growth. Identified their relationship is presented in the form of Markov chain. The initial event, which is event of generate fear in the society, the final event of the endless growing of informational panic, and is chaos. The result obtained are the basic for further research on the impact of negative information on the society and identify ways to return is to normal state. This is a final slide. I would like to say thank you for your attention, and I'm looking for the question.
Thank you for your presentation. Dear participants, if somebody wants to ask a question, please.
Yeah. Switch microphone on. Dmitry, switch microphone.
If somebody asks, please.
Yes, please. What data are needed to estimate the entropy in the society?
In the article, we have a chain of equation which show how we define dependence between the organizational entropy and the panic. But it's maybe 10 or 12 equation, and I believe if we go inside, we spend more than 10 minutes for answer. Please, if Dmitry, if you would like to have my answer, please go through the paper, and we can communicate according to that. I especially have not put on the presentation equation, which is in the article. It's only conceptual model. It's not formal model, which is presented in my paper.
I understand. Thank you.
If somebody other want to ask something, please.
We have in this topic, we have maybe 15 papers in different topic. First of all, we start from special equation, how to simulate this differential equation, which simulate the how to diseases start, and this is a equation which called Sears with the wave of pandemia. And after that, we extend our articles with infodemic and pandemic. And now we are looking for the next step, how to we decide the issues with the vaccination of population and what happened when we reach the needed level of vaccination. But it's our next article. If you would like to look on the paper, I can send you the list of the paper in Scopus on this topic.
With pleasure.
And I appreciate if you would like to this research, because I believe for Ukraine it's very important.
Thank you very much.
Thank you very much. If there is no any other questions, we will go to the. We will return to the previous paper. The paper 6 formal models on question answering machines. If there is anybody.
Can you hear me?
Yes.
Oh, thank you. I had problems with Zoom, and so I'm ready if you allow me.
Yes, please. You can start your presentation.
And my presentation. On my presentation,
we don't see it. You need to press button, screen demonstration, green button. To show your presentation at the bottom of your screen, there is a demonstration of screen. in Russian, демонстрация экрана. Oh,
Can you see?
yes, yes, please.
Okay, finally, my presentation has 6 points. First, I will say a few words about the generally accepted typology of question answering dialogue systems. Then, a cognitive model of question answering dialogue will be presented. This model not only describes the cognitive foundations of question answering dialogue, but provides an ontology for subsequent formal models. Then, two formal models will be described. The first model associates the question answering dialogue with the behavior of the Mealy automata. The basis of the second model is the presentation of the script of the dialogue in the form of a Petri net. Finally, the scope of applicability of the second model will be analyzed. The modern classification of conversational systems divides them into two classes: chatbots and systems focused on solving problems. Chatbots simulate an unstructured question answering dialogue. The first chatbot, Elisa, was created by Weizenbaum in 1966. Modern examples of chatbots are BlenderBot, Facebook, XiaoEyes, Chinese name, Microsoft. Chatbots have a pronounced pragmatic use and can work on social media and e-commerce systems. Problem-solving dialogue systems are capable of solving problems that are ill-formalized. The example of an ill-formalized problem is the problem of teaching and knowledge transfer. Intelligent tutors are examples of problem-solving dialogue systems. From our point of view, the modeling of dialogue processes should be based on the cognitive model of human perception. On the first slide, the cognitive model of the question-answering cycle of perception is presented in graphical form. This model is a development of the nicer perceptual cycle model. The cognitive model of the question-answering cycle implies the following. First, each question-answering cycle is used by the active agent to obtain knowledge from the reactive agent, which he needs to continue the dialogue. Second, on each question-answering cycle, the active agent operates with a set of answers that he expects to receive from the reactive agent. Third, the question generated by the active agent is not created algorithmically, but it's searched for in the memory of questions. The method of accessing this memory is at the same time a method of solving the problem. The memory of questions and the dialogue method of accessing the memory of questions are components of the dialogue script. The fifth slide lists the assumptions underlying the finite automated model. First, the problem that is solved in a question-answering dialogue can be solved in a finite number of dialogue cycles. Second, by the beginning of the dialogue, all questions and answers necessary for formation of dialogue cycles are determined. Third, modifying the current set of expected responses always generate a new set that is different from the previous one. The sixth slide shows the main components of the finite automated model. The model includes a dialogue method of accessing the memory of questions, DIM. DIM is determined by four components. A set of indices of questions needed for the active agent to solve the problem. A set of all expected responses. A set of indices of the dialogue cycles carried out in the process of solving the problem. Step function which maps the pair. The current response of the reactive agent and the current step index into a pair. the index of the next question in the index of the next step. The seventh slide provides a meaningful description of an example that is used to illustrate formal models. Example describes a dialog method which consists of two steps. At the first step, the active agent generates a question 1. The active agent expects 4 responses to this question. 1. Request for a hard copy of a question. 3. The answer that implies the continuation of the dialog and the generation of a question 3. 4. An answer that implies the continuation of the dialog and the generation of a question 4. 5. Unrecognizable answer. Any answer other than 1, 3, or 4. Answer 5 means that it is necessary to form a question 2. At the second step, the active agent generates a question 2, which is a reformulated question 1. At this step, the active agent expects to receive the same answers as in the first step, as well as an answer 2, which is a request to return to step 1. The dialog method DM for the example under consideration can be described analytically, in tabular form, and graphically. Slide 8 shows a graphical description of the dialog method in the form of a finite automated state diagram. The nodes of the graph correspond to the indices of dialog cycles, and the branches correspond to the pairs, the expected response of the reactive agent, and the corresponding index of the question of the active agent. The ninth slide lists the reasons for the transition from a finite automated model to a model in the form of a Petri net. The main reason is the ease of using the Petri net for data logical design of an artificial active agent. Data logical design means that the script is implemented not using program code, but in the form of a database. Representing a script as data has an important advantage. Creation and editing of a script can be carried out directly by the script author and without the participation of a programmer. This requires only the full-screen script editor. The 10th slide lists the main components of the Petri model. The dialog method is represented by 4 components. A collection of question indices, which allows the presence of several instances of the same element. A collection of responses. Function of subsequent question indices, function of subsequent answers. The 11th slide shows the Petri model of the dialog method in graphical form. The model corresponds to the dialog method for the example described earlier in the 7th slide. On the 11th slide, the elements included in the scope on the concept of a step of a dialog are highlighted. The dialog step includes the active agent questions, as well as all recognizable and unrecognizable responses of the reactive agent for this step. On this slide, all unrecognizable responses are modeled with one black transition. The 12th slide lists the main components of the Petri model that simulate the dynamics of the dialog. The marking vector indicates the active step. Unified process simulates the cyclically repeating dynamics of the dialog and uniformly manages the transition from the previous step of the dialog to the next step. 2 process daemons which can carry out, if needed, the non-standard processing of a question or answer at any step of the dialog. The Petri model well simulates a dialog in which there is a close logical connection between the previous answer and the next question. In psychodiagnostic tests, dialog interaction with the subject of diagnosis is used to accumulate data. The accumulated data is then used to formulate a conclusion. In such tests, the previous response of the reactive agent and the subsequent questions of the active agent are independent. The implementation of psychodiagnostic tests using the Petri model is difficult, since it generates a tree-like script with a very large number of potential steps. Scripts of hardly implemented dialog methods are greatly simplified if the model includes the memory of response history. The index of the subsequent questions is determined taking into account the current response of the reactive agent and the contents of the response history memory. The 14th slide shows the Petri model of the dialog method script for a simple psychodiagnostic test consisting of 2 steps. At each step, only 2 responses are expected from the reactive agent. The model includes memory that stores the response received from the active agent in the previous step. Thank you for your attention.
Thank you for your presentation. If somebody want to ask a question, please. So if nobody want to ask, then I will ask. Generally, you speak about a very important technology and what should be the key practical applications for which proposed technologies are more useful comparable with analogous?
I would say that modeling has 2 purposes. The first purpose is to understand deeply the phenomenon of the dialogue. And the second purpose is to use the model in practice for the design of artificial active agent. We developed these 2 models, and has another more sophisticated model which can be used to design artificial active agent. We did it, and this artificial active agent can be designed, the script of a dialog behavior of this artificial active agent can be designed directly by the author of the script. For example, by teachers of foreign languages, if they are constructing the script for knowledge transfer, for teaching of different foreign languages.
Oh, thank you. Professor Fedorov, want to ask something?
First question, why didn't you use proactive agents?
You mean why I use this terminology?
Agents with target function, proactive agents. Agents with target function.
Hard for me to answer these questions, why active and reactive, but not proactive. But historically, in our papers, we use this terminology.
Mm-hmm. Thank you. And other question, what software package did you use?
It's theoretical investigation. If you wish, I can say that we used Turbo Pascal and Object Pascal languages and subsequent packages for software experiments.
Thank you.
Please, Professor Polyakov, you want to ask something? Professor Polyakov, your microphone is, please.
In your system, you use binary type of answers. And what about answers maybe, yes, no, and maybe you use this type of answers?
I use binary, as you say, type of answers only in my last slide when I demonstrate an example of psychodiagnostic script with the memory of the history of questions. In my previous models, there are set and collections of answers with a large number, I would say, answers that can be recognizable.
Thank you.
Thank you for your presentation. If there is no any questions, then we will move to other presentations. Next paper should be moved for the future time, and if authors of the 31 paper, Homogeneity Hypothesis, Indiscriminate Analysis, available here, I ask them to show their presentation.
Thank you. I'm ready.
Please.
Do you see my screen?
Yes, please.
Thank you. Dear colleagues, my talk is devoted to the homogeneity hypothesis and its application in machine learning, in particular in featureless discriminant analysis. Main idea of FDA is construction of a linear mapping where D is a matrix of distances between objects in the training sample, and lambda is a vector of labels, and W is a vector of distances between a test object and object from the training set. Therefore, for new object represented by the distances from the element, we can represent it as an inner product. Despite of the simplicity of such idea, the featureless discriminant analysis has some drawbacks. In particular, FDA in the original formulation by Dune does not work with samples and use metrics. However, it is impossible correctly introduce a matrix between samples since they are unordered sets. Therefore, we need to replace a matrix by a numerical measure of samples homogeneity. The homogeneity hypothesis may be used not for extension of FDA on random samples only, but also for binary classification on random data. Consider training samples X and Y and reduce the classification of a test sample Z to testing of homogeneity Z and X from the one side and Z and Y from the other side. There are many non-parametric tests for two samples homogeneity, and the most widely used are the Kolmogorov-Smirnov test and the Wilcoxon test. We propose an alternative and show that it is more universal and effective test. Our approach is based on the Hill's assumption. The Hill's assumption states that for the exchangeable random values from absolutely continuous distribution, the probability that the random values X with asterisk lays between I's and J's order statistics is defined by equation 1. Finding the relative frequency of the event that the elements of the sample Z lays between the I's and J's order statistic, we can estimate proximity between the observed relative frequency and the known expected probability. For definiteness, we use the Wilson confidence interval 2. The significance level of these intervals is the function of a parameter g. When g is equal to 3, the significance level of the interval does not exceed 0.05. Statistics estimating the homogeneity of samples X and Z is defined by the equation 3. As we see, the p-statistics is the estimation of the probability that the samples are homogeneous. Therefore, using equation 2, we may formulate the following decision rule. The null hypothesis is accepted if H is greater than 0.95, else it's rejected. In practice, due to the rounding of G's, samples frequently contain ties, duplicates. Let us introduce a sample X with tilde containing ties and approximating a hypothetical sample X without ties and construct corresponding variational series. If a random value X with asterisk is drawn from the same distribution independently from X, then the Hill's assumption may be refined as it is shown in equation 4. Consider empirical samples X with tilde and Z with tilde, and using the Wilson confidence interval for the probability 4 of the event that the element of the sample Z with tilde lays between the i's and j's of the statistics, we find the observed relative frequency. Then we compute the empirical p-statistics. The null hypothesis is accepted if the probability that the samples are homogeneous is greater than 0.95, else the null hypothesis is rejected. The above version of the decision rules based on the Wilson confidence intervals depend on the parameter j that varies from the 1.94 for the normal distribution to 3 for a general unimodal distribution. To avoid this uncertainty, we propose to use an original exact confidence interval for the unknown probability constructed on the proportion in the Bernoulli model consisting of n trials. Since the equation describing this exact confidence interval are quite cumbersome, we don't show them here, and you can see it in the paper. Oh, I'm sorry. To assess the true positive and true negative rates of the proposed test, we performed numerical experiments using samples from the normal distribution of various degrees of overlapping. We considered 100 samples of 40 random numbers having different averages and the same variance, so-called location shift, and as well as 100 samples and 40 random numbers having the same average value and different variances, so-called scale shift. We calculated the average p-statistics and its lower and upper confidence limits, the average Kolmogorov-Smirnov statistics and its p-value, and the average Wilcoxon statistics and its p-value. The experiments, I shall show the tables from 1 to 8, have shown that the p-statistics is monotonically decreasing as the local shift increases. The Kolmogorov-Smirnov and Wilcoxon sign-run test work well when testing the location shift hypothesis. However, the Kolmogorov-Smirnov test fails when samples are largely overlapped in more than almost a half of the cases, and the Wilcoxon sign-run test has failed at all. The original and exact p-statistic test fails in almost a third of cases of very overlapped samples following the distribution N03, N04, and N05. You can see in table 1 and following the result of the simulation, and as we see, we can see the monotonicity of the p-statistics when the difference between location point increases, and we see that in most cases we distinguish the samples. That is, it is successful. This is the result of the application of Kolmogorov-Smirnov and Wilcoxon test, and as expected, this test in the location shift is work very well. But when we test the scale shift, when the samples have the same mean but the different standard deviations, we have some other results. The ties, we consider two cases, the samples without ties and samples with ties. The ties break the monotonic decrease in the p-statistics as the difference between the means increases. The p-statistics like the Kolmogorov-Smirnov test does not distinguish between the distributions of N03, N04, and N05. And at the same time, it turned out to be effective in cases where the Kolmogorov-Smirnov test and the Wilcoxon-Sign-Rank test don't work. Thus, there is an advantage of the p-statistics over the Kolmogorov-Smirnov and Wilcoxon-Sign-Rank test. Our test demonstrates high sensitivity and specificity for both non-overlapping and strongly overlapping samples. Due to this property, it can be called a universal test for the homogeneity of two samples. That is, it both effective in the case of the location shift and in the case of scale shift. In table 9 and table 10, we can see the monotonicity of the p-statistics when we test the location shift. But this monotonicity is broken when we test the scale shift. But this breaking is not very strong. The evaluation of the homogeneity of the samples is provided by the Petunin p-statistics and its variance demonstrate high sensitivity and specificity in experiments, both when testing the hypothesis of a shift in the mean and in testing the hypothesis of a shift in the scale. The proposed method has a rigorous mathematical justification and high efficiency in practical application. Thank you for attention.
Thank you for your presentation. Please, questions. If somebody want to ask something. Nobody wants. As for the term, then I will ask, as for the term high efficiency, what is the criterion to measure the efficiency for your methods? It's a computational cost or it's accuracy, or what is the key reason to use?
Yes, I agree that efficiency have some fuzzy, but in statistics, efficiency has a very exact sense. It's a high true positive and high true negative rates. Sensitivity and specificity.
Okay, thank you. Do we have some other questions? If there is no any, so thank you very much for your presentation and answers. Then we need to go for the paper on construct pattern variability in virtual desktop infrastructure. Please, authors.
Thank you very much. I'll be sharing the screen in a moment. There we are. I hope you can see my screen, yes?
Yes, please.
Excellent. Right. Good morning, everyone. Thank you for joining the session. My name is Bogdan Gitze. I'll be presenting today the paper on keystroke pattern variability in virtual desktop infrastructure. My colleague Evgenia and Alex, we worked on this paper for quite a while. It was an interesting start. We just wanted to have a look at to explore an idea, and I think we're ready to take it forward. But let's have a look at it first. So I'll present first the context of our paper, just to describe a bit virtual desktop infrastructures and the interaction between systems in there. I'll then focus on the current challenges faced. We'll talk about our actual investigation, the results, and some conclusions and future work. So I think we're all users of virtual desktop infrastructures, whether we use a remote desktop or VNC or any type of virtual connectivity. It's very useful and heavily used, particularly in the last year or so when we couldn't actually access the systems physically. And to be honest, I would say at the moment is the default option for remote access. For those around you, around us, who are, let's say, senior enough to talk about the years when Telnet or SSH were the default option, not anymore. Everybody now prefers a direct connection, a visual connection. We like to click buttons. We like to open menus. We don't like to type commands on the terminal. So we've got a remote desktop application with an input driver, input buffer. Information then is passed on via the remote display protocol through a network driver over to the remote desktop server. There's no magic there. It's a pretty straightforward client-server application. Then the network driver passes it on to the remote display protocol, via the remote display protocol to the session manager, and there is processed in the input buffer by the actual application or applications that are running there. And as we know, we can exchange, we can send keystrokes, mouse movements, possibly even video files at times, and we get the screen interaction from the other end. So this is a pretty standard. There's nothing, no surprises there, no news there. So let's think a bit about the challenges. Now, VDI was designed with accessibility rather than security in mind. When VDI was put in place, they thought, okay, tunnel, one end, the client will have some sort of authentication there. We don't care. The other end, the server, will actually pipe those commands over. In between, fine, we'll encrypt it, we'll secure it. However, if we now draw a parallel with access to the actual terminal, to the actual device, if we think of a data center, the physical access, or to any type of server, physical access is heavily restricted. You can't just go in and start typing on a terminal. Unlike remote connectivity, where there is no control over physical access. So somebody accessing the remote application will be allowed on the server with no further checks. And quite often, for convenience, some of the solutions will actually cache the credentials. So all we need is just to click an icon and access to the server will be immediate. That's not good. That's clearly not good. So somebody taking hold of the device will be able to access these remote servers. So the solution is to employ some sort of additional authentication. I'm not against passwords, but passwords we all hate to type, especially when they become longer and longer. So ideally, we want to use some biometric authentication. And the easiest one and the most transparent one is keystroke authentication, I would say. Yes, of course, we've got a face, but that would require having a camera on the device, having the right lighting, and so on. With biometric, we all have a keyboard, so we all can monitor that. There are, however, some data collection challenges. So if we think of how keystroke works, the most important part of keystroke is recording the key presses and key releases. And the problem with VDI is that it does not accurately deliver keystroke timing. So basically, keystrokes as part of a VDI will be sent in a packet as an event. I'm not a very good programmer, so I'm not going to go down the route of explaining the system calls. But essentially, they're being sent in bulk and they're being processed by the remote system as they come. So timing will be entirely affected. Basically, if there is a bit of congestion in the network, if there is any activity, it'll be all gone. And there are no mechanisms to authenticate in the remote application. So me on the system, on the remote system, I will have no means other than that username and password. So essentially, my only choice for applying biometric authentication is to apply it in the server as those keystrokes arrive. So the purpose of the paper and the purpose of this investigation is to determine whether the keystroke pattern is affected by network impairments or dynamics. So we created an environment to input and collect keystroke accurate timings and analyze the variability in the keystroke dynamics. Basically, we pre-recorded some sequences of key press and releases, grouped in profiles. Then on the client, the driver, there was a driver that was used to input these pre-recorded presses and releases, remote access using one of the RD remote desktop protocols. Then on the server, we record the timing of arriving keys, press and release. So basically, we input the ones that's in the client, and we read them at the server. There is the reason why we preferred to input them pre-recorded was to have control over the repeatability of the experiment. Okay, so what do we actually record? What do we need to look at? And I'm not going to do a biometrics 101, but essentially is the 4 events. So is the 4 features: press release time, so hold time for a key that defines the key that the time it remains pressed. Press, so the time interval between 2 successive keys. Release, time between releasing 2 successive keys. And release press to figure out the interval between releasing and pressing 2 successive keys. So essentially, I've got 4 events. I've got key number 1, press, release, key number 2, press, release. But the way they're actually happening in time, they could overlap, they could fully overlap, and so on. So there could be variations of that. So this is why we record all 4 features, and we look at them as a quadruple of data. So the last one, I just wanted to clarify. You would say, well, if you've got 4 events, 3 of them should be three features should be enough. But because there is a bit of independence between these, that's why we prefer to record all 4 of them. Okay, so what were the actual experiments? We played a bit with network latency, so it generated some cross-traffic and emulated congestion. Then transmission of files from remote desktop to the host, so we provided some concurrent bursted traffic, some congestion. We watch also the video on the remote desktop, so concurrent CBR or YouTube traffic, congestion, and significant RDP activity due to the screen dynamics. This is very important because ultimately watching a video does not impact that much. I mean, downloading a video, that will just go rather smoothly onto the server. However, because of the way RDP works, we're actually sending this video through between the server and the client because the actual video will be rendered on the client's computer. Okay, so we've got these experiments, which I'll list in the next slide. And what we wanted to do was to calculate the Euclidean distance for each scenario. So we've got experiment 1, baseline, no competing traffic. So that should give us a Euclidean distance of 1. Experiments 2 and 3, increasing traffic with limited congestion. Experiment 4, sorry, that should be the other way around. Experiment 4, same as experiment 3, plus competing RDP traffic, mouse movement. 5 was high congestion, so it basically rammed lots of traffic into the pipe. Then 6 and 7, we had some competing bulk transfer, just a file download, and competing video traffic. And for 1 to 5, we wanted to place a significant restriction on the actual communication link. So we restricted that to 1 megabits per second. For 6 and 7, we had 100 megabits per second. Results, I realize I'm slowly running out of time. Sorry about that. We've got the amount. So just I'll work a bit on them. This is the amount of traffic introduced. So we pushed it quite a bit up to 115 packets. This was basically pushing at 1 point something megabits per second of traffic. Then we had a bit of mouse movement, copying file, and watching video. And this is the most important part, the Euclidean distance. And we can see that we are having quite a bit of variation here. So as we see packet loss increasing, the Euclidean distance is also increased. We couldn't monitor packet loss for the last two parts because there was the network was not restricted. So it was a bit more. There was no significant packet loss there, but there was competition from the competing traffic from the video and from the file download. Okay, so what do we conclude? Well, if we just increase a bit the channel load up to some congestion, no effect on the biometric pattern. So we're not affected. The actual keys arrive in order at the other end, and we can still perform biometric authentication. Significant congestion leading to packet loss affects significantly the Euclidean distance. So the moment we start seeing packet loss, there's an indication that packets have been buffered, that packets have been delayed. So the time in between packets will be severely affected. If you think of it, if I send two keys and the sending is in real time at one end and they end up being buffered at the other end, the actual distance, the spacing between them will be just dependent on how quickly the receiving system can process the arriving packet. So it will be almost at operating system speed. Video, as I said, affects the pattern significantly due to the additional traffic. So we've got video broadcasting, which is optimized for reducing bandwidth. It's very well done. However, VDI was not designed for sending for video broadcasting. It was designed for sending almost static images. So its ability to adjust to a continuous, to a dynamic video is not very good. And ultimately, as we've seen in the previous slide, packet loss is a good indicator of high impact on Euclidean distance. And I'm guessing, I'm anticipating some of the questions. The future work, we need to actually look beyond Euclidean distance. We need to look at the efficiency of keystroke authentication algorithms. So we need to look at, okay, we measured whether the profile is affected or not. Let's see whether the actual authentication algorithm is affected or not. I apologize for slightly running over time. Thank you very much. Any questions?
Thank you very much for your presentation. Please, if somebody want to ask something.
May I ask a question?
Please.
Please.
Maybe I wasn't very attentive, but I didn't hear. Where did you place the software of this keystroke authentication? On the server or on your home computer? Thank you.
That's a very good question. So we couldn't, the actual authentication, we haven't played at all with the authentication. So this would be the next step. But the authentication cannot be set on the client. The client is a very thin client. All we have is remote desktop. So the authentication needs to be on the server. This is why when keys are being sent over the network, their timing will be affected. So the biometric authentication will be on the server, will be on the remote system. And this is the next step. For now, we just collected keys at sending and at receiving, and we compared the timing. Does that answer your question?
Thank you.
Thank you very much.
May I ask some questions to you?
Please.
As I understood, you used the delays between different press on case.
Correct.
Then, if you are going to identify some person by that info, you should take in account that some person may use different keyboards. Some keyboards may work well, some may work not very well, and we have different timings then.
You're absolutely correct, and there are plenty more challenges to go. So for now, we took a rather let's say we didn't want to create too many problems. We just said, right, let's just assume a profile will be a user using the same keyboard, the same system. You're absolutely correct. I mean, if I just type on my laptop or on my work computer, because of the electromechanical characteristics of the keyboard and the bounciness of the keys, I will have slightly different results. But to begin with, we just wanted to see, let's assume that we use the same system. Will it actually work, or will the profile already be distorted? And to my mind, it is a bit distorted. I think that the opportunity would be to change the biometric authentication systems to account for this distortion, particularly for the remote authentication. But your question is absolutely valid, and this is something that needs to be explored even for local systems, even for systems when I log in and I might have a mobile profile. Thank you.
Thank you for answer.
Thank you.
Thank you for your presentation and answers. If there is no any other questions, we will go to the paper 78, a conceptual model of EOT laboratory. So authors of this paper, please, you have possibility.
Hello everyone. Can you see my presentation?
Yes, please.
Okay, let's start. I would like to present our work. It's a conceptual model of IoT-based laboratory for study electrical engineering and electronics. And today we know the Internet of Things include in our life, and we go into full automatization of our life, yes. And my idea of IoT is give the physical static objects some intelligence, and then they can decide, or devices or things can decide some everyday problems. It's my idea of Internet of Things. And this trend not bypassed the learning process, and this tendency is growing, and day per day we watching or see some topics about remote laboratory, IoT remote laboratory, when students can use real physics equipment without physical visits some laboratories, and it reduce of the workload but not reduce the quality of training, because students working with real equipment. But are two ways of these laboratories. First way, it's a remote laboratory. Can you see my drawing now? Can you see what I draw or not?
Yes, we see.
Okay, it's first case when we talking about only remote laboratories is with IoT, and second case it's about smart laboratories, but in these laboratories, students work in class, but class IoT devices, for example, smart devices can control temperature inside rooms, can control projectors or heating or conditions, yes, but not control, for example, equipment of trainings, yes. And we propose it, or we see that how to solve this problem, combine two ways. It's first way, it's a remote laboratory, and second way, it's classical laboratory, we propose to combine two these ways in one laboratory. It means combined remote laboratory and regular classroom for practical trainings. It's one case. And second case, this laboratory can be controlled, can control all equipment inside this laboratory. It can be stands, training stands, or, for example, condition system, projects, and another equipment for help learning process. Not, for example, stands for study, but additional equipment. And it will be very complex system, yes. And for management of the system, we propose to use artificial neural networks, and for protect all data flows and all smart things, we propose to use this artificial network tool, because if you know, it's very big problem for protecting smart devices, because you can't see is some problems with this device or not. You can see this not in time, as like in your computer, for example, if you get some messages from antivirus, yes, you can detect some problems after some time, and it will be a big problem. And for detecting for some requests from some network packages, yes, we propose to use artificial networks. And here is base structure. This structure divides into two big parts. First part, it control electrical system, which control, for example, smart this part, yes. It's system control, for example, condition, projector, lightnings, control of PCs, because we're talking about classic laboratory, yes, where are PCs with stands, and this system control each, for example, PC, each condition, each light, and another parts of laboratory, yes. And second part, it's control of training stands. It's where students study some electrical parts and make experiments, and all these processes controlled by local IoT service, or in other words, it's foggy foggy computing, yes, when we have a local server where implemented many web servers, databases, and some software of analytics and neural networks for control, for collecting data, for analysis data, and for another functionality. And yes, it's about control equipment system, and and last part, it is global IoT service. We discussed today, not today, a few days ago, about what the service we can use. It can be own service, can be Microsoft Azure service or ThinkSpeak service. But today it's not clearly what the service we use, because the main problem is combine all these parts together. After that, we start to go into this part, because main problem is main main step, it's local IoT service and control subsystem for electrical equipment and control of training systems. And here it's a description of control subsystem of electrical equipment. Its subsystem can control projector, condition, and smart light in its general purpose, but it can be changed according to the wishes of lecturers, for example, if or for wishes of students, or wishes of faculty management. And each device in control subsystem of electrical equipment has a smart meter for measuring energy consumption, yes, has some relays for control, for example, switch off, switch on, standby, because it can be different devices, and what the relay we need to use, it depends from this object. And all this smart meter relay, and for example, on this picture, it's projector, can control it by Raspberry Pi microcomputer or another device which has access to, which has possibility to transmit data to server by wireless communication or by cable communication. And second part, it's the subsystem for work with education stand. For this system works in similar principle as like this system in case of electricity measurement, yes, because it has two smart meter and relay for controlling, and stand consists with PC, because PC for collecting, for reading data, it can be used Arduino board or another board for converting some signals, digital or analog signals, into digital format, and stand, for example, for training. In this case, it's stand for investigating direct current, and this inside one this case can be many this substance. Can be not only one circuit, it can be 2, 5, or more circuits which can be connect to real PC.
Alexander, you have a time limit, so
okay. And about IoT service, IoT local service, and global IoT service, all you can see all functions of local IoT service. It's collect data, analyze data, databases for data for about users. There is neural networks, software for analyzing data, and for managing users' accounts, yes, and for remote control. And global IoT service have only 3 parts. It's collect data, and it's mistake. It must be user data and only pre-experiment result. Here is some proposal of stand of to investigate direct current. It's only one of many stands. It's only from this stand we will plan it start, yes, because we have this equipment, and it's how to make students experiment and concept of user graphic interface. It's one idea, it's main idea. We have, for example, experiment in laboratory, experiment outside laboratory. And if students want to run the experiment, if stand is busy, all these parts will be not active, and you must go to your account and make order to next experiment, for example. And after that, you can continue or can shift this experiment to another experiment. And it's proposed equipment for controlling electricity parts of smart laboratory, for example, for PC, and it's control for PC, and smart meter for measuring power consumption, yes. And here is some scenario, because I haven't more time, how it works. Smart projector, for example, it can work automatically and upload and download presentation and show presentation before class start, for example, in time. Yes, or it can have possibility to direct uploading presentation, teacher presentation in classroom. And about conclusion, we proposed the conceptual model of training laboratory based on IoT, which combines the function of remote laboratory and regular classroom for practical classes, describe the general structure of this system and some basic modules and how it works, and describe some scenarios of working of equipment, and in future we plan to implement the first step. It's implement in local IoT service. It's artificial network, neural network for detecting, for controlling all equipment, and after that control the requests inside the network. And acknowledgements we sent for Ukrainian German Education and Research Center of West Ukrainian National University for the opportunity to use their training laboratories, and support from the Internet of Things project for the provided equipment for measuring stands. And thank you for attention and waiting for your questions.
I'm sorry, I need to make on my microphone. Dear colleagues, please, if you have any questions.
I have questions.
Please, please.
You don't speak about prototype of our laboratory. Our work have prototype or no? Answer, please.
Our laboratory or previous works, for example, what we analyze.
Next question. What is the advantage of your electronic experiments versus experiments in circuit simulator package such as multisim?
I understand. Yes, it's a hot question and hot topic. But I think maybe it will be, because it's concept model, it's concept, yes, and maybe it will be the experiment for students will be consist of two steps. First step, it's simulating on multi-sim, and next step, similar experiment on real equipment. Why not only simulation? Because I saw many problems with simulation when students make the circuit, make some devices in simulation mode, run, check all errors, for example, and after that they try to implement in real equipment, and they have some problems with implementation. Always simulation and real implementation have some problems in this way.
Mhm.
And better, for example, watching what happened inside a real circuit, yes, than what happened in simulation mode. Simulation mode is good for catching some errors, for understanding all processes, but real simulation, real equipment, it's more better for understanding. And you see what happened inside.
How many experiments of electronics you planning in
Planning,
your laboratory?
for example, if we're talking only of electronics, we're planning 10 or more only experiments for electronics. For example, for the direct current, alternative current, and parallel connection, serial connection, and else. We're planning stands for investigation for DC motors and for AC motors too. There will be many stands and experiments, because each stand one experiment or two experiments, because it's IoT, we can change logic of functionality.
And last question, how many people can perform a particular experiment and at the same time?
For example, if one, let's back to my presentation. Here, yes. It's only one stand. For example, wait a second.
And
it's PC, yes. For example, it's only one stand. Here can be another stand. If user occupied the stand physically, yes, it user sit near computer. Another student can't occupy this, for example, a remote online, but he or she can occupy another stand in one time. Is it clear?
Thank you. And what voltage meter on this right of this picture? What this meter can meter?
You talking about
it's short.
This
short cap.
I'm not understanding. You're talking about this part or this part?
Right
part. Yes.
Right voltmeter.
Yes.
Short wire.
Yeah. Yes, it's general voltage in the circuit.
Oh, thank you. Thank you.
Thank you for your answers. We have a question in the chat from Evgenia Kuzminych. What is the novelty of your proposal? Maybe theoretical novelty.
Theoretical novelty.
She is right that you speak about commonly practical applications.
Yes.
If your paper is only practical, it's understandable. But if you have theoretical novelty, please describe.
It's closer to practical implementation. About theoretical novelty, I can't say now about it because we not implement, for example, 5. Because 2 stands, it's not good for analysis. If we implemented, for example, 5 or more stands, we can talking about managing of system. We can talk about performance, about some theoretical novelty. But now, about theoretical novelty, I can't say nothing. Because it's more practical than theoretical.
Okay, thank you. If there is no any other questions, so we will go to other paper. In our schedule, the next paper should be 80, improvement of grayscale images. So authors of this paper, I give you a possibility to present.
Thank you. One moment, please. I open tab. Do you see
Yes,
my presentation?
Please.
Very well. Then let's introduce our work, improvement of grayscale images in orthogonal basis of the type 2 membership functions. The authors are Lyudmila Akhmedchina and Artyom Yegorov. The one of the serious problems in image processing is the ambiguity on the images. Clear and crisp images don't exist in reality. Real images often may contain complex structured background, full range of brightness levels, areas with low contrast light, stark or and dark areas, noise, blur, various artifacts, and so on. For example, from the left, you may see an example of such real image, the X-ray tomogram of human brain. And it's a histogram. As you can see, this image have a complex structured background here, full range of brightness, areas with low contrast. Here and we can exactly say where is the object of interest here. It is one of the main problems. So the choice of image processing methods depends on the whole of processing and properties of source images. One of the solutions of this problem is fuzzy logic. We have 2 types of fuzzy sets, type 1 and type 2. Type 1 fuzzy sets allow taking into account ambiguity in images. In the same time, fuzzy sets type 2 allow to consider problems with a higher degree of uncertainty, which is typical for methods of image representation and for the image processing algorithm. Here you may see an example of type 2 fuzzy sets description. Fuzzy membership function of the type 2, MFT2, is determined by the difference between upper and lower membership function. On this graphic, you may see here upper and here lower values. Purpose of this work was to study a method for improving quality of the grayscale images based on orthogonalization of MFT2 with singular value decomposition and selective filtering of combined noise usage. The diagram of proposed method of grayscale images improvement. Here, from the left, you may see the steps of our method. First step is obvious, and it is scaling image brightness to the range 0 to 1. After that, we pre-processed image. It is not obvious step, but for most of images, it cannot be emitted. The way of image pre-processing depends on image type and host of processing, and make significant influence on the resulting image. After that, we formed lower upper MFT1 and MFT2. And these functions and source image were the source of making a data set for SVD. After SVD usage, we automatically choose the most significant features from the new obtained space, and based on these most significant features, we formed a resulting image. As about pre-processing methods, we used in this work two methods. First of them is adaptive power law brightness correction, was introduced in this work by us. It contains three steps. As you can see, all the steps is mostly power transformation. First step, slightly decreasing brightness of initial image and deleting brightness value of 1. It is important for next power transformations. This transformation proportional reduct of light stack area brightness, and as you can see, it also may increase the brightness of dark areas. And the final transformation makes a reduction of brightness of entire image. Also, we used local background subtraction. This method contains next steps. Initial image transforming with help of non-overlapped windows. We used 15 window size. After that, we forming the resulting image as difference between initial image and image obtained by previous step. And at the end, we scale resulting image to the range 0 to 1 and perform adaptive histogram equalization. After pre-processing, we formed a lower upper MFT1 and MFT2. As you can see, MFT1 upper and lower was formed by power transformations. Is mostly the same function, but here you can see minus and here plus. So after forming lower and upper function, we got MFT2 as difference and choose the data set for SVD. For different pre-processing method, we manually choose a little different data sets. We made our choice based on brightness of obtained images manually, but it is possible in the future to make it based on some brightness estimation. After performing SVD, we automatically choose the most significant features from the new space. For that, we calculated a vector C based on this formula and setting the elements of C in decreasing order and normalize them. After that, we calculate the vector DC. It contains differences for each pair of adjacent elements of vector C and calculate DC value. by this formula. Based on this DCA value, we scanned elements of vector C for finding such index Imax that satisfies the condition. And after that, we normalize vector DC in such way that element still index Imax plus 1 becomes equal to 1. Based on these significant features, we formed resulting images by these formulas. For final image, we use adaptive histogram equalization or histogram equalization, depends on used preprocessing method. And now experimental results. We used various images for our experience, but here we present an example grayscale images that contains a phosphorus containing alloy. This image was obtained with magnification of 250 on a metallographic microscope GX51 with a digital image analysis system of the company Olympus. To separate the individual phases of the alloy during determining its structure and properties, chemical etching was used at first. After that, thermal etching at temperatures of 400 till 600 degrees with natural air circulation was performed. The atoms that make up the phase interact with oxygen, therefore an oxide membrane of different thickness is formed in different phases. When observing through an optical microscope and in image, the phases have different levels of intensity. It is how this image was obtained. The analysis of this image is difficult due to non-uniformity of the background at the presence of light dark area. Here you can see this area, light stuff. Next, experiment results, preprocessing. Here you can see preprocessing by both of our used methods, adaptive parallel brightness and local background subtraction. As you can see, we got very different results, and here you can see that preprocessing is very important and makes a great important influence to the resulting image. Next, we made MFT2 and lower alpha MFT1 for both of preprocessing results. It is for a parallel correction for this image, and it is for local background subtraction. And the final image you can see here. It is for adaptive parallel brightness correction and by local background subtraction. As you can see, the final images are very different too. When we have some goals of our processing, we may use, for example, this image if we need to find out exact borders of different area, or we may use this image. It has some blur, but it has at the same time high level of brightness. So preprocessing method mostly determine the obtained resulting images. Conclusions. If I say in short, we use some of, I may say, template or the source of family method of grayscale image preprocessing that allows to obtain additional parameters for multidimensional method of the multidimensional information processing, and allows to transform the ensemble of obtained images to the new space of features. This transformation with further automated determining of most significant features allows to achieve higher level of detailing, contrast, and so on. The promising area of other researchers are the usage of different orthogonal information, different pre-processing methods of initial data, and also we may use automatically select data sets for orthogonal transformation. Thank you for attention. Now you may ask some questions if you have.
Please ask questions if somebody have. Please, Professor Fedorov.
What are the reasons for the choice of membership functions?
You are asking about this?
Yes.
Here we formed our membership function. Type 1 base our function is our image after pre-processing. It is a grayscale image, so we have only one feature. After that, we formed upper and lower MFT1, so we have another two features. And in addition, we may get MFT2. It is fourth feature. And of course, we have source images. So we may get up to 5 features. Next, based on the brightness, we may choose the data set for SVD or another orthogonal transformation. We made it manually in this work, but as you can see our experimental results here, what this is image is too bright, and it is not very informative, for example. So we used only images which were not too bright. In the next our works in the future, it is possible to make some estimation of brightness and make this step in automatical mode. But it is the future.
Thank you.
Thank you. Does somebody other want to ask? Please, Professor Stobo.
So you use type 2 membership functions. What is main advantages of use two type membership functions? In fact, in the end stage, you do the falsification and no reasons to have such complicated model.
We used additional function because of we want to use method of multidimensional data processing. If we use only MFT1, then we should interpret as MFT1 our initial images, but it is only one feature. SVD can't work with such data. So we need additional data. We used SVD for visualization of fuzzy clustering results, but here we don't use such method. So we used additional membership function, MFT2. But for obtaining MFT2, the most popular way is using upper and lower MFT1 values and obtaining MFT2 as difference. So for getting additional features, we use all this function. From the calculation point of sight, it is not very hard. It is the usual difference, and it is one transformation, power transformation. It doesn't work too slow even in MATLAB. If it will be implemented in some compiled language as C++, it will work very fast.
Okay, but you can use two simple fuzzy knowledge base. One for upper and one for lower. What is the benefit of membership fuzzy type 2 for fuzzy sets?
As author of this method was told, it allows us to take into consideration uncertainty in a higher level. But if we say it in a more clear mathematical way, if we see on this picture, we can see that here our points of our membership MFT1, our usual membership function, and here and here upper and lower membership function values. So the difference gives us additional information. It may be useful or may be in correlation with other features, but it is not important because we used SVD. It allows us to get our data in a new feature space and to select the most important feature. So even if we got some correlation due to forming additional features here and here, after SVD and this step, we got only a significant feature. We checked this approach on visualization of fuzzy clustering results, and in our previous works, we got good results in this automatically selecting the most important features. So we used it here for the same reasons. So MFT2 is just an additional feature that can give us some additional info about our image. We use it from this point of sight. Have you some other questions?
Yes, if somebody wants, you can ask other questions. So there is no any questions more. Thank you very much for your presentation. And we go for the next paper. It's a paper with ID 87, Neurofuzzy Control System for Non-Deterministic Objects in Real Time. Please, if you have authors of this paper.
Yes,
Please, you can start demonstration of representation.
Yeah, my
See?
presentation.
Okay. Thank you, please.
Okay, hello. Before I start, I want to thank organizers and participants international workshop on computer modeling and intelligent systems. Today, I am going to present a report on paper 87, Fuzzy control system for a non-domestic object in real time. That paper was written by Natalia Maksishko, Mykola Ivanov, and me, Sergey Ivanov, the scientist from the Zaporizhzhia National University, Zaporizhzhia, Ukraine. The whole report contains such sections. One of the methods for construction model control systems is the synthesis of intelligent systems based on narrow fuzzy systems. The peculiarity of systems of this class is the use of neural network and fuzzy logic to control complex dynamic objects that function under conditions of uncertainty and conflict. Uncertainty, in this case, it is existing a lack of information which is necessary to obtain a quantitative description of the process occurring in the system and the complexity of the control object. The use of classical methods, the description of the control system assumes that the control object are described by linear dynamic links of low order. This assumption often leads to the fact that classical control systems in practice do not provide the desired indicators of fast and efficient control. Therefore, the narrow fuzzy control system using the procedures of artificial neural network and fuzzy logic make it possible to identify complex processes both in technology and in economics. The use of neural fuzzy systems makes it possible to solve the problem of constructing control systems in conditions of uncertainty on the basis of the available statistical and experimental data obtained about the control object. It should be noted that the use of only one neural network in the task of automated control has a number of disadvantages. This is how the neural network receives information about the control object in the learning process, and this requires statistic data. Therefore, this disadvantage can be eliminated by using fuzzy set structure, which allow for the formalization of fuzzy variables. Therefore, this article is devoted to the actual problem of constructing a narrow fuzzy control system for non-domestic object in real-time systems. To determine the input components of the narrow fuzzy object control system, the method of system analysis is applied. This method allows you to analyze the mechanisms of interaction of an economic object with the environment. Typical procedures correspond to business processes of non-deterministic discrete objects. The decision to use marketing, resource, and production procedures is made based on an analysis of the degree of competence, in this case, with business processes in an economic entity. This approach combines the advantages of the principle of using typical subsystems of automated control systems and the process approach. However, for automated control systems, it is not always possible to obtain a system of equations that fully describes it. Existing automated control systems are conditionally invariant to external factors. Therefore, the classical structural model of discrete automated control systems is usually presented in the following form. The system ensures the adaptation of management decisions under the quantity of fuzzy input values. The adaptation of the system is provided at the stage of training the neural networks. The neural fuzzy control system is based on the learning process of an artificial neural network, which allows to define the rules of fuzzy interface. This is an integrated model in which a neural network training algorithm is used to determine the parameters of a fuzzy interface system. On the other hand, the learning mechanism of a neural network does not depend on statistical information, but it's standard for the chosen architecture for an artificial neural network. The NFIS model adaptive network with the implementation of the Takagi-Sugeno fuzzy system, which is a 5-layer feed-forward neural network, is shown in the figure 3. The input values of the model allow you to determine the mismatch between the current and planned value of the variable and the output variable is the control action of the automated system. The first layer of the NFIS system defines fuzzy terms of the set of input quantities. The outputs of the nodes of this layer are the values of the membership function for a specific value of the input. The second layer of the system defines the fuzzy rules to be applied. In this layer, each node corresponds to one fuzzy rule. The node outputs are the degree of rule fulfillment, which is calculated as the ratio of the input quantity. The third layer normalizes the degrees of rule exception. MATLAB applied the implementation of a neural fuzzy control system for non-domestic objects. MATLAB allows to create a model of adaptive system of neural fuzzy interface as well as perform its training is shown in figure 4. At the fifth generation stage, membership function are selected and the parameters of the fuzzy interface system are determined. In this solution, Gaussian functions are selected, which allows visualization the input and output membership function of the fees shown in figure 5. The next stage is performed by training the network where the hybrid method is selected, which is a combination of the least squares method and the inverse gradient decay method. Also, the number of training cycles supports is set equal to 100, followed by the testing procedures. The obtained test results confirmed the possibility of using the neural fuzzy models in NFIS. The structure of the constructed neural fuzzy model NFIS is shown on this page. To study the NFIS model built by the neural fuzzy models, the building MATLAB procedure was used to use the rules of the fuzzy interface system. In addition, MATLAB obtained control surface of the neural fuzzy model NFIS, which is shown in the figure 8. To analyze the results obtained, the following values of the input variables were set. This is statistical value of the demand for goods on the market for the year 1 multiply 10 exponential 5, and the optimistic scenario 1.04 multiplied 10 exponential 5. To obtain this result, the control effect on the production of goods in the NFIS system will be equivalent to 1.07. multiply 10 exponential 4. The article presents a technique for implementation a narrow fuzzy control system for non-domestic objects using MATLAB. MATLAB made it possible to create a solution for an adaptive system of narrow fuzzy interface, as well as carry out procedures for its training. The paper presents the results of the work of an adaptive narrow fuzzy control system for non-domestic object. Thank you for your attention.
Thank you for your presentation. Please, if you have questions, Professor Fedorov, please.
What learning algorithm did you use?
We use algorithm Levenberg-McWatt because it have great advantage in speed of its working.
Thank you.
Professor Shtova, please.
Thank you. Can you show slide number 10?
Yes, of course.
So, as far as I understand, there are only 12 data points for training.
Yes.
Is it all? Yes?
It is. We use 2 data points. It's about sales of goods, good results and the bad results, and we input in our model and get our production or in out.
But here, the training data set, the length of training data set is 12. So, and you try to learn fuzzy systems, and the number of training parameter is much is more than 12. How did you train in such condition and using so complicated Levenberg-McWatt methods? It's impossible to train. For example, on the upper of the slide, there are 3 membership functions. So we have 6 parameters, tuning parameters for one input. For the second input, also 6. In total, 12 parameters, tuning parameters. Also, minimum 3 rules. This is a Sugano fast type or zero type model. If fast type 3 multiple 3 9 parameter plus 12, we have in total 21 tuning parameters and just 12 data point for training. It's impossible to train.
Yes, I understand what you mean. But in economic systems, there are some situations when you have no enough statistic data. And when you use this algorithm and narrow fuzzy networks, it can apply you some effect and give you some output, even if you have not enough statistic. So it's
what it's a mistake. It is a mistake. It's impossible to train 21 parameters using just 12 data points.
We talk about the system in real time that contain information flow about cells. So in this system will be rather more statistic data for training.
Okay. Do you have a testing data set?
In our work, we have, yes.
You have what is the result of testing the model on the testing data set?
The result is shown by
No, it just surface. It's not it's not checking on testing data.
It is in our work, if you want.
Thank you.
Thank you. Somebody other questions?
May I ask one question?
Please.
I have a general question regarding uncertainty. You said that uncertainty is a lack of information. So, are there any mechanism in fuzzy sets and fuzzy neural networks which can compensate this lack of information?
Yes, thank you for the question. Often in economic systems, we have no much information about our process, and we need to get some management results. And in our model, we can have not much statistic variables, and we can use variables in different parts. So we can get results without many information and many analysis of it.
Good, thank you.
Thank you.
If there is no any other questions, so thank you for your presentation answers, and we will go to the other paper. It's 89 paper, local quality improvement of multispectral imagery classification. Please, authors of this paper, if you're online with us.
Yes, hello, dear participants. Do you hear me?
Yes, but we do not see your presentation.
Yes, it's one moment.
Okay, we see. Please.
Okay, and my name is Irina Pestova, and I'm a senior researcher in Scientific Center for Aerospace Research of the Earth. And the topic of my presentation is local quality improvement of logical location of multispectral imagery classification with radiometric spatial feedback. As you know, classification is the process of dividing a mass of data into classes, groups, according to some criterion. Classification of satellite images is a widely used remote sensing tool for solving such tasks as land cover mapping and change detection, forecasting gas and oil potential of subsoil plots. When carrying out any classification, some obstacles affect the quality and accuracy of the classification. And we can separate them to radiometric obstacle and the spatial obstacle. This study presents tool for solving the problems described above, applying a hybrid approach to classification to correct radiometry and the spatial resolution equalization of multispectral satellite images. The hybrid approach of classification is applied to form of interpretable and objective classes is shown in this slide. This approach to classification implies subdividing training samples of expert selected classes into objective clusters by unsupervised classification. After that, format clusters are used as training samples for supervised classification. These steps are aimed to reduce accuracy and subjectiveness of the selected samples. In turn, it increases the classification accuracy in comparison with both supervised and unsupervised types of classification. In the other way, it is very important to carry out the spatial resolution equalization procedure when satellite images or separate image bands of different spatial resolutions are used together. And the first is the scanning pattern. When the near neighbors oversampling procedure generates four identical subpixels to improve the overall physical resolution of the image bands, but not degrade the quality, it is necessary to correctly distribute the signals in these subpixels while maintaining their average geometric value. It should be done using the scanning window and taking into account the adjacent territory that is the nearest 8 subpixels around the current one as shown in this figure. For the correct spatial redistribution of subpixels, it is necessary to analyze the topological properties of the main classes and obtain appropriate topological description. Multiply value logic methods are used to solve the problem and change the subpixel class according to the relationships and classes of the nearest surrounding subpixels. 5 significant types of the relative location of subpixels of one class are defined in these figures, and a logical function is used to decide on the replacement of the central subpixels class. According to this function, the central pixel change its value if the function value is 2, and not change if the value of the function is 0. Changing the class of the central pixel requires additional analysis if the value of this function is 1. The hybrid classification method described above requires high-resolution source images. In turn, to increase the resolution of the bands of a multispectral image, stable clustering is required, which is based on the spectral signatures of the Earth covers. This leads us to the solution of using radiometric spatial feedback. This method is an iterative process described in the slide, and this iterative process continues until the spatial resolution of the bands is increased. As soon as the increase becomes insignificant compared to the previous iteration, the process stops and the final classification is carried out. And this is the test. The study area was located around the city of Novomyrhorod in Kirovohrad Oblast. And here you can see in this study, we focused on 7 land cover types, namely artificial surfaces, rocklands, tree-covered areas, grasslands, wet grasslands, wetlands, and water bodies. And in this slide, you can see a characteristic of the input data. It were sentinel to a satellite imagery, and you can see the spectral indexes which were calculated and used in this study. And the next step, guided by the data flow diagram described in slide 5, a 2-iteration process was carried out, which includes two grid classification blocks, two blocks of spectral bands, spatial resolution enhancement, and the final classification. The results of evaluating the spatial resolution of spectral bands after the second iteration using the age spread function are presented in this table and show a steady increase of spatial resolution in bands from 5 to 7 and 8A. It is assumed that the more stable increase of the spatial resolution in bands 11 and 12 can be achieved after attracting additional spectral signatures for reference clustering. And the next, you can see an illustrating of the multispectral image classification local quality improvement. In the presented test section, you can see that the class divergence has increased, as a result of which there are no obvious errors in the final classification when the pixels of the artificial object class appear in the middle of the field class. All linear extended features, such as forest belts and roads, retained their shape and got rid of distortion caused by larger pixels from bands with a lower spatial resolution. And a conclusion, the work presents a solution to a geometric obstacle by using a hybrid approach to classification, as well as a solution to a spatial obstacle by a spectral resolution enhancement of lower resolution spectral bands. And further research should be aimed at developing an algorithm for determining the most appropriate clustering methods for each particular class. And thank you for attention.
Thank you for your presentation. Please, if somebody wants to ask a question, you have possibility. Generally, for me, this study is interesting, but general question, you have only, how to say, method and software, but not own hardware to provide such measurement. Is it true?
Software, hardware. What do you mean?
I mean that you use for this study only that data obtained by other people, not by your own specific camera. You have no own camera to make such observations.
In this study, we use satellite imagery, but we can use some imagery from drones. In our institution, we have a drone, and we can use this method with other.
So you have own hardware too.
Yes,
so
yes.
My other question will be for this hardware. Maybe it's not strongly related to this paper, but maybe you can answer. Is it possible to use such a multispectral camera not only for how to say big land parts or land areas, but even for how to say like photo camera for real people? For example, is it possible to use this camera not from drone but from your hands to make hyperspectral photo of any small object, for example, computer, fruits, etc.?
Yes, you can use this camera for any application. If you want to photo your room, you can do it, but we create our methods for big areas and for using a large data.
Okay, thank you. My question was not related strongly for your paper, but it's my own interest.
Okay, you can contact us, and we can speak about this, about our data. And
thank you very much. These applications, how to say, equipment should be used not only for observation of landing, but also for different tasks. For example, for classification of garbage, because and many ecological tasks should be related with such hardware and many other engineering applications. So your method is interesting, and maybe it can be used not only for classification of plants, but also adopted to other problems. If somebody, yes.
You can classify any textures what you need. We provide this number of test results because we know about plants, about tree, about grass. But if you want to classify garbage or some ecological disaster, you can use this method, only choose other classes.
Okay, thank you. Maybe somebody other wants to ask something. So if you have no any other questions, thank you very much for your answers and your report. And our next paper, it's 92, Synthesis of Spherical Object Configurations. So authors of this paper, please, you can show your presentation. We don't hear you. You need to on your microphone.
Oh, thanks.
Okay,
I'm ready.
please.
I will try to open my presentation. Can you see?
Yes, so please.
Good afternoon, dear participants of conference. It is proposed the work synthesis of spherical object configurations, models, and information technologies. I am Alexey Kartashov, and my co-authors Kirill Korobchinsky, Irina Yakovleva, Olga Yarovaya, and George Yaskov. The authors represent three scientific and educational institutions of the faculty. Name is institution given this. The work continues the research of the Scientific School of Academician Professor Yuri Stoyan. We are talking about creation or synthesis of a new object from a set of spatial geometric objects that meets certain requirements, restriction of properties, and would deliver an extremum according to certain quality criteria. On the slide given some practical areas of application, application of a more general problem in general spatial configuration. In this article, we will restrict ourselves to a class of spherical geometric objects. As example, however, the results obtained can be generalized to broader classes of features of objects. A significant number of publications indicate the importance of the problem spatial synthesis of spherical objects. And in our work, this is linked to a review of works devoted to this topic, containing more than 60 references. Problem statement, the main statement, no, first of all, it's modeling, and next it is one of most part of our work is information technology. And main aim of the work is using modern information technologies, which allow automatically designing model of optimization problems and their subsequent solving by specialized software packages. Special attention is paid to combining optimization and interactive visualization blocks into a single computational process. The present technology allows a decision maker to change the current configuration interactively. This instrument is important since most of the problems under consideration are incomplete, and there are no methods for treating them guarantees finding the optimal global solution. So first of all, about modeling. All modeling special objects in our approaches is based on a function that describes the boundary of the spatial object in question. In this work, we write only about spherical objects. So on this slide, first lies it is this function. This function in which V1, V2, V3 is center coordinates of sphere, R is radius of sphere, and we can for any arbitrary point, if we this point set into this equation, if equation will be equal to 0, it means that this point lie on frontier of objects. If this equation less than 0 strictly, it means that it is interior point of the objects, and if greater than 0 strictly, it is point not belongs to the object. On base this model, we can construct optimization synthesis problems, and this problem contain as some restriction as objective function. And the most restriction, it is binary relation between pairs of initial objects, and the main binary relation is non-overlapping and inclusion. Non-overlapping, it means that two objects don't have the common interior points. And inclusion, it means that one object belongs to other. On this slide, present various type of constraints for optimization problem of synthesis of spherical objects. The type of this constraint are specific to the problems with different type of spatial objects. But on this side and in this work, this shows analytical model model this constraint only for spherical objects. It is all analytical models. On next slide, similarly, this slide provides analytical view of the various objective function for the spherical configuration. combination on various combination of constraints, objective function, and binary relation matrices generate many classes on configuration synthesis problems. These classes are given in our work. On base this approach, it will do information analytical model of configuration synthesis problem. This model includes data structures for storing objects themselves, their relations or constraints, and objective functions. Also, this model contains tools for visualization, some configuration, and models for optimization, so optimization block. And this model provides data conversion between all these parts. On base this model, it is proposed iterative process to optimal configuration systems. First of all, first step, it is formation or creation initial model. After this model using to obtain local optimum, it is block. In our work, we use EPOPT, such tools for solution of optimization problem. After this, we use block for visualization. In our work, we use 3D Max Studio. And using this visualization, as a result, decision maker, including in this process, can change this solution, and it can change it using immediately interactive graphical environment and associated numerical parameters. And if it changes will do, we repeat this process. On next slide, this information technology doing more detailed forming initial structure and inner structures, synthesis special configuration to solving optimization problem, visualization, processing the current result, and analyzing by decision maker. If decision maker change this obtaining solution, these changes return as initial point to a block of optimization. On this slide is given some example of this process for spherical objects and for one of problem synthesis. Left pictures is initial locally optimal solution. Next, its decision maker change its solution, and this is from this initial point was obtained new improved configuration. It is next new any local optimal solution. Conclusion. This paper proposed models and methods for solving optimization problem of synthesis spatial configuration based on spherical objects. This approach based on concepts of geometric information and configuration space. It is proposed information technology for iterative search of solving such problems, and main part of this technology is involving into this process using tools for visualization involving decision maker, and this allows the use experience and intuition, decision. So that's all. Thank you for your attention. Great question.
Thank you for your presentation. Please, if somebody wants to ask a question, you have possibility. So I will ask, what the main application area of such technologies, for which practical problems it should be used to resolve an effect for practice?
First of all, this approach, these problems of for general spatial configuration, it is many practical areas as transportation, storage, logistic, aerospace, object layout, security fuel, and many others. And this approach is may be used for general such problem. But if we can say about spherical objects, this has interesting practical problems as 3D printing techniques, because some of elements of this 3D printing has a spherical form. Next interesting example is in medicine, when we can radio medicine, when the beam, radio beam must be minimal intersect in human body. And of course, it may be technical problems in which we can transportate some technical system, spherical form. In particular, it may be, and we have some problems in space as a Sputnik. Thanks.
Thank you. If there is any other questions. So thank you very much for your presentation and answer. And we go to other paper. It's paper 93, self-improvable computer system model and architecture based on reconfigurable hardware, automatic design and synthesis tool, and artificial intelligence technologies. If we have authors here, please, you have possibility.
Good afternoon. Can you hear me?
Yes, please, you have possibility to demonstrate your presentation.
Yes, I'm trying to share my screen.
Okay, we see. Please.
Okay, so my name is Victor Melnik, and just a moment, I would like to minimize this thumbnail video. And I would like to present a report, Self-Improvable Computer Systems, Model and Architecture. And we are two authors, me and my colleague Anatoly Melnik, representing two institutions. It's Lviv Polytechnic National University from Ukraine and John Paul II Catholic University of Lublin from Poland. The agenda for today's report is following. First, motivation, state of the art, the objective, the idea, directions of self-improvement, the main hypothesis. And then I will show the proposed approach, the hardware basis, methodological basis, and the software basis of the self-improvable computer systems. Finally, we will discuss the expected benefits and conclusions. So first topic will be state of the art and motivation for this research. And we will start from the application-specific processors, the design of which is one of the basic directions of development in computer engineering today. And one of the reasons for this is that they can provide high performance at low energy as compared to universal processors. The characteristics of performance and power consumption and the size, of course, of ASPs dominate universal processors by 2, 3, or even sometimes 4 orders of magnitude. And it becomes possible due to taking into account the features of the algorithm and its hardware implementation in ASP design. Here on the chart, we can see that ASPs are even deployed in a significant part of supercomputers, and this part is has a tendency to grow. There are numerous research on the topic, and one of them is cited here. You can find some background of the application of application-specific or specialized processors in universal high-performance computers. Another chart here shows the trade-off between the characteristics of flexibility and performance between different types of processors, general purpose, dedicated processors, custom processors based on configurable hardware, and application-specific processors. The challenge of the application-specific processors is a large cost of production as custom chips. As we can see, application processors have here highest performance among these types of processors. So the solution would be to implement them on a base of configurable hardware and to create so-called reconfigurable computer systems. Some word about the latter. So these are the types of computer systems where some reconfigurable chips or some reconfigurable integrated circuits are used as computing nodes. And today, such devices are produced as in the form of field programmable gate array application integrated circuits. These computer devices have also, and reconfigurable computer systems as well, have also several challenges. The challenges are the need to balance computational tasks among the general purpose processor and reconfigurable environment. Second one is the need to design application-specific processors or soft cores to be implemented in this reconfigurable environment. And the third one is that these systems are only effective for certain classes of problems. And this latter one is unsolvable with the currently used or conventional model of computations. In order to solve all these challenges, we propose to use to build, yes, and to use new computational models and to build the self-configurable FPGA-based computer systems. More information about that topic you can find on one of our web pages is 3W self-configurable.com. There are several articles on that and some basic information about this kind of computer systems. So what would be the next step after creation of self-configurable computer systems. On our opinion, it would be creation of self-improvable computer system. And the reason for this is following, that today is very large number of computer systems utilized by billions of people in the world. And it is very important to improve mentioned characteristics of computers, especially in terms of power consumption. Also, in the last years, there is a new direction of development of computer technology. This has emerged on the junction of reconfigurable computing and artificial intelligence. This is called with the term evolvable hardware. The objective of our research is to estimate the possibilities of creation an architecture of self-improvable computer systems which are able to independently improve their technical characteristics and functionality. We believe that the self-improvable computer systems can serve as a new basis for future developments of the evolvable hardware and will make a significant progress in the development of computer technology at all. The basic directions of computer system self-improvement we consider as following. The first is increasing the efficiency of equipment use during operation. Second one is reducing the power consumption also during operation. And self-improving of some other technical characteristics, general technical characteristics of computer, like accuracy of computations, dynamic range of process data, etc. The main hypothesis of the study consists in following. We are talking about the universal computer systems, which deploy also reconfigurable components, executing application-specific computations. The mechanisms of self-improvement in their architecture should provide an opportunity at the stage of their operation to greatly improve the efficiency of equipment use or to reduce the power consumption on the classes of algorithms. And on the following part, we will disclose our approach proposed in this actual research. A hardware basis or the processing core for self-improvable computer system consists of a universal or general purpose processor and a reconfigurable environment with some additional modules in order to organize the operation. The latter one provides the ability to specify the initial structure and functions of the computer system and their further changes to improve technical characteristics. Methodological basis of the self-improvable computer systems consists in new methods of high-level automatic design of specialized processors, new computational models, including that one that uses principles of self-configuration as a basis for self-improvement, and modern computational intelligence technologies different. Some prerequisites for self-improvement of the computer systems are following: the knowledge of technical characteristics that need to be improved, knowledge of ways how to improve them, ability to measure or to acquire the values of current technical characteristics and compare them with previous values, availability of hardware and structure, the structure and functions of which can be changed, and availability of methods and means for self-adjustment of the structure and functions of hardware by the computer system for self-improvement. The basic components of the computer system which will ensure the ability of its self-improvement are following. These are the information base of technical characteristics to be improved, the algorithms and software to improve the technical characteristics, the specifications of tasks and the corresponding descriptions of hardware configurations for them, the processing core of a self-improvable computer system, the software tools for self-configuring, tools for measuring technical characteristics during execution, and a set of artificial intelligence software to improve the technical characteristics of the computer system. On this slide, we can find a figure with the high-level architecture of the self-improvable computer system. It consists of several modules. We can find here software and hardware modules. So there are software tools for computer system self-configuring, the processing core. So the first one is it is used in order to create the configurations for the processing core. Then also we see here the processing core that executes the tasks. Here we find the means of technical characteristics acquisition and artificial intelligence software that improves the characteristics and the information basis that is used to store the needed software and information base. Okay. Here aside, we see the operation model of the self-improvable computer system. The operation model described consists of number of steps to automatically create a hardware configuration from the user program. User program is on the input. The configuration is created automatically here. And then after the program configuration is created, it's automatic acquisition of the configuration, then program execution, and afterwards the iterative process of the self-improvement begins from storing of the characteristics to information base, a trial to improve them, a new specification generation, and a change of configuration. And afterwards, again, comparing new characteristics with the previous one and decision-making on improvement. The details of method of self-configuring in the self-improvable computer system is shown here on the slide. It defines operation of the corresponding software tools for creating of configurations. The artificial intelligence technologies which are used or which are supposed to be used in the self-improvable computer system are self-learning technologies. These are also mechanisms of expert systems, computational intelligence technologies like neural networks, genetic algorithms, etc. Collective intelligence technologies also. Regarding the software basis of self-improvable computer system, the most important component of them is specialized processor high-level design tools, which enable automatic creation of hardware configurations and independently improve the efficiency of hardware use. On the chart here, we can see how we can choose between different designs of FFT fast Fourier transform processor with a constant performance but different number of arithmetic logic units. And corresponding changes in latency and the frequency of operation. These designs have been obtained with the use of Chameleon C2HDL design tool, and the feature of this tool are shown in the following slide. We two authors taking some roles, some key roles in creation of this tool for high-level design of application-specific processors. This tool is intended for ASIC design automatic generation from algorithm which is described on NCC language. So we have NCC language on input, and we have a basic architecture which is used inside, and configuring this architecture with respect of the input program and some input parameters will give an outcome of RTL VHDL description of the specialized processor. Okay. So other software tools of self-improvable computer system, which also are used for self-improving and self-configuring as well, yes? These are computational load balancing system, a compiler for general purpose processors, subprogram compilation, and specialized processor logic synthesis tools, and FPGA configuring tools. So regarding the expected benefits, we believe that further practical implementation of self-improvable computer systems based on proposed new computing model will be a fundamental innovation and will make a positive impact on further developments of society and civilization in general, taking into account the use of computer systems in all spheres of today's human activity. The conclusions are drawn here. Basically, these are following that self-improvable computer system is a new type of computer systems, and today there is already available all methodological and technological base needed or necessary for their practical implementation. Second is that self-improvement can be performed or carried out at different levels of the computer system specification. And these systems are polyhedral, which requires a wide range of future research to be done. That's all from me, and thank you for your attention. Please,
thank you for your presentation. Dear colleagues, please, if you have any questions, ask them. Your paper is provides a big, big work with different aspects. Maybe, it's commonly a theoretical paper, or you have a specific practical case of implementation for this area.
Okay, I understand. Thank you for the question. I would like to say as follows. Some things that are used in order to implement or in order to define the concept and in order to implement such systems, we have already done. Firstly, we have this method of self-configuring of the computer system and created. I have no such slide here on this presentation about the detailed structure of the software tools, but we have created several tools. These are computational load balancing between a general purpose processor and reconfigurable environment. We have a method and the software created in order to do this. Also, we have this system for generation of specialized processor HDL model, which are presented here. I mean this one, the chameleon. Also, these logic synthesis tools, they are available from the FPGA production vendors, from FPGA vendors like Altera or Intel today, or Xilinx, and some others. This is conventional compiler, so you can find it for your target general purpose processor with no problems. So something was done also into regarding creation of operating system for self-configurable computer system. One of my aspirants has created a set of software that is used together with the Linux Ubuntu operating system in order to perform automatic operation of self-configurable computer system. If you can see here on this structure, this software tools for self-configuring, they are one of the basic, say, yes. So this part is is practically implemented. So, okay, we cannot take one instance of such system because there are also some things that should be also solved. For example, cooperation between FPGA configuring tools and the tools for creation of the HDL models. But most of this software and methodological basis as well is already created. This is available, I think. So what should be done in the future in this direction is to develop the artificial intelligence software. But we believe that it is absolutely feasible. It is absolutely feasible. Okay.
Well, thank you very much for your answer. If there is no any other questions, so we will go to next our paper, and it's paper an algorithm of photopic modeling of researchers taking into account their interest in Google Scholar profiles. Please.
Hi, can you hear me?
Yes.
Okay, let me share my screen. Sorry, I will have to reconnect because my computer wants permissions. Is it okay with you?
Yes, we will wait.
Okay, sorry.
So, dear colleagues, before we now need several minutes maybe for waiting this presentation. I think that it will be quickly. I want to say that the video of this event will be published in Facebook and on YouTube, and we will send you letters via email with links, maybe in several days, so you will be able to see you and to distribute this video to your colleagues. Please, now with your presentation.
Okay, sorry about that.
Okay.
Okay, so hello and welcome to my talk. My name is Mykola. I am a PhD student at Vinnytsia National Technical University. Today, I'm going to talk about the representation of researchers using their profiles from Google Scholar. And what I really mean here by representation is the processing of the data that we have about researchers in such a way that we can use it to solve different problems efficiently and correctly. Consider the problem of a collaboration recommendation, where we want to find a researcher to work on a shared project, or we want to find an expert in a particular research domain. How do we do that? Well, one way to do that is to use some information about a researcher that is publicly available in his profile. Here you can see an example of that, where a researcher is represented as a distribution over his publications, and each publication is a distribution over some abstract topic. And eventually each topic is a distribution over a vocabulary of words. Now we can find the similarity between these different distributions, and based on that we can rank the researchers by descending order and choose the top researchers as researchers to collaborate with. Another problem that can be solved using an appropriate representations of a researcher is a reviewer recommendation problem, where we want to find a reviewer for a particular publication. Here you can also see the most commonly used models to represent a researcher's work and topic model. Now let's take a look at the typical profile at Google Scholar. Here we can see different information about researchers, such as his name, his current place of employment, his research interests, his publications, some statistics about citations of his work, and the list of co-authors. Now, usually what is commonly used as the main source of information is publications. As I showed you example in the previous slide, the authors of that work used publications to solve the problem of collaboration recommendation. Now, what we do in this research, we instead use researcher interests that he specifies in his profile. And we motivate this by the fact that publications, first of all, can be written by different authors, and to tell which author was responsible for a particular part of the publications is a hard problem. Another motivation is that a publication, once it's published, it's always there. And when a researcher changes his scientific interest, the representation of researcher based on publications can never find these changes because it stays the same. On the other hand, he can easily change his interest and be represented as another distribution. So let's define more formally what we want to do. Given a set of researchers' interests from Google Scholar profile and a set of research topics, we want to find a mapping between them. And we represent this mapping as a fuzzy set. Now, the research topics, we choose them from a research classification system that I will explain a little bit later. Now the fuzzy set is basically a set, the terms of which are research domains. And for each research domain, we set a number which we call a membership degree, which is in the range of 0 to 1. And basically, this value represents how well this given set of keywords corresponds to the properties of a particular research domain. The greater the value, the more properties of this research group a given set of research of keywords contains. Now, what is the key thing to notice here is that we represent a researcher as a distribution of a research domain. So basically, the result of this mapping can be easily understood by a human. Now, here we present the basic idea, and the idea is to use the system called dimensions, which is a very similar system to Google Scholar. It indexes over 100 million of publications and gives access to researchers' profile. And the key thing about dimension is each publication, it is categorized to different research domains. And we can search these publications by a keyword, meaning that the system will give us the number of publications where this keyword appeared either in title or on abstract. And this gives us basically the distribution over all research domains that are defined in the dimension. Here you can see a few of them. And for each domain, we have the number of publications where this particular keyword is presented as in title and abstract. So the idea is to map a key.
Колеги, чи хтось чує мене?
Так.
Пане Микола, у вас є якісь проблеми зі зв'язком? Я думав, що то в мене.
Так, я перепрошую, мене не викинуло. На чому ви що останнє побачили?
Ну, ми бачили слайд, де була dimensions, оце ми бачили, так.
Okay, so so here we present you a review of the research classification system that is used in dimensions. The name is Australian and New Zealand Standard Research Classification. It has 22 research divisions and 154 research groups. Now, a research division defines a more broader concept of study. A research group is a more specific area of study, and divisions consist of a few research groups. Now, in this study, we only use research groups as representations of researchers. For our algorithm, we define a few key principles. We want to filter some noise and ignore stop words. We have the principle of multi-labeling, where we want a researcher to be represented as a few research groups and some others that are pretty self-explanatory. Here is our algorithm. It consists of a few stages. Basically, the first stage is we extend our set of keywords. We add a pairwise combination of them, which I will show you in the next slide. Then for each keyword, for each query that we formed, we find the distribution of publications, the distribution of research domains as the number of publications. We perform some noise filtering and stop words. We reject the least popular research groups and we norm the results. And then for each query, we average the results, basically just an average. And again, we reject the least popular research groups and reduce the distribution to be at most 4, to have research groups with non-zero membership degrees of the count at most 4. Here you can see an example of how does our algorithm work. We have a test profile with 3 research interests, and here we can see the distribution over all research groups for each research interest. And as I mentioned it above, we also extend this keyword set to include a pairwise combination of research interests, which basically gives us the support for research group that have both research interests, and therefore it basically removes some noise that we can get from other research groups. And here on the x-axis we have a research group, and research groups are grouped by research division, where a research division is notated as a letter. The next stage is first noise filtering. We basically ignore all research groups that have a small membership degree. We still have here the distribution over all keywords separately. Now here we average all previous distributions and get this one. We again perform noise filtering and we reduce the number of non-zero membership degrees to be at most 4. And also we ignore all research groups with membership degree less than 50%. And here is the results of modeling. We have the initial set of keywords, and the results interesting representation of a researcher. Now, we have represented a researcher. How do we compare different representation of researchers? And we propose to use the Chekhanovsky schematic, which is basically a minimum of each individual research group for two different researchers. And the intuition behind this is basically if we have two different distributions for the same research group for different researchers, well, what is similar between them? It's this thing here, the minimum between them, and the same thing here. Well, in that case, where we use Chekhanov schematic, we only compare the same research groups for two different researchers. But usually what we want is that researchers from different research groups have greater similarity, because these research groups are very similar. And so for this metric, we add an additional value, which basically takes that into account, and for each research group, it basically sums the research similarity between them. And for the sake of simplicity, just ignore this term here. I'm not going to get into detail of that for now. Now let's consider an example of how we can compare different research representations. Here we have a profile in Google Scholar where we will use his research interest to represent a profile, and here a profile from Dimensions, where basically a researcher has a number of publications, and the list of his publications here is one of them. And as I mentioned above, all publications in Dimensions are categorized to different research domains. And for each researcher in Dimensions, we can get the distribution of research domains of his publications. And we can process this as the last stage of our algorithm to get the spectral representations. And here we do that for a few profiles, for 3 profiles, just to show you an example. And as a result, we compare them and find the similarity. So using Chekhanovsky metric, we get these results, and using Chekhanovsky metric with including the research group similarity, we get this result. So basically what we see here is that based on research interest, we get a pretty good match with representation based on the dimensions, based on the publications from Dimensions. They are very similar, and basically we can use it. We can use research interest as a main source information to represent researchers and solve different problems. And that's it from my side.
Thank you for your presentation. Please, all who have questions, you can ask the authors. When we wait questions, I have one concerning this table. Is it correctly that Ronald Jager is more, how to say, similar to Evgeny Podyansky by these measures, or it's a mistake from my side?
What do you mean more similar? That he has.
You say that you want to compare researchers, and yes, you provide specific measures for different categories. And if we have some measures for these people, I can see that measures of Ronald Jager is more similar to Evgeny Podyansky than for Natalia Kusul. Is it correct to say that their interests are more closely related than for Natalia Kusul? Commonly, what's the sense of this data presented in this table? What they show us?
Basically, the numbers here, they show that the given set of keywords, the research interests that are in Google Scholar have the properties that are represented in this research group.
Okay, so if, for example, one Jager have by the research group H1 the 0.63, and Evgeny Badyansky have 0.79, it means that they more closely related to this group. What does it mean? What mean these numbers?
I mean, they are basically what the membership degrees, meaning that the higher this value, basically the more properties of this research group a given researcher has.
So Jager is related to artificial intelligence, and Badyansky is strongly, highly related to artificial intelligence.
Yes, okay. So basically this number is greater. That means that he has more properties of this research group.
Thank you. Does some other questions maybe somebody want to ask? I hope you successful further studies. It's generally interesting direction to try to work with different systems, showing now us publications, and maybe you will try to use Scopus and Web of Science results too. We have in Ukraine also Open Ukrainian Index and Microsoft Academic Search. They are commonly related with the same data as dimensions. Maybe these directions will be interesting for your next works.
I am Mikhail Polyakov. Together with my colleagues, I present a report on the forms of additions to physical models of objects of study in remote laboratories. Important elements of distant learning environments for learning system design are remote laboratories. The pedagogical problem when using physical models in the process of teaching systems design lie in a very limited number of technological operations, linking the state of the model with its sensors and actuators. Another problem of remote laboratories is the small number of simultaneous experiments with physical models of research objects. The purpose of this article is to expand the functionality of physical models of object of study, increase the variety of experiments with when increase the level of systems under study to cognitive ones by using various augmenteds, starting with augmented reality and improve interface in experiments with visual models. The term augmented entity, reality, functionality, cognitivity implies the definition of a basic entity with respect to which additions are made. The contents of the basic and added entities will be examined using physical models of the Goldie laboratory, such as elevator, free access portal, warehouse, and production cell. The forms of the basic reality of physical model, warehouse, and elevator are shown in different interface of a laboratory, such as SIPI, WCI, and other. By basic functionality, we mean the minimum set of functions performed by a normal physical model in normal mode with basic reality. The warehouse model has next basic functionality. Load a box from the warehouse cell or input drive into a movable module. Move the movable module to a given warehouse cell. Upload a box from the moving module to the warehouse cell or to the output drive, waiting for a box operation. The possible augmented realities of the elevator model are: first, the images of the queue of passengers who have called the elevator and waiting for the arrival of the cabin. Result report display with waiting and travel time. The possible augmented functionality of elevator model are: generator of stochastic sequence of elevator calls from different flows at the same time, as well as generate destination floors for these calls. The analysis of the load of the elevator and the optimization of the replanting passengers along the road of the elevator. Calculation the parameters for the elevator latency and use query time. Analyzes the parameters of the flow of requests for calling and moving the elevator. A fragment of the animation of the virtual experiment is shown on slide 6. First, the parameters of experiment are entered, such as the number of the passengers, simultaneous calls, and the duration of the experiment. When a call flow is generated, the elevator carries passengers and generates a report with service. Slide 7 shows an example of added functionality of the warehouse model. In the course of the virtual experiment, the boxes are sorted according to the principle of the game 15. Other options of added functionality could be obtaining information about filling the cells of their house with boxes and information about the number and parameters of the boxes stored in the warehouse, the timing of the sending batches of the boxes, and the composition of the boxes in the load. Sorting boxes in the warehouse according to the specialized criterion, for example, by numbers, aerial time, parameters of boxes and their storage area, rows and floors of the warehouse, analysis of the effectiveness of search algorithm for sorting boxes, optimization of the placement of boxes according to various criteria, for example, minimum length of movements of a movable model, the timing of sending boxes, increasing the speed of receiving boxes through the input drive. The basic and augmented realities of perception and functionality of behavior discussed about the related information based are the basis for constructing cognitive systems. When constructing these systems, additional means are used to convert higher form of knowledge, implemented target and scenario control, cognitive perception, planning, training, and reasoning. The complex of these tools we will call augmented cognitivity. Cognitive perception of the results of studying an object is possible, for example, because the transformation of secondary information about added reality. The statistics of the flow of boxes are at the entrance to the storage train the neural network, which forms a model of the flow of boxes. This model is used to predict future receipts of boxes and plan their placement. Options for predicted situation and placement are analyzed by a block of reasoning, taking into account the such possible goals of the system. Minimize the movement of movable model, minimize the time of receiving or sending a batch of boxes. Indicators of the effectiveness of the method of additions have been proposed. As an indicator of technical efficiency, we will choose the relative increase in the number of experiments. As an indicator of economic efficiency, we will choose the relative decrease in the cost of one experiment. When implementing the proposed method of additions in the Goldie laboratory, it is expected that the variety of experiments will increase by at least 2 times. Accordingly, the efficiency of experiments on the proposed indicators will increase at least twice. The number of simultaneous experiments with physical models is limited. Virtual experiments don't have these limitations, but virtual experiments have reduced visibility. To overcome this drawback, a method of using pre-slot video chips in virtual experiments is proposed. Typical fragments of movement, sensors, and actuators to synchronize the video display, and the condition for displaying video fragments are given in tables. If the laboratory must simultaneously conduct G experiments with physical models of cost C, then the total costs are equal to G multiplied by C. This cost can be avoided by applying the proposed method for improving the WC I interface. The method of additions allows you to expand the range of creative design tasks for students without additional costs for the execution of physical models of the study systems. The arts one presented in the remote lab and are complex and include augmented reality, functionality, and cognition, and interact with the underlying properties of the object. The expected efficiency of experiments using additions is at the least twice the baseline in terms of the proposed indicators. Thank you for your attention.
My name is Anastasia Deineka, and I represent here Kharkiv University of Radio Electronics. I am associated professor at AI department, and I'm a senior researcher at Control System Research Laboratory. And topic of my report today will be about adaptive learning of evolving hybrid basis function neural network. Today, artificial neural networks are widely used to solve various problems of data mining, and first of all for intelligence control, identification, pattern recognition, classification, clusterization, forecasting, and other one. If data should be processed in the sequential online mode, a convergence rate of the learning process comes to the force that significantly limits the class of artificial neural network suitable for work under this consideration. Neural network which use kernel activation function that is known as radial basis, bell shape function, potential function are very effective from the speed optimization point of view in the learning process. Radial basis function neural network are widely used because their output signal depends linearly on synaptic weights. The main idea of this neural network is connected this potential function method, parsed estimation, kernel, and non-parametric regression. Universal approximation properties and ability to process data sequentially in online mode are its main benefits. However, the radial-based function network is exposed to the so-called curse of dimensionality, which means that when the input space dimensionally increases, there's an exponential growth of the adjustable parameters, their synaptic weights amount. To overcome this problem for solving practical task, possible to use a hyperbasis function neural network that have more advantages comparatively to traditional RBSN. Speaking about hybrid basis function neural network learning, it should be noted that they are not only synaptic weights vectors can be adjusted, but and centers and covariance metrics also could be adjusted. So, introduced into consideration the transformation implemented by the neural network in the form of Formula 2. The most commonly standard Gaussian function as activation function in the radial basis neural network is used in the form of Formula 1. Figure 1 demonstrates standard radial basis function network, and at the figure 2 you can see standard Gaussian with different weight parameters. Okay, a learning criterion of this neural network could be written in the form of Formula 3. Its learning algorithm could be written as Formula 4. Using as activation function Gaussian leads to learning procedure 4 becomes to converse one from computational point of view that naturally slows down the learning speed. In this regards, we propose to introduce into consideration multidimensional modification of the Yupanechnikov function in the form of the Formula 5. In this regards, also learning algorithm that could adjust not only synaptic weights but and centers and covariance matrices. You can see also in this slide. The questions how to choose number of neurons in the networks and initial centers location. It's very important. The easiest way to overcome this problem is to use a subtractive clustering algorithm that is effective enough for processing data in the bench mode. Dynamic key adjusted also is one of the possible methods to tune neural network with kernel activation function. This method is belong to constructive learning algorithm and works fast enough, but in the mode of online process of the non-stationary signal, this method becomes non-effective. Resource allocation network use hybrid learning based on the both optimization and memory learning. The principle, like in a general regression neural network, this names neurons in data points are used in this neural network. But this system is have high computational complexity. In this regard, it's necessary to develop artificial evolving hybrid basis function neural network that tunes not only its all parameter but and automatically determines number of neurons in online mode at high speed of data processing. In the figure 3, architecture of the hybrid evolving artificial neural network that is based on the hybrid basis neural network with a variable number of neurons and coherent self-organizing map that control their numbers and adjust centers location in the self-learning mode is demonstrated. The main idea of this hybrid neural network is to combine self-organizing map with hyperbasis function neural network. It's self-learning combine it with standard radial basis function learning. You can see by steps on these slides and on the next slide. As computational experiments, in the first series of experiments, we used synthetic generated data set that describe normal Gauss bivariate distribution. In this data set, number of clusters was chosen arbitrary, and all data were generated in the fixed interval. Result of processing synthetic data set by evolving hybrid basis function neural network are shown at this slide at figure 4. For the next experiment series, dataset 1 and dataset ionosphere from UCI repository were taken. Effectiveness of proposed evolving hybrid basis function neural network has been investigated and compared with the standard radial basis function network and the standard self-organizing map developed by Kohanen. The figure 5 demonstrates evaluation of the centroids coordinates. As a visualization example, dataset 1 was taken. Comparison of numerical results of proposed system, standard radial basis function network, and a self-organizing map are shown in the table 1. Visualization of clustering result by proposed evolving hybrid basis function neural network are presented as at the figure 6. In this slide, you can see numerical results of comparison of proposed system and standard RBFN and SOM. As a conclusion, I can say that the main advantages of the proposed approach is that it can be used in online mode when the training set is fed to the system's input sequentially and its volume is not fixed beforehand. The results can be used for solving a wide class of dynamic data mining and data stream mining. Thank you for your attention.
Hello, everyone. My name is Demet Güler. This study is prepared by Professor Dr. Zaporizhzhia and me, and we're from Istanbul Technical University. This study will be based on the SVD-Aided EKF, but we're applying a process noise covariance adaptation, and it is implemented to a satellite attitude dynamics. So our purpose is to estimate the attitude angles of an satellite. Let's go to the next slide. This is the outline of the presentation. We will start with the introduction part and continue with the singular value decomposition method, which is the base method of the filter. And inside of this method, we're using two different models based on the Earth's magnetic field and sun direction vector. And we will see the mathematical models for the satellite's rotational motion and the measurement models after this topic. And the most important part of the presentation is the analysis part. But before that, I will show you the Q-adaptive SVD-Aided EKF scheme so that we can see which adaptation rule we're using and which way we're adapting our filter. And I will show you the details inside of that title. And we will conclude our presentation after the analysis and results part. So what was our motivation to start this study at the first place was we were using non-traditional filter. We're calling non-traditional filter to singular value, not singular value, but single frame meta-space Kalman filters. So this is a general name. But in this study, we were using SVD-Aided EKF. So we were using non-traditional filter, and they were robust to the variations in the measurement noise. But we were wondering if our filter can fit or can be robust to the disturbance torques on the modeling, on the system models or faults in the actuators. So that was our motivation to look for another adaptation rule, so that our filter will be robust to both measurement noise and the system noises. So it will be a simultaneous adaptation for R and Q matrices. In those kinds of disturbance torques, our estimation accuracy of the filter, not only the non-traditional, but also the traditional, the conventional filters, will deteriorate. So if the faults are very long, then those filters can diverge. That's the second starting point of our study. And as we are using a satellite, so our implementation is for a satellite. So satellites are in the space environment, so they are in harsh operation conditions. And also in that environment, we can, yes, we are modeling those the space environment, but there can be anomalies like external magnetic field or some other different anomalies like solar variations in the space environment. So if we don't model those in the system, then they will also affect the satellite estimation accuracy and data estimation. Let's start with the SVD method. So in most of the studies, if you're using SVD with a filter, you're using it with a different way, probably. So it's kind of a different approach. So we're using SVD method as a pre-processing step. So how we are doing this? In the method, we have, as you see here, the loss function. In the loss function, it's an optimization problem. In the loss function, we need two or more vector observations. Those are the vector observations. First one is the BI is in the body frame. So it actually represents the measurement vector, but also R. So you need to model that measurement vector. So it's a model. It's in the reference frame. And you need to transform this R vector using an attitude matrix, or you can call it transformation matrix. So the difference between them and also as you see here, AI is also used. It is the 1 over sigma square. Sigma means the standard deviation of the sensor that you use. So from this loss function, you can write a BSVD matrix. From this matrix, the loss function can be rewritten in this form. So using this form, you see it is a simplified version of this. So our purpose here now, our purpose was to minimize the loss functions. To minimize the loss function, we need to maximize the trace of this part. So for doing that, let's start with the we define to singular values of the BSVD, and from finding these singular values, you can come up with an optimum A matrix, which is the attitude matrix, the transformation matrix. And from that matrix, you can have the Euler angles or quaternions or MRPs. You can use any kind of representation, but in this study, we are using Euler angles. So from the optimum A matrix, we have the Euler angles. And also, so this is the measurements from SVD, as it is determined by the SVD. And also, we have one other matrix called PSVD. This is the same matrix we are using in the filter, so it makes our filter adaptive. This is the measurement noise covariance matrix, and this is updated in every step in SVD. By this way, our filter is already R adaptive. R means the measurement covariance, measurement noise covariance matrix. Here, only thing that we need to consider is if we have a parallel vector of 2 or more, or if you have an unobservable time interval like eclipse, the dark side of Earth, then this matrix will become infinite. So this will also affect the estimation results. So we will be careful here. Okay, so here in the SVD, we need at least two vectors. In this study, we use magnetic field vector and sand direction vector. For magnetic field, we have selected the IGRF model, which is very commonly used to model for attitude estimation purposes, and it is only for near-Earth spacecraft, and we need the position of that spacecraft and the time. And we can have the magnetic field vector from the model. This is the general model mathematics, the formula. And after having that vector from the model, we can have the magnetometer measurements as modeled like this. We have the Gaussian noise here, zero mean Gaussian measurement noise for the magnetometer. And here you see again the attitude matrix as we are transforming that vector into the body frame, which is which we have the measurements. And the second one is the sun direction vector. Where after having the sun direction vector from the model, we can also have the sun sensor measurements. We can model the sun sensor measurements like this, which is similar to the magnetometer. Again, you see the measurement noise here. This is the satellite's rotational motion formulas, the equations. First one is the kinematics equation of motion of the satellite. As we are using Euler angles, you can see the change of the propagation of the Euler angles. And then we are using, by the way, right gyros as well, but I will show you the equation later. So we have also the angular velocity changes, which is the dynamics of the satellite's rotational motion, as you see in the third row. So by using those equations, we can simulate a satellite at low Earth orbit or other orbits as well, but in our study, we are using low Earth orbit. Okay, so for the measurement models, as I told you about, in the SVD, we are determining a coarse attitude angles, and we are using those as measurements in the filter. So those are the measurements. You see roll, pitch, and yaw angles as a vector. So this is the first part of the vector, the measurement vector. And the second part is composed by the rate gyro measurements. So this is the rate gyro measurement model. So this is the second part. So we have 6 elements in the measurement vector. for the filter. So let's start with the traditional approach, the conventional DKF. As you know, we have two different initial conditions for the filter. And we have predict step and update step in the filter. As it is a nonlinear measure, we have the nonlinear measurements and the nonlinear system. We have to have this partial derivatives in this, let's say f, and let's say h here. So those are the partial derivatives that we need to calculate in the traditional filter. And our measurements here is different than the non-traditional approach because we have the measurements directly and they're nonlinear with respect to the states. And first one is the magnetic field vector, and the second one is the sun direction vector, sun direction measurements. Those are measurements, of course. And the third one is the rate gyros. Let's look at the non-traditional approach. So first advantage right here is the states are coming from the SVD. So as we all know, if we have a very different initial condition, the filter even may diverge. So we don't have that problem in non-traditional approach because it is determined by SVD and we can just directly use it as an initial condition in the filter. So this is one advantage. In predict step, it is the same with traditional approach, so there's no change here. But in the update step, we have two different change. One is the h. We were calculating the partial derivatives in traditional filter, but in non-traditional approach, this is becoming linear. So because the measurements here are linear with respect to the states, as our states are Euler angles and angle rates. But of course, if you, for example, if you don't measure, if you don't have rate gyros, or if you do not want to estimate that, then the size of the matrix will be different. So you need to be careful in that. But in our study, we are both measuring the Euler angles from SVD. We are measuring the angular velocities from rate gyros, and also we are estimating Euler angles and angular velocities. So this is linear. This is a unit matrix, 6 by 6. And another difference here, our filter now is inherently adaptive with respect to the R, which is the measurement noise covariance matrix, because it is coming from SVD's covariance matrix. It is using it directly so that we can update it at each step of the filter. So it is inherently adaptive. We can call it our adaptive filter as well. So it is already our adaptive. And what was our purpose? Our purpose was to add another adaptation rule in here. So right now, even if it is, say, K, it is a constant matrix. It's not changing in time. And also in traditional filter, R is not changing in time. It's constant. So in this filter, our purpose is to also make this Q matrix adaptive for the filter, the system noise covariance matrix. Those are the general Kalman filter equations. They're not really different from the conventional filter. So you see, those are the general system and measurement functions, and you can see the Kalman gain. And at the end, we have the estimation and we have the covariance matrices calculated in the filter. Okay, so here, this is our Q adaptive SVD-Aided EKF. We are calling it AEKF in short, but it is not only adaptive to Q, but also it is adaptive to R. So it's simultaneously adaptive filter. Which is kind of typical for conventional filters, as you know. So our adaptation is coming from SVD, as you see, and we have the attitude measurements from SVD. We are using those information in EKF updates, and as we estimate the attitudes, we also have an adaptation rule here. So how we are doing this? In the innovation, as we're calculating innovation in the filters, let me show you here. This is the innovation part in the estimations. So in the innovation part, if we have that kind of equation, then we can recreate a scaling matrix by using the innovation values. So this is the formula that we use for the scaling matrix. So I'm calling it scaling matrix because it's a matrix, and you can find those scaling values for each channel. So you don't have only one value, but you have the values for each different channel for the Euler angles and also angular velocities. And we're using that scaling here, lambda and Q matrices. So in this here, lambda star might have negative values, or it can be less than 1. So we are also using this rule as a sub-step in the Q-adaptive filter. Okay, let's see the analysis. So in the analysis, we have a low Earth orbiting and tumbling nanosatellite. So it's not controlled, it's tumbling all over the orbit. Our sampling time is 1 second, and it's a circular orbit. We have an eclipse period between 1500 and 2500 seconds, and we have a process noise. So we have added a process noise for checking if our filter is really working. So the process noise is between 3000 and 4000 seconds. Okay, so this is the first result for the Euler angles. I will show you the angular velocity result and also the scaling factor for each channel. So for the Euler angles, you see, so in the eclipse, they are similar, not changing a lot. Sometimes I think the EKF is better, but we were expecting they're similar because they're both having the measurement noise covariance adaptation. So we were expecting this result, so that they will be similar. So this is, you can see it as like a measurement fault. So for the process noise increments, as you see, the AEKF, which is the Q-adaptive and R-adaptive SVD-Aided EKF, is giving much more accurate results than the SVD-Aided EKF, the basic non-traditional filter. And even after the period, it's converging in a long time for the SVD-Aided EKF. So here we're suggesting to use the AEKF. But if you look at the angular velocities, we do not really see that much difference. So for the Richard, maybe you should have more system noise on the system. Then maybe you can see the difference. But for our system noise, it is not really effective in here for the angular velocities. But in the other angles, we really see the difference between those filters. So I will show you the table as well. So wait for that. Okay, those are the adaptive factor for the first three and the last three. So first three for the other angles, and the last three is for the angular velocities. So we didn't really see that much difference, even we have really adapted here. So you can see the values, but in here you see it's the 4 and 10 for product by 10 to 5. So it's very large for adapting the filter, and we see that it is really working for our case, for our analysis for the satellite. This is the last slide for the analysis, and it is the table that we created for nominal and the process noise increment cases for 2 different filters. So that's our filter. So in nominal case, we are not really seeing that much difference, and it's actually what we expected. But in the process noise increment period, you see the accuracy is really improving, like 4 times here, more than 10 times here, and 6 times here. So it's improving a lot. The attitude estimation, attitude angles estimation. So as a conclusion, we have used pre-processing step as it's called SVD. You can use other techniques inside of the single frame methods, but we have selected SVD. And we have eliminated the poorly chosen initial attitudes. So it's a good advantage. Another thing, we have added Q adaptation. So we have simultaneous adaptive SVD-Aided EKF. So it's also an advantage. We have a scaling inside of the Q adaptive, and after that scaling, we're improving the accuracy of the attitude estimation 4 to 10 times, which is a very good result. Thank you for listening. If you have any questions, you can use the conferences platform, or you can directly send an email to me. Thank you.
The fourth international workshop on computer modeling and intelligent systems. Our university is National University of Water and Environment Engineering in Rovna. The title of my paper is Deep Convolution GAN for Enhancing Eye Disease Classification, presented by Mahmoud Smaida, supervised Dr. Yarashek. Presentation layout, introduction, generative adversarial networks, GMD model, dataset, methodology, results, and conclusion. One of the main challenges in the field of medical image is how to deal with small dataset, especially when we use supervised learning to classify images. Therefore, using artificial intelligence techniques to improve current system must be made available to provide maximum comfortable to the patient, ophthalmologist, and improve healthcare. In this paper, we will use deep convolution GAN network to increase our dataset in order to improve the accuracy of classification using GMD model. In briefly, generative adversarial networks are a type of machine learning networks that Ion Goodflow and colleagues invented in 2014. There are two neural networks computing with each other. The aim is to create a fabricated data similar to the real data set. This technique learns to generate new data with the same statistical properties of a training set. The deep convolution GAN is only replaces the generator and discriminator with two convolutional neural network, and this figure shows a simplest diagram of GAN. GMD model is glaucoma, myopia, diabetic retinopathy model. We have 4 classes: glaucoma, myopia, diabetic retinopathy, and normal eyes. Our network consists of a set of convolution layer and pooling layer and the fully connected layer. The output is 4 unities represented eyes disease. We collected our dataset from Kaggle. It's a data science site that contains a variety of extremely contributed, interested datasets. And all these images we have collected, reviewed to a doctor in a clinic in Kiev to confirm all these images. We have collected in training set 1,200 images and for validation set 246 images. The main goal in this work is to generate images that looks like realistic images in each class in order to solve the problem of lack of medical images. In addition, using a GMD model to classify eye diseases with and without deep convolution GAN. Deep convolution GAN consists of two separate neural networks, generator and discriminator, consequently computing against each other. The generator, which tries to generate examples that seems the real data, it works to deceive the discriminator, while the rule of discriminator network is to distinguish between the real and the fake data. The GMD model consists of a set of inner layer and pooling layer occurring in an alternate fashion. This figure shows the block diagram of proposed deep convolution GAN and the objective function of GAN, the formula. The complete formula consists of two periods. X represents the real image and Z represents the noise input to the generator network. A G of Z is a fake image generated by the generator, and D of X is a probability of that X came from the real data, which value between 0 and 1. The discriminator should classify a real image is real, and this value should be close to 1. Purpose of generator, as mentioned above, dg of z is the probability that the discriminator network governs whether the image generated by generator is real. In other words, generator wants dg of z is to be close to 1, and v, d, g will be smaller at the same time. So we see that the formula tags of the formula is minimum g. The purpose of discriminator is simply a classifier. It tries to distinguish real data from the data created by generator. Train discriminator to classify real images as real. D of x, it's the output of discriminator, should be close to 1. Train D to classify fake images as a fake. D, G of Z should be close to 0. In our experiment, we just save the image when D, G of Z greater than or equal 0.76. And this figure shows the discriminator network in the left and the generator network in the right, which we have used in our experiment. The block diagram of GMD model. Our model consists of a set of convolution layer and pooling layers and fully connected layer, and the output layer is consists of 4 unities representing the eye's disease. The main objective of this paper is to increase our data set using deep convolution GAN. These data will be fed to a GMD model in order to improve eye disease classification. The schema of our experiment has been applied. We utilized our data set as we mentioned before. The number of epoch we have used are 4,000 epoch. That is not mean we have 4,000 images will be generated because we save just the images that dg of z greater than or equal 0.76. And the table below shows the synthetic or the generated images that we have obtained. This figure shows the training image in the left and the real image and the fake images in the right. And these are the losses in all classes: glaucoma, diabetic retinopathy, myopia. A GMD model has been applied. We use a constant learning rate. The initial learning rate was set as 0.001 and the number of epoch set as 100. In original data, we obtained accuracy on training set 76.5 and in validation set 76.4. GMD model results with the synthetic data set. The same parameters has been implemented. The results obtained, the accuracy on training set 80.4 and accuracy on validation set 83.7%. In conclusion, deep convolution GAN strongly can be used for generating a good quality of medical image and increase data set. Furthermore, the performance of GMD model with original images and images were compared. We confirmed that with the help of deep convolution GAN and GMD model can yield better accuracy compared to traditional methods. Based on this work, we suggested that deep convolution GAN can be optimized for multi-class generator. We also suggest that this work can be applied to the other networks such as VGG, Inception V3, ResNet to enhance the accuracy. We noted that the images we have obtained from deep convolution GAN had some noise. Therefore, in the next paper, we will use the noise swing autoencoder to enhance these images to improve the accuracy of our model.
The topic of the research is Intelligent Big Data System based on scientific machine learning of cyber-physical systems of medical and biological processes. Over the last decade, we have seen a rapid growth of digital developments, including a variety of sensors, microcontrollers, communication systems to meet societal needs. Thanks to the Internet of Things and the use of biosensors, digital electronic health services are increasingly used every year. Biosensors play a crucial role in the Internet of Things when it comes to e-health. Medical big data helps prevent the development of the disease at the early stage through the analysis of cardiovascular pressure, pulse, respiration, and blood sugar. Cyber-physical systems are attracting more attention than ever, thanks to the rapid development of the Internet of Things and its combination with artificial intelligence, machine learning, and the cloud. These interacting networks of physical and computational components will provide the foundation of critical infrastructure, form the basis of smart services, and improve the quality of life in areas ranging from energy and environment to the transportation and healthcare. Cyber-physical system technologies are already transforming the way people interact with engineered systems in the real or physical world, just as the Internet has transformed the way people interact with information. Yet, due to their complexity, the developers of cyber-physical systems face a major problem: the lack of simulation tools and models for their design and analysis. Cyber-physical systems are systems that integrate computing elements with the physical components and processes. The computing elements coordinate and communicate with sensors, which monitor cyber and physical indicators, and actuators, which modify the cyber and physical environment. Cyber-physical systems use sensors to connect all distributed intelligence in the environment to gain a deeper knowledge of the environment, which enables a more accurate actions and tasks. Cyber-physical systems are systems consisting of various natural objects, artificial subsystems, and control computers that allow such an education to be represented as a single entity. Cyber-physical system ensures close communication and coordination between computational and physical resources. Computers monitor and control physical processes using such a feedback loop where what happens in physical systems affects computations and vice versa. Nowadays, the integration between physical resources and computing leads to the creation of complicated computing systems with distributed parameters. Such systems are controlled or managed by integrated into the Internet computing resources. The slide shows the principle of operation of cyber-physical biosensor systems of medical and biological processes. First, a particle of the substance is measured, which is measured with a particle of the selective layer of the cyber-physical biosensor system, resulting in the formation of the product, which is converted by the converter into an electrical signal for data analysis. That is, the methods of the molecular biology, electronics, and communications make it possible to monitor health, controlling chronic and preventing critical human conditions. A cyber-physical system typically consists of physical and cyber spaces with various sensors and actuators, as graphically shown in the slide. These spaces integrate computation and physical processes and are interconnected by a network layer for exchange of data between these two spaces. The development and implementation of sensors with different functions is practical use are one of the priority areas of modern electronics. Development of biosensors requires integration of knowledge in different subjects such as molecular biology, genetic and protein engineering, analytical chemistry, material science, microelectronics, and nanotechnology. Biosensors are analytical devices that use biochemical reactions to detect a wide range of chemical compounds, metabolites, medications, environmental pollutants, etc. Slide shows the transfer of antigens between adjacent immunopixels. A model of the biosensor on the rectangular lattice with the use of the lattice delay differential equations is developed. using a number of assumptions. In particular, it's assumed that we use the concentration of antigen population, and also it's used the concentration of the antibody population in the biopixels IJ. The design of the biosensor model on the rectangular lattice of the antigen antibody type with time delay for the two-dimensional array of biopixels, which is based on the known Marchuk model and uses a special operator, is considered in this work. Also, the initial functions are shown in the slide. For square array, the discrete diffusion is used for the special operator, taking into account the imbalance constant. Each pixel is exposed to antigens from 4 adjacent pixels that are separated by equal distances. In order to obtain the results of numerical simulation of the immunosensor on rectangular lattice using delayed differential equations, the values of the parameters of the immunosensor's model on the rectangular lattice using differential equations with delay are introduced. The name of the model parameters, their numerical values, as well as the representation of parameters and their numerical values in the package are determined in the computer program. For the intelligent big data system of medical and biological processes dynamics, we use the mathematical description with the help of nonlinear difference equations with delay. It is considered the concentration of macrophages and the concentration of monoclonal antibodies in the biopixel IJK on the basis of the hexagonal lattice. In this case, the cubic coordinate system is used. Results of computer simulation are shown in the slide. Figures show the first stage of computer modeling of discrete dynamics of the intelligent big data system for investigation of the stability of the cyber-physical system of medical and biological processes in the form of the lattice images of macrophages and monoclonal antibody in pixels of the studied system. Picture shows the result of numerical simulation of system at the value r equals 5, which corresponds to a stable focus. For R17, there is less pronounced, and for R22, more pronounced wavy changes in the lattice images of macrophages and monoclonal antibodies in the pixels of the system. And next results show the second stage of computer modeling. It is used the lattice graphs. They are used to investigate the stability of the system. Firstly, the corresponding graphs are constructed on which, for each pixel, the image of the probability of contact of macrophages with monoclonal antibodies are presented. The picture first shows the result of numerical simulation at the r equals 5. It corresponds to the stable focus. R17, it is less pronounced, and for R22, more pronounced. In the third stage of the computer modeling, lattice graphs of fluorescent pixels were obtained based on the fulfillment of conditions. Hope bifurcation is observed with increasing time delay. The last picture shows the results of numerical simulation of the system at the value 22. In this case, chaotic behavior is observed, which begins with wave-like changes in fluorescent pixels. and quickly turns into chaotic changes. And in this slide also it's shown the electrical signal. On the left, it's shown the electrical signal from the converter, which characterizes the number of fluorescent pixels, values is given at the R equals 17. Analyzing the type of electrical signal in the picture, we can conclude that changing the value qualitatively changes the behavior of the pixels and the entire biosensor model based on the latest difference equations. As shown by the result of numerical analysis, fluorescent states in biopixels change according to the laws of discrete dynamics, and in the picture on the left, there is a traveling wave of non-fluorescent pixels. The threshold value of fluorescence is 1.5. According to results of series of experiments of intelligent big data system for investigation of the stability of the cyber-physical systems using latest difference equations with delay, it established that in case of using hexagonal lattice, the solution of the investigated system tend to endemic state, which are stable focus. For R17, in the case of the hexagonal lattice, there is a Hopf bifurcation, and all subsequent trajectories correspond to stable boundary cycles for all immunopixels. With a further increase in the delay constant, chaotic behavior of the system occurs on the basis of the lattice difference equations. The block diagram of the software package for the study of the cyber-physical biosensor system is shown in the slide. The software module for this system consists of blocks for obtaining the bifurcation and phase diagram. Slide presents the interfaces of the developed software packages in the form of program windows for input of input parameters of the model and windows for modeling lattice images of antigens. The numerical simulations results obtained in the work make it possible to carry out stability analysis and comparisons of the studied models, taking into account the time delay. A set of computer programs for the study of phase diagrams has been created, which can be used both separately and as additional specialized software. The development computer programs for the study can be used for different medical purposes. In the following researchers, it's necessary to offer mathematical models of intelligent systems of big data on the basis of other geometrical structures and to carry out research of their stability. Thank you very much for your attention.
Dear colleagues, I am Zaporizhzhia from the Institute of Cybernetics in Kiev, and I am pleased to have an ability to present the talk on parameters identification for fractional fractal model of filtration consolidation using GPU. I would like to start from some general context. We study mathematical modeling of transport processes in Polish media on the basis of the models of non-integer order. Such models contain integral differential operators, the so-called fractional derivatives, the order of which usually do not have some precise physical meaning and cannot be instrumentally measured. To practically use such models and other models with the same properties, we should solve inverse problems of determining such values of non-measurable parameters that allows describing measurable indicators of processes dynamics with the best possible accuracy. For complex underlying mathematical problems, including initial boundary value problems for integral differential equations, the efficient class of methods used to identify the values of their parameters is the class of population-based Metaheuristics methods. Their working principles include the solution of independent series of direct problems that makes possible an easy application of parallel computing techniques for shared memory systems for their implementation. Talking about the results, I will start from the direct mathematical problem. We consider the system of fractional differential equations that describe non-local mass transfer and consolidation processes in soils of fractal structure. This system contains the non-local fractional derivative of computer type with respect to the time variable and the local fractal derivative with respect to the space variable. They determine two parameters, their orders respectively, of the model that need identification on the basis of available measurements of water head and salt concentration, considering the values of other physical parameters that are known. We pose an initial boundary value problem for this model, adding a first-order condition to it, and solve this problem using a finite difference technique. The example of the dynamics of the process described by the considered model is given in the current slide. Comparing to the case of classical models that contains derivatives of integer order, this non-classical integral differential model describes the processes in which the dissipation of water heads and the distribution of salt concentrations have non-symmetric features and different states. So, we look for a computer science solution in the situation when the observed process visibly differs from the expected classical behavior, and its dynamics should be modeled using a generalized fractional model with non-measurable parameters. We assume that there are a set of measured values of process indicators, in our case, water heads and salt concentrations, on known depth and in known time points. We define a goal function as a sum of squares of differences between the measured values and the modeled ones, and propose to use particle swarm optimization algorithm to find the values of non-measurable parameters. Briefly, a fixed set of particles whose coordinates corresponds to the fitted parameters move iteratively in a force field with intensity that depend on goal function value. In our study, we use the basic version of PSO, focusing on its accuracy and time spent on one iteration rather than on its convergence rate, on the improvement of which algorithms modifications are in most cases focused on. As PSO algorithm requires parallelizable computation of goal function values for all particles on each iteration, and that such recomputation requires solution of the direct problem, to perform the computation faster, we propose the following algorithm for running it on GPU. For each particle of the swarm, we allocate a group of threads that coordinatively solve the direct problem. As the most time-consuming part of the solution of time fractional differential equation is the calculation of non-local part of fractional derivative, we map each thread in the group to a node of finite difference grid and perform parallel within each group computation of non-local part making use of the local memory of GPU. Then, other step of direct problem solution is performed by a single thread. The movement of particles using their recomputed values of goal function was performed on central processor, and its influence on total execution time is negligible. The GPU algorithm was implemented using OpenCL framework. For comparison purposes, we also considered multi-threaded implementation on central processor using OpenMP. In CPU implementation, each thread executed computations related to a single particle. We performed two series of computational experiments. The first one to test the accuracy and the second one to test the efficiency of GPU implementation regarding solution time. To simulate possibly inaccurate field measurements, we generate testing datasets in the form of noise solutions of the direct problem. So, for fixed values of physical parameters and randomly generated set of fractional derivatives orders, We solve the direct problem, randomly select a given number of grid nodes as observation points, and add the uniform random noise to the modeled values of water-head and salt concentration of these points to simulate measurements and accuracies. In such a way, we obtained a series of data sets with 4 parameters: 2 values of fractional derivative orders, a number of observation points, and a level of noise. The example of the resulting testing dataset is presented in the current slide. To check the accuracy of PSO algorithm usage for parameter identification of the considered model, we send the generated datasets as inputs to the PSO, further analyzing relative errors of fractional derivative orders restoration depending on other dataset parameters. The experiments were performed on one node of the cluster of the Institute of Cybernetics. As the result, we found that the orders of non-local time fractional derivative is restored with 10 times higher relative errors when compared with the errors of restoration of the order of local space fractal derivative. Errors expectedly increased with the increase of noise level and non-uniformly depended on the values of derivative orders. We also determined the minimal number of observation points needed to obtain practically usable accuracy. This value equal to 25 points. Studying execution time, we checked the influence of the number of particles in the swarm, the size of the grid, and the ending simulation time of the performance of GPU and CPU implementations. As not all computational resources of GPU were used in our experiments, execution time of GPU implementation did not depend on the number of particles, while for CPU implementation it linearly increased for the number of CPU cores less than the number of particles. Execution time of the both implementations increased linearly with the increase of the grid size. GPU implementation in this case was slightly faster for 10 particles and 50 nodes in the grid, with the tendency of speed up increased with the increase of the grid size. When observations in a longer period or a lesser time step are used, execution time quadratically increased with the increase of the number of time steps. Expectedly, having the same order of computational complexity, as computations are parallelized only on a single iteration, GPU implementation has 5 times lower values of highest power coefficient in the corresponding dependencies. All the obtained results were in perfect agreement with theoretical expectations. To conclude, I can say that our study confirmed the efficiency of particle swarm algorithm application for parameter identification of fractional differential model, applying it to filtration consolidation model that contained both non-local and local fractional operators. For the considered problem, we determined that the order of the non-local derivative can be restored by the proposed procedure with lower accuracy comparing with the order of the local fractal derivative. We also experimentally determined the minimal number of observation points needed to obtain a fairly acceptable level of accuracy. With the combined use of the features of both the PSO algorithm and the numerical method of the direct problem solution, the GPU algorithm was developed. It showed in our computational experiments up to 4 times higher performance when compared with the multi-threaded implementation. Thank you for your attention.
Good day, my name is Volodymyr Polishchuk. I would like to present methodology for determining the level of process control in complex systems, taking into account risk-oriented factors from safe time to pandemics. The aim of the study is the urgent task of developing a methodology for determining the level of process control in the system, taking into account risk-oriented factors influencing it. The methodology is represented by a set of fusion method and models based on risk-oriented factors using the experience of experts in their assessment, the linguistic level of risk assessment criteria, the consequence of various trees to the system. The developed methodology will allow assessing the controllability of process for a complex, taking into account the various risks that affect the functioning of the system. The logic of the study is as follows. If the overall assessment of the system is high, risk-oriented factor influencing the controllability of a complex system, then we can talk about a high level of controllability of process in the system, and competence management decision will lead to system calls. Formal formulation of the class of tasks. A system set theoretical model of the problem of estimating process control in complex system, taking into account risk-oriented factors of influence, can be represented as follows, where S is a complex, poorly structured system. KR is information model of criteria for assessing risk-oriented factors affecting the system. MR is type of model for assessing control process in complex system, taking into account system traits, indicators of various risk and experience of experts. As a result, we obtain an initial estimate of Y, which carries the content of process control in the system, taking into account risk-oriented factors. This assessment will be called an aggregate risk-based assessment of the level of process control in the system. Figure illustrates the algorithm for the selection model of risk-oriented assessment of the level of process control in a complex system based on available input data, taking into account system traits, indicators of various risks, and the experience of experts. At the output of each model will be aggregate risk-oriented assessment of the level of process control in the system, based on the assessment of the risk of system operation. Input data. Since this study focuses on various complex systems, therefore, based on the theoretical study, we can formalize the input data used to assess risk using fuzzy models. Risk-oriented impact factors are indicators of risk that are assessed by some expert using a linguistic variable. To do this, based on experience, skills, and knowledge about the impact of risk on the system as a group of experts draw conclusions and make a linguistic assessment of each indicator K from some term set T. Also, to each assessment, the expert puts or a number of reliability mu, the resulting from the interval 0, 1. Risk-oriented factors are a set of traits K of some assets of the system. The input data in this concept are defined as follows. T, the consequence of the implementation of traits K, mu, the degree of possibility of realization of the tree in the system, L, the severity of the consequence of the incident on the asset. Two-level fuzzy mathematical model for establishing the risk of system operation and the level of process control in it. Step 1. Introduction of expert input data and determination of the resulting thermal evolution. Based on the knowledge entered on the object of research and the constructed knowledge base, the resulting thermal evolution is determined for the relevant groups of criteria. Step 2. An aggregate assessment of the reliability of the expert's opinion is determined. The aggregate assessment of the reliability. Step 3. Obtaining of one generalized risk assessment of research objects by group of criteria. For each group of criteria, the risk level is calculated relative to the percentage score and the resulting thermal estimate. Next step, introduction of weight by group of risk criteria. Step 5, recording of risk-oriented assessment of the system for all group of criteria. Next step, derivation of the level of process control in the system. Estimate of O with the initial variable y are equated to establish the level of process control in the system, taking into account risk-oriented factors. For example, the original variable may take the value low risk of system operation, which determines a high level of process control in the system. Next, fuse a model for assessing the risk of system operation using data mining. A fuse model is developed, proven, and tested for the task of assessing the security risk of network systems, assessing the risk of project financing, assessing the risk of the municipality system, and other. Formally, we present a fuse model for assessing the risk of system operation in the following forms. Delta operator that matches the set of output value of theta with input variable t delta. The input date of the model are t, expert level of the criterion on the object of study of the functioning of the system. Delta is a quantitative assessment of the considered criterion. At the output of the evolution model, we have R, risk-oriented assessment of system operation, and Y, the level of process control in the system. Expert model for assessing the risk of the system operation, taking into account the consequence of the implementation of various threats to the system and assessing financial loss. For this model, risk-oriented factors are the set of threats K, the consequence of the implementation of threats T, the degree of possibility of the threats in the system mu, and the severity of the consequence of the incident on the asset L. Based on the expert evolution model, we construct a generalizing step-by-step algorithm. First step, classification of input date. Next, aggregation of the incident rate within the asset. Step 3, risk assessment of system assets. Next, consideration the importance of the system asset. 5 step, diffusification date. And next step, calculation of financial loss of the incident for assets. Research of the current problem of developing a methodology for determining the level of process control in complex systems, taking into account risk-oriented factors influencing it. This is the first time the following results have been obtained. The stage of risk management in the process of assessing the level of controllability of complex systems on the basis of the conducted theoretical research are offered. Formalize the input date using to assess risk using fuse model for various complex systems. A set theoretic model if proposed which solve a class of problem of process control assessment in complex system, taking into account risk-oriented factors of influence and an algorithm for choosing a risk-oriented assessment model. Generally, step-by-step algorithms are constructed. An example of the developed methodology for determining the level of process control in the airline system, taking into account risk-oriented factors influencing it, is demonstrated. Thank you.
For your attention is offered a report based on the results of scientific and practical research on the topic methodology for evaluation the performance indicators of the ergatic information system functioning. Reports researcher of the research department of the Scientific Center of the Korolev Military Institute, Roman Loboda. The efficiency of the functioning within any ergatic information system depends on the reliability of its components, technical means, and operator. The modern science allows us to establish successfully the laws of occurrence failure, occurrence of devices, and methods to forecast them, to find methods to improve reliability during their design and the following manufacturing, as well as methods and technique to maintain reliability during their storage and operation. At the same time, the individual nature and high variability of human psychological, physiological, and professional capabilities and characteristics, its sensitivity to the influence exerted by external and internal environment factors complicates the processes related to analysis, forecasting, and improvement of human operator reliability. As a consequence, due to human errors as a result of their insufficient training, unfavorable psychological factors, fatigue, occurs the majority share in all the accidents, and accidents in different branches of activity. Under such conditions, the issue related to the evaluation indicators of the effectiveness of the functioning ergatic information system is topical. Under such system, we will understand the interaction of technical means and the operator, whose activity is aimed at the time identification and processing significant volume of information flows, rapid analysis of the received data, development and optimum decision concerning the further actions. Examples of such activities are the actions of an air traffic controller, operator of an unmanned aircraft complex, operator of a radio monitoring post, and so on. To prevent a failure in the execution of tasks, it's necessary to evaluate the performance indicator of the information system in the process of its operation and compare their values with the limit value. Based on this, there is an urgent need to calculate these indicators in real time, taking into account the peculiarities of the operator's activities in specific conditions, in order to prevent the deterioration of the quality of the tasks performed by the system as a whole. To do this, we will formalize and stimulate the process of the system functioning, as a result of which we will obtain the dependence of the performance indicator of the information system on the operation reliability. When constructing a model, we will determine its qualitative composition and numerical parameters. In the future, the evaluation of the indicators of efficiency, indicators for function of the radio information system, will be carried out on the basis of the applications of the radio monitoring system. As a result of the analysis of functional systems, on the basis operational and logical interfaces, edited test analysis can be carried out on the basis of the visual scheme of the visual analysis, visualization of system analysis. Functions of system and radio monitoring is seen as a process of immediate identification, receipt and processing of information flow by the operator, operational analysis of the data received, the optimum solution for further action. In this case, we will assume that the technical equipment of the information system functions smoothly in a given interval of time. Under this condition, the efficiency of the radio monitoring system
will be determined by the timeliness and accuracy of decision-making by the operator. As indicator of performance under conditions of uncertainty, the probability of this or that event will be used. Therefore, as indicator of efficiency of functioning of the system of radio monitoring, we use the probability Pt. Under the probability of error-free decision-making by the operator, Pd. Let's consider the first indicator, the probability of timely decision-making. The method of estimation probability for timely decision-making by the operator of radio monitoring system will consist of the steps shown on the slide. Let's consider the order of evaluation the selected indicator in accordance with the given methodology. For this purpose, at the first stage, let's make the probabilistic-oriented graph of radio monitoring functioning. The corresponding graph is represented on the next slide. The given probabilistic-oriented graph corresponds to the algorithm of radio monitoring system functioning and is a graphical representation of individual operations and allows to describe the algorithm mathematically, to estimate the time and probabilistic indicators. Each vertex of the graph corresponds to operation according to the numbers. At the second stage of the methodology, we obtain the time indices of the individual operations. On the slide, there is a table with the list the operator's operations of radio monitoring system, the numbers of which corresponds to the numbers of the probability-oriented graph. For each operation, the corresponding time indices are set by expert method. At the third stage of the methodology, we will perform the transformation of the graph using the rules of combining paths without branches and with branches, shown on the next slide. Using the rules, let's calculate the time indices of the equivalent vertex of the graph. Obtaining time indices of the algorithm of radio monitoring system operators activity gives the possibility to find the probabilities of timely decision-making by operator at arbitrary moment of time. On the fourth step of the methodology, let's calculate the average deviation of the operator's decision time. Taking into account that the operator's decision time is distributed according to the normal law, we will find the average deviation of the operator's decision time according to expression 1, which is shown on the slide. At the last stage of the methodology, we will calculate the probability of timely decision-making by the operator of radio monitoring system by expression 2. Let's move on to consider the second indicator, the probability of error-free decision-making by the operator. The method of calculation of this indicator is shown on the slide and consists of 4 stages. The first stage of the methodology provides the compilation of probability-oriented graph of radio monitoring system functioning. The corresponding graph was made at the first stage of preliminary methodology, was shown on the slide 4. Therefore, let us proceed to the second stage of the methodology, which involves determining the number of possible solutions for each operation, determining the number of states n. By expert polling, we determine the number of possible solutions for each operation, determining the number of states n. The results are shown on the slide. In the table, the number of operations correspond to the number of the probabilistic-oriented graph. On the third step of the methodology, let's calculate the probability of the error-free decision by the operator when performing each operation at an arbitrary moment of time by expression 1, which is shown on the slide. This expression was obtained on the basis of informational analysis of decision-making process. The basis of the informational approach is the fact that the most significant factor that affects the error-free decision-making is the amount of initial information. Accordingly, for any complex system, an increase in the amount of initial information leads to an increase in the probability of an error-free decision by an operator. At the final stage of the methodology, we make a rearrangement of the graph using the rules of combining the paths without and with disconnections, and carry out the calculation of that is the probability of the decision making by the operator without compromise. In order to verify the suggested method for evaluating the indicators of efficiency and functioning of the system, we made calculation of the probability of timely decision taking and probability of poor decision taken by the operator of the information system for the range of chances, the coefficient Kr, which equal from 0 to 1. The obtained results are shown in the table for which the corresponding dependencies were created, which are shown on the slide. Analysis of the data obtained shows that at the initial stage of reducing the operator's reliability up to Kr04, the performance indicators of the system functioning practically doesn't change. This can be explained by the inclusion of human compensatory mechanism. After a certain value, a sharp decrease in the performance indicators of the system functioning to critical value is observed. The developed methods constitute the content of the generalized methodology for evaluation the performance indicators for ergodic information system based on an algorithmic model of the operator's activity. The methods take into account the reduction factor of operator's reliability, made it possible to obtain an estimate of probabilities for timely decision-making and probability of error-free decision-making by the information system operator in real time while on duty. The report is concluded. Thank you for your attention.
The topic of the report is simple autonomous security system based on Arduino Uno platform and fingerprint scanner model, a study case. In the modern world, biometric information protection is one of the most effective methods for its preservation. Biometric security technologies are becoming more and more everyday attributes of the ordinary person's life. In recent years, they have become extremely widespread in the production of mobile technology. Fingerprint scanners, face geometry scanners, and voice recognizers are built into smartphones. All this makes the life of an ordinary user much more convenient, quieter, and safer. Precisely the same devices are now very often equipped with personal computers, smart houses, and many other computerized equipment. Biometric systems are also quite popular among enterprises, where the entrance to the territory or access to information is open to a large but limited number of people. At the checkpoints of such enterprises, specialized equipment is usually installed that allows you to identify your person through the iris of the eye, the geometry of the hand, face, or through the drawing of papillary lines on the pads of the fingers, and sometimes all together. In this paper, we proposed a simple autonomous security system that based on the Arduino Uno and fingerprint scanner model that can be used for education. A written program or code is called sketch. In this work, the Arduino IDE is used as an environment in which the Arduino Uno program is written, compiled, and uploaded on the Arduino board as depicted in Figure 1. The Arduino can be connected to a computer through the USB port and programmed using a language similar to C++. In the first stage, we must control the fingerprint sensor model with the Arduino. It is by using the Adafruit library for this sensor. Having the fingerprint sensor module wired to the Arduino, we must follow the next steps to enroll a new fingerprint. Make sure you have installed the Adafruit fingerprint sensor library previously. Figure 2. You will be asked to place the thumb finger twice on the scanner. If you get the print matched message, the fingerprint was successfully stored. If not, we repeat the process until was success. Figure 3. Now we should have several fingerprints saved on different IDs. Figure 4. Next stage is place the finger on the scan for identified. On the serial monitor, we can see the IDE user that matched the fingerprint. It also shows the confidence. The higher the confidence, the similar the fingerprint is with the stored fingerprint. Figure 5. Figure 6 shows pins of the fingerprint sensor model. The connection schema is quite simple and it's rather difficult to make a mistake. Figure 7. Next, it's Figure 8 shows connection schema for experimental demonstration of the simple autonomous security system. And conclusions. The simple autonomous security system that can be used for individual or different commercial security, as example personal data, based on the fingerprint scanner model and Arduino Uno. The Arduino was connected to a computer through the USB port and programmed using a language similar to C++. Programming code or sketch was uploaded in the Arduino using program software Arduino IDE. Connection schema and experimental results are also presented. Thanks.
Hello, dear colleagues. Today I want to present you our work on the topic implementation of probabilistic data structure in the processes of near evolutionary synthesis. So let's start. In this slide, you can see the advantages and disadvantages of near evolutionary approach. Usually, when we talk about near evolution, we can say that this is alternativity approach for the synthesis of neural nets. And as any approach, it have some pros and cons. The main advantages, it is using with different learning strategies, the high level of adaptivity, the parallelization of operation. But we have the list of disadvantages. And the many of disadvantages can be explained by the one. It is high level of resource consumption. And how we can solution it. Let's say at the next slide. Probabilistic data structures. Probabilistic data structures, it is very interesting group of data structures. We usually talk that we use in some hash functions for the coding of input information. And as a result, we have the hash of our input data. And what is more interesting, the last work on this topic demonstrates that we can compress our data for the 90%, for example, and this is really good result. So how we can implement the probabilistic data structure during the naive evolution synthesis? Usually we talk about two cases. First case, it is sequential execution of naive evolution, and the second case, this is parallel execution. In two cases, we usually talk about very similar implementation. This is coding of genetic information about individuals in our population. This will be the neural nets. And what is more interesting, when we talk about sequential execution, we can say that we will have some very interesting stages at the stage of mutation or some variation of our individuals, and at the stage of recombination, when we will selection some really the best solution for it. In the parallel system, we usually say that we can't use probabilistic data structure during we work on the threads or in the different course, but we can use it when we transfer data from the main or to the main core during the execution. In this slide, you can see the main probabilistic data structure which we will using during the work. This is Bloom filter, min hash, and count min sketch. This is well-known data structures with very huge background, which can be really interesting and useful in our work. So, compression of the probabilistic data structure for the work. As you can see, we make some compression, and I must say that min hash and count min sketch we will use during the sequential execution, and Bloom filter we will use in the parallel case. In the next slide, you can see some information of data set which will be using during the training, and some metaparameters, because when we talk about naive evolution approach, we usually talk about some metaparameters which can changes. And we have some difficulties at this stage, because count min sketch and Bloom filter can make some changes in structure of coding information. But when we talk about min hash, we have some problem in this stage. So for the min hash, we will use only one epoch for the synthesis, the best solution. And in the case of using Bloom filter and count min sketch, we usually talk about the 5 epochs. In this slide, you can see the first part of result. This is using the sequential execution of evolution, and what we can see. We have really not a bad result of using memory. And the synthesis time really came more smaller. But when we talk about min hash, we must say that during the training, we have not bad result. But when we talk about the testing, the accuracy not so good. Yes, it can be explained that we use only one epoch for the synthesis, the best solution. But this is not so good. And what is more interesting and important, we have not so good synthesis time. Yes, it came smaller, but not so good. During using count-min sketch, we have more optimistic result because accuracy not so bad. We really can see that very balanced using of memory, but the time in this case came more smaller, but not so good. So, we haven't got some balanced result. If we talk about the balance between the synthesis time, the accuracy of final neonet, and the using of memory during the synthesis. Bloomfield demonstrate more good result because in this case we must say that we have not so bad error. We have some not so bad result for the time, and communication overheads really goes more smaller, and this very important. But in this case, we must say that accuracy not so bad. So what we can say as a conclusion of all this manipulation? Yes, really. Use probabilistic data structure during the evolution synthesis demonstrate not bad result and have some advantages. This is compact data storage and forwarding. This is really speed up during the compression of neural nets. This is really some level of optimization of using the resource. But we have the list of difficulties, and these difficulties can be explained by the one case. Really, complicity of coding and encoding the information about neural nets. In our case, the genetic information of neural nets. The question of coding and encoding the genetic information about the neural nets in evolution, very important question. And in this case, we can say that we have problems because before the mutation and crossover, we must know the accuracy information about our individuals. And using probabilistic data structures can't give to us really accuracy information. So, as a future work and in the future plan, we can use probabilistic data structures for the coding of information of pre-synthesis neural nets. So, during the evolution, we have the best solution, and we must transfer it, for example, from the server to our working station. And for it, we can use probabilistic data structure, because we will have really compact information about this neural net, and it can be transferred for another working station. It can be explained by the real good result of reduction of time of synthesis and reducing the communication overhead in parallel system. So this is final of my presentation. I want to thank you for attention, and your ideas will be welcome as a comments. Thank you. Goodbye.
The topic of my presentation is software for statistical processing and modeling of a set of synchronously registered carrier signals of different physical nature. Authors are Serhiy Lupenko, Yaroslav Litvinenko, Boris Shelestovsky, Andriy Sverstyuk, Andriy Horkunenko. I'm the reporter. My name is Andriy Horkunenko, and I'm from Horbachevsky Ternopil National Medical University. The cardiovascular disease in the world are serious problem. The medical social burden of circulatory system disease, especially exacerbated by a rapid spread of COVID-19, and is that they significantly affect
the duration and life quality, the loss economic potential indicators of countries. That is why the fight against disease of circulatory system at the present stage is priority problem of modern medicine. Analysis of cardiac signals based by their processing in the cardiac diagnostic systems. And the effectiveness of modern cardiac diagnostic systems mostly depends on the hardware and software components on which they are based. On the bottom, we can see the diagram that show the life cycle of creating cardiac diagnostic systems. Incoming information, purpose and tasks of modeling, and also the properties of cardiac signals. Then there's mathematical apparatus of cardiac diagnostic systems. This includes mathematical model of cardiac signals, methods of processing and simulation of cardiac signals, and the algorithms for processing and simulation of cardiac signals. And then we implement the mathematical apparatus into software hardware of cardiac diagnostic systems that include software for processing and simulation of cardiac signals and cardiac signal processing and simulation hardware. So the quality of software hardware of cardiac diagnostic systems depends on the quality and efficiency of mathematical apparatus of cardiac diagnostic system. Objectives. The paper is devoted to the creation and application of software for statistical processing and modeling of synchronously registered cardiac signals as components of cardiac diagnostic systems. The importance of this study lies in the possibility of using a common rhythm in the modeling and statistic processing of different in nature cyclic signals, but formed by a signal source. On the bottom, we see the examples of synchronously registered cardiac signals that are coming from one source. That's A, that is an electrocardiogram, B, that is a phonocardiogram. As a mathematical model, we use a vector of rhythmically connected stochastic processes. The definition of this model is if there is a function such as t from Tn, which satisfies the condition of the rhythm function that finitely measurable vectors, we see the vector, the row of the vectors, where T1, Tk, that is a multiple separability of the vector for all the integers more or equal 1 are stochastic equivalent in the broadest sense. We will call the vector of cyclic stochastic processes as a vector of strictly rhythmically connected stochastic processes and the processes as strictly rhythmically connected. The use of model is based on the rhythm function. The rhythm function t from Tn determines the law of changing the time intervals between the single phase values of the vector of cyclic rhythmically connected stochastic processes. The function of the rhythm satisfies such condition according to theorem. There's 1 and 2 conditions, and number 1 includes 3 points when this rhythm function more than 0, equal 0, and less than 0. And so generally rhythm function help us to determine the changes in the rhythm of cardiac signals. Here are some probabilistic characteristics presented. Number 3, that is for compatible k-measurable distribution function, and number 4, that is combined central moment function of order P. Also, in addition to this characteristic, we find the mathematical expectation and variance. Here, results are presented. So we make the analysis by using the well-known mathematical model in the form of vector of periodically connected stochastic processes, and we compare the result with our mathematical model of vector of cyclic rhythmically connected stochastic processes. So the top row, A and B, that's the realization graphs for statistical estimation of autocorrelation function of electrocardial signal. A, that's when we use well-known vector of periodically connected stochastic processes. B, that's when we use our model presented in the paper. That is the vector of cyclic rhythmically connected stochastic processes. C and D, that's the realization graph for statistical estimations of autocorrelation function of phonocardial signal, while processed based on C, that is a vector of periodically connected stochastic processes, and D, that is the vector of cyclic rhythmically connected stochastic processes. The bottom row, on the bottom, that is the realization graph of statistical estimations of mutual correlation function of electrocardial signal and phonocardial signal, while processing A, that is using the vector of periodically connected stochastic processes, and B, that is a vector of cyclic rhythmically connected stochastic processes. In conclusion to this analysis, we can say that we compared the analysis of using our model and the well-known of vector periodically connected stochastic processes. And we see that our model decreases the variability. The graphs are more smooth. That indicates the efficiency of our model compared to the well-known model of vector of periodically connected stochastic processes. As implementation of mathematical apparatus, we see the result in the form of software complex for statistical processing and synchronously registered cardiac signals. This complex includes a block of synchronously registered cardio signal formation, block of pre-processing, block of segmentation, block of determining the rhythm function, block of statistical processing, block of informative features, vector, and block of diagnostics. This slide demonstrates the structural functional schemes of the program. That's on top for compatible statistical processing, and on the bottom that's for simulation unit taking into account the rhythm function. This slide demonstrates the software design. A, that is the program interface for data input, then B for data visualization, then C for statistical processing through the period, and D for statistical processing based on the rhythm function. Conclusion. A set of programs has been developed that allows performing a statistical processing of carrier signals of different physical origin and to obtain estimates of mathematical expectation, variance, autocorrelation, and cross-correlation function. Taking into account the function of rhythm and period, the software allows to simulate the implementation of cardio signals of different physical nature, taking into account the constant rhythm, variable rhythm, and the common rhythm. The modeling methods include information obtained at the stage of statistical processing and cardio signals. In particular, morphological features are taken into account on the basis of estimates of mathematical expectation and variance of carrier cycles. Developers' software provides the possibility of forming a discrete rhythm function depending on the number of cycles and zones of simulated carrier signal. This software can be used as a component of diagnostic systems of the human heart. Thanks for your attention.
Dear colleagues, I'd like to present a report Bioobjective circular hole-based topology optimization problem in additive manufacturing. Circle packing problems have a wide range of industrial and engineering applications, for example, facility layout design, cutting stock problems in the glass, metal, paper, textile, and wood industries, etc. One of the most topics of modern mechanical engineering is reducing weight while maintaining specific characteristics of structures designed. Such problems with conflicting criteria are related to decision making. A key objective of the problems is finding optimal geometric shape and topology of the design product, ensuring minimum weight at specified strengths. To this end, topology optimization methods are used to find the best design parameters, satisfying the technological and strength constraints, and thus providing the objective function extremum. The problem consists in finding the best placement location and geometry for holes within the modeling area. The circular holes are known to help avoiding stress concentrators due to absence of sharp corners. The aim of the work is to construct a mathematical model and a fast method of placement a number of circles of variable radii into a polygonal container, being a union of convex polygons to take into account two objectives: the packing
factor and the maximum mechanical stress. We first propose a biobjective formulation for circular hole-based topology optimization, which takes into account both the packing factor and the maximum mechanical stress of paths. A new approach for packing circles based on a modified finite Apollonian circle packing and optimized homothetic transformations of circles is suggested. Both techniques allow to arrange circles within polygonal paths, minimizing material expenses. The epsilon constraint method is applied to find out a trade-off circular arrangement. We consider a polygon and define a disconnected polygonal domain consisting of convex non-overlapping polygons being contained in the given polygon. Let us also define a collection of circles of variable radii bounded from below and above. The biobjective circle topology optimization problem is formulated as follows. Pack circles into the given domain, providing containment of circles into the polygons, meeting the minimal allowed distance between the circles, and maximizing the packing factor while minimizing the maximum mechanical stress. The packing conditions are analytically described using the 5-function technique, which makes it possible presenting a mathematical model as the following by objective problem. Packing parameters and radii of circles are variable. Two objective functions. The first is the total sum of the circle areas, and the second is an implicit function which defines the maximum mechanical stress depending on the center coordinates and radii of circles. Feasible region is given by packing conditions described by functions and restrictions on the lower and upper bounds of circles radii. We note the objective functions are compromising. Our aim is to find a trade-off solution of the biobjective problem. On the assumption that an accepted value of the maximum mechanical stress is tolerable, we solve the problem by means of the epsilon constraints method, known also as the main criterion method. The method reduces the problem to a single objective one. The main objective is maximizing sum of squares of circles to be packed. We temporarily relax the restrictions on the maximal mechanical stress value, solve the single objective problem, and can evaluate a posteriori the maximum mechanical stress for the obtained topology. We decompose the problems into several subproblems separately for each polygon. Our multi-step strategy involves the following main stages. Stage 1. Define a lower bound of the number of circles which can be packed into the appropriate polygon with the maximum packing factor, using the known algorithm based on packing equal circles. Stage 2. Generate feasible points for the problem according to Apollonian circle packing. Stage 3. Search for a local maximum point of the problem using interior point optimizer. Stage 4. Choose the best local maximum point satisfying the maximum allowed mechanical stress. In accordance with Apollonian circle packing, starting from 3 mutually tangent circles, next circles are ready to be tangent to the 3 circles forming 4 mutually tangent circles, or tangent to the frontier of the container. We modify Apollonian circle packing for taking into account the upper bound of circle radii and the minimal allowed distance between the circles. Some circles are allowed to be moved within the container and located to positions which give a possibility to enlarge radii circles of next circles being packed. We consider the benchmark geometry presented in the previous investigations and provide new benchmark examples for packing circles with variable radii. Studied is the dependence of the number of circles packed and the packing density on the minimal allowed distance between circles. A graphical illustration of the results is presented on the slide. The runtime was within 30 seconds for all examples. As computational results show, with an increase in the minimal allowed distance between circles, the contribution of large circles into the total circle area increases, since it's proportional to the squares of the circle radii. Obviously, this leads to a decrease in the number of circles with small radii and an increase in the radii of other circles. In this regard, the choice of the minimal allowed distance is of importance. A compromise value should be chosen. A too low value can lead to poor quality printing due to the technical features of the process, while a too large one causes additional material consumption. Conclusion. Topology optimization is a key point in additive manufacturing. Circular hole-based layout models help to cut down material expenses while meeting strength requirements. We formulate non-standard packing problem of circles with variable metric characteristics. The proposed bi-objective model takes into account both the maximum packing factor and mechanical stress of paths. An efficient packing algorithm based on Apollonian circle packing, nonlinear programming, and the epsilon constraint methods has been developed. The approach allows estimating the number of circular perforations needed to and search for an approximate solution of the problem, maximizing the packing factor and following a threshold value of mechanical stress. Further research is directed to layout of circular perforations inside a 3D part considering balancing conditions. There is a more nuanced approach to multi-objective optimization should be constructed. Thank you for your attention.
Dear colleagues, good afternoon. Greetings from the National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. Our team today would like to present our research data mining methods for elevation and forecasting the mobile internet traffic in roaming. This research was done by our team several years, and it was devoted to such real and actual practical tasks for the telecommunication industry as forecasting the main services in roaming.
Today, mobile operators are really interested in resuming their services, especially including mobile roaming, because it was observed that before COVID-19, it was really practical and really important for them tasks in order to predict such services like mobile internet volume, including abroad. It is needed to develop the special optimal packages and behavior of subscribers. And of course, it is needed to take into account how they use certain services within their own country, and then to predict it in future how they will use such services, especially abroad. In future, of course, it would be possible to them to predict how such subscriber will behave abroad, how they can use these services. For this reason, we develop and propose to use modern methods. And of course, we need to develop our own models based on data mining and forecasting methods. Special mention here should be paid to such possibility as virtual operator. Even in Ukraine, we can admit that we have such operator like Luka Mobile, which give us the possibility of roaming technology, let's say, and rent communication equipment inside our countries. Actually, every subscriber, every user of such virtual operator is in roaming already within his own country, and therefore the information of the Ukrainian services and how it is used by different subscribers really important. Roaming is such situation when a mobile operator subscriber uses the networks and equipment of a mobile operator abroad, outside of the geography of our own country. For our research, we decided to make such problem statement as to develop the special roaming services based on development different models. And concentrated on developing the special informational tools and developed our own strategy based on predictions of volume of services. Here we mention the main services used in Ukraine, such as calls and traffic for a particular subscriber. And for this reason, we need to develop the new mathematical models for analyzing the consumption and using of such services inside our own country, and of course to forecast the services that will be used abroad. It is necessary to predict the volume of mobile internet because right now it is the most popular services in Ukraine. Almost every subscriber uses internet, so it is important to understand what will be the volume of using packages abroad. And of course, it is needed to classify somehow subscriber by their using of the packages of the internet inside their own country, and to provide them the possibility to choose appropriate package outside the country. Finally, of course, it is needed to develop the special techniques and approach to increase the number of subscribers who will use such services in roaming, and to develop the special strategy for the telecommunication company, which gives the possibility to increase the quantity of such services. As for our opinion, the main methods and techniques and tasks which could be used during this research, we used the popular and the most promising techniques which were announced on the workshop of the company SAS in September 2020, real-time statistics, analytics, and cybersecurity, where it was announced that big four are still really popular, and more promising methods such as gradient boosting, random forest, neural networks, support vector machines, and of course the good place is for the logistic regression method. So in our research, we decided to use these methods and to develop our own models to construct. They are based on such techniques, but
also to use bootstrap analysis, time series analysis for solving such tasks as roaming forecasting and mobile internet traffic, especially based on special data mining methods. In our research, it is needed also to admit that we have made also multi-label classification. For this reason, we also propose to construct a special confusion matrix based on the multi-dimension, and for this reason we need to develop own strategy how to divide the clients. In total, we have the data set which contains the records for subscribers who are using roaming services. The mobile operator give us 120,000 records, the data of subscribers who were traveling abroad. Actually, it was 10,000 different random records from users for each month during the year. So in total, it was 120,000. The input data contains, of course, such following characteristic as their previous experience in the using of services in Ukraine, such as before, let's say, the months going abroad. It gives us the assumption about the history of using services in Ukraine. And of course, it wears a series of characteristics and reflect the features and types of services and some different packages used for the subscribers when it was previously in abroad. In total, we have defined more than 15 characteristics that describe the subscriber behavior characteristic in Ukraine and abroad. And of course, we had roaming experience, such as GPRS, minutes, and SMS as the most popular services abroad still. And as experimental study, we decided to firstly to solve two different tasks. One task, as you can see on the slide, is the task of prediction the services amount in roaming. For this reason, we need to understand what will be the volume of traffic which is needed for the definitely subscriber based on some statistic. For this reason, we decided to use regression models and predicted such a target variable, as you can see on the slide, the volume of GPRS mobile data traffic. We decided to try to auto-regression models, but we made firstly visually, but then we did also the tests such as Dickey-Fuller and KPSS, which confirmed that time series not stationary. That's why we need to remove firstly the order trend, and then after it became stationary, and that's why we can use simple auto-regression models. For this reason, we find the best models in table 1 that it was the ARMA model with parameters 2 and 6. The results of prediction actually based on this model, or you can see also on the slide, and we need to admit that we decide for the next 6 months to predict ahead the services which will be used in total by all subscribers in roaming, but also separately by each subscriber, and it gives us quite good results. The next task which we were solved, it was the classification task. As a mobile operator has the possibility and needed for the information how to group the whole users, we need to admit that we made multi-classification, so we did 4 classification for different classes for our subscribers. The first class, as you can see, it is the most full and the most frequent class. It is the class where a subscriber didn't use the services at all. It means that still are a lot of customers who are afraid to use mobile internet in roaming, mobile services in roaming, while they were used that it was quite expensive. But for now, we need to admit that in several years before COVID, the price for such services become less. So the quantity of subscribers who use the services become more and more. And we expect that after the COVID situation, our forecast and our developed models gives the mobile operators the assumption how to deal with such clients and how to promise them that the services are not so expensive. So in total, we divided in 4 categories. As you can see, there is a small quantity of subscribers that use more than 500 megabytes. So as you can see, we need to make a lot of preparation of the data. So in total, we did different stages of preparation for solving the classification task. The first one, it was data processing and preparation. For continuous variables, it was used discretization, splitting a continuous variable into some categories. For categorical features, it was made the special direct coding, or let's say one-hot encoding, coded with one active state. And the basic idea was to replace the categorical variable with a new variable by formula for linear binary classification. And that gives us the possibility, let's say, n new features that are created for categorical figure. The next stages, it was preliminary data processing. The whole data set was divided in 2 classes, training and test data set in such division. And the next stage, it was made for balancing the number of records, because we appeared that small classes had, let's say, some imbalancing, and for this reason we need to increase their weight for training set. For this reason, we used the synthetic minority oversample technique, in which records are not similarly duplicated, but also artificially generated based on examples and real representatives of the classes for minor derivation. The next stage, it was the using of special statistical characteristic for checking the classification quality used in our data set. We decided to make multi-label classification confusion matrix. In general, the error matrix is in dimension n to n. In our cases, while it was only 4 classes, we made it 4 to 4. And we decided what will be the most important for our variables. It was false negative, first kind of errors, and also false positive, second kind of errors, which give us assumption to use the best models based on the fact that the second kind errors are more acceptable for marketing decision. It is good when the subscriber was forecasted that it will not use mobile internet, but actually it used. It is good for us because the first kind error, it means that potentially used forecasters are not used their internet. And for this reason, we decided to use such characteristic metrics as accuracy, precision, recall, and also F1 score, and extra one, it's Matthew correlation coefficient, as you can see here. After that, we decided to make the simulation for our data set, and for this reason, we used 4 methods: logistic regression, neural network, random forest, and gradient boosting, as more popular and more promising methods for our task. As you can see that based on our statistics, we built also the quality classification comparison models by different classes, and it appears for different classes that the best model, it was the model based on the gradient boosting. After that, we developed some suggestion for our subscriber and also for our mobile operator. So we developed such proposals that may provide some extra benefits for the clients. For example, for the first type, subscribers who are in the group less than 0, it means or equal to 0, that the subscribers that are not using internet, to send them announcement and to send them SMS and only once, and to give the smaller packages.
for them. For subscribers who already use and they are in the second group, it is a proposal that to offer not 100 megabytes but extra 50 megabytes in the second purchase package. In this reason, we can encourage the subscriber to use more than one package and, of course, to order one more packages. For subscribers that are classified in the third group, the subscriber are used less than 500 megabytes. We offer to purchase TU promotional data, a special package, for example, 500 megabytes with 5% of discount. And the subscriber that use more than 500 megabytes, of course, it is good reason to offer them in immediately purchase 1 gigabyte services package instead. Thus, we are more interested in such clients that are using more packages. The first scenario give us assumption and implementation of using such models, and in total, as you can see on the slide, the main conclusions that we can make during our research that, of course, analysis of behavior of our users, it's really important. Data mining techniques give us the possibility, based on statistical data, to develop new tariff packages and to retain existing subscribers to use the services. And to build different classification models, we can use that after the situation. We hope that it will happen really soon. The borders are opening between the countries and international travel become more active. We can give new strategy for the mobile operators, new packages, how to include more clients, how to interest them to use mobile internet abroad. And for this reason, we recommend to use gradient boosting and to use such model based on the broader marketing campaign, which give us possibility to include more subscribers to use internet. And of course, we still are doing our research with telecommunication operators, and the next and further stages of our research it is planned to analyze different types of another services because they are still popular, such as calls and SMS, and also to cooperate with different departments and to solve different tasks on different measures and different layers, such as to develop and forecast the quantity of the needed equipment for provided services, not only in national but also on the international vectors. Thank you very much for your attention, and we will be glad to discuss with you our research.
Good day. I would like to present our scientific research work on topic of it, optimization of data transmission system, information parameters for complex technical systems, state diagnosing. Nikolai Dudchenko is the speaker. Problem relevance. Considering the problem of diagnosing complex technical systems, these are objects often with mutability, uncertainty or behavior a large number of correlated parameters functioning in tens of normal rules and modes. The purpose of complex technical system state diagnosing is to improve reliability, prevent accidents that cause shutdown and damage to systems, in many cases accompanied by human causes and damage to the environment. Analysis of technical solution that improve the reliability of the complex technical systems operation showed that timely and high-quality diagnosing, including remote diagnostics of the CTS components, can improve the reliability of system and their operation efficiency. To successfully solve problems of complex technical system accident-free operation in abnormal operating modes, it's necessary to maximize the use of information technology with software and hardware diagnosing modules. The article's goal is to maximize a complex technical system remote diagnostic system efficiency by optimizing the information parameters. The work objectives are
analyzing of literature and study area, destination and substantion of research problem, a development and description of mathematical background for problem solving, data transmission system for complex technical system state, remote diagnosing, development, and research of the optimization results. Block diagram and data transmission system for diagnostic the system, the complex technical system state. We can see that measurement switching through to text signal generating and information processing to the block of memory. Also the exit of information processing block puts on the input of display and registration, and so on. Block diagram of the data transmission system model for diagnostic of state of the complex technical system by chip is presented in our work, and data sources goes to the controllers and put it next to the server. After that, the decoder makes it happen with transmitter through the link connections, go to the receiver and grid. Next blocks are decoder, gateway, local network, and server, the second server, and destination. And we would like to say that information transmission is carried out based on the use of one of the standards for digital information transmitting systems, such as WiMAX, LTE. The accumulated diagnostic data of the complex technical system conditions is sent in the form of reports to the coastal diagnostic center. Data transmission system efficiency characters might be described as a topology, throughput, performance, permission data transmission error, efficiency of information protection in the system, risk of data transmission system device failures in remote diagnosing. The generated indicators of the quality of the functioning data transmission system in research in remote diagnosing system is determined by the results of information parameters optimization, as well as its reliability characteristics. Data transmission topology, system topology indicators optimization, objective function can be presented in the form of a maximum of D, B, and C, where D is the length of the data transmission path, K is the compact structure of the system, C is the degree of system structure centralization, so on. Complex technical system parameter monitored failure risks can be described as RS and 0, which we can find through the multiplication of PS and O to HS and O, where P, S, and O is a probability of complex technical system parameter control device failure determined on the basis of an expert estimates. H, S, and O is the damage from failure of complex technical system parameter control devices, and so on. The structure of the data transmission system in remote diagnostic software can be described through a couple of blocks. For example, parameter coding device, complex technical system, controllers, dispatcher workstations, optimizing modules, and remote address workstation, which includes graphical user interface, report generation software, database, and database update software, which is combined in a few blocks. Perhaps the optimal solutions for the capacity relative to the aggregate is shown on our graph, and we can see that solution of optimizing problem of the information parameters of data transmitting system in a remote system based on the development of model allows us to find several Pareto optimal solutions for the quality indicator. For example, the data transmission system throughput, which affects the efficiency of the remote. As a conclusion, we would like to say the developed model of optimization of information characteristics of the complex technical systems state data transmission system in a remote system allows us to exclude the influence of the human factor when taking into account the complex technical system various technological parameters, generate reports on complex technical system states at any time for any reporting period for the subsequent analysis, monitor the state of complex technical system in real time, which will avoid accidents during their operations, to reduce the risk of the data transmission systems in remote elements failures, and improve the data transmission system efficiency at all. Thank you for your attention.
Hello everyone. Our research topic is method for visual video defects detection using machine learning. The evolution of digital systems has led to the active development of multimedia systems and applications such as IPTV, mobile multimedia, video conferencing, and educational multimedia presentations. These multimedia applications have become an integral part of everyday life, and they are expected to grow in the future. Video quality is an important factor of success for companies that provide video streaming services. It has been proven that even minor visual defects can significantly decrease viewer satisfaction and therefore lead to huge financial losses. Since nowadays there's a wide variety of consumer electronic devices capable of video streaming, such as TVs, smartphones, and laptops, as well as due to the fact that network bandwidth is changeable, the video file needs to go through many modification stages before reaching its end user. Unfortunately, there is a probability that a visual defect will be introduced in any of those stages, such as encoding or compression. If the video defect is identified quickly, it can be eliminated before it reaches the end user screen. So our goal is to automate the video testing process by introducing a new way to identify visual defects, which will use machine learning. The current approach in the industry is called subjective testing. It implies that there are people who watch the video content and give their subjective opinion on the quality. While this approach has its advantages, there are many significant drawbacks, such as that there's always a need for human resources to conduct testing. There is high quality of testing equipment, and it's very time-consuming. In our approach, we created a novel defect detection model using machine learning. It can mimic human perception and therefore give consistently reliable results without a need of expensive equipment. Since we deal with visual data, we need to use convolutional neural networks so that the training process is efficient. Our network architecture consists of 3 convolution layers and 3 pooling layers, followed by 2 dense layers and a dropout layer. Its input is a 160 by 90 pixel colored image. Output is a single value, which is defect probability. In order to construct a dataset, we handpicked a few Creative Commons licensed videos from the internet. To provide best learning results, we have selected videos with diverse content genres as well as different camera movements. After introducing visual defects and adding labels, we received nearly 130,000 of training examples. Later, we used the data augmentation to get even more samples. Experimentally, we have discovered that using image flip proves to be the best in this case. This might be explained by the fact that different augmentation techniques might introduce distortions in the images that have been previously marked as original, and that would confuse the training process of the network. We trained the model using TensorFlow, Python, and Keras. The model achieved accuracy of 98.5% on validation data, which is enough to provide reliable results. Using the created model, we created a prototype of a software system that predicts presence of defects in the given video file. It works by performing three main operations, which are retrieving the frames, analyzing them, and then saving results. It outputs a graph of defects probability. Normally, at this point, a person who is responsible for the testing process would need to take a look at the diagram and investigate the defects that have been found and most likely take measures to fix those defects. To summarize, we created a high accuracy model that can predict defects in frames of videos. We then used it to build a prototype of a software system that outputs probability of defects in a given video. The use of this system can significantly reduce the cost of video testing and increase the quality of service that the end user receives. Thank you.
Dear colleagues, I would like to present our study, an approach to development of interactive adaptive software tool to support data analysis activity. It was prepared by me, Andrei Kop, and my co-authors, Dmitry Orlovsky and Ivan Bilaus. Today, databases are used to keep large collections of enterprise data in almost any organization. But having such data volumes without interactive and flexible data querying tools becomes pointless, since data must be used as the source for analytical processing, data visualization, and business decision-making. Database query languages require technical training and experience for their usage, while so-called query wizards of database management systems have limited functionality and still complex enough for non-technical users. Therefore, a software tool for interactive and adaptive data querying should be developed in order to support data analysis activity. The software system for interactive and adaptive data analytics should be developed for two user roles: database administrator and data analyst. There should be introduced a recommending technique that will analyze query execution statistics, taking into account query execution frequency in order to suggest the most relevant database queries. Then, it is supposed to limit the set of frequently executed queries to three most popular ones, for each of which will be suggested two most similar queries. In total, we expect to provide the list of 9 the most relevant queries to users' preferences. The number of recommended queries has been chosen according to the 7 ± 2 rule that defines suitable number of objects for human perception. According to the proposed approach, the statistics of database queries execution should be captured in order to formulate the list of relevant queries for each user by each data source. To solve this problem, we need to use certain recommending approach. Among variety of solutions, we have chosen a content-based filtering approach, which is based on the vector space model. Using query parameters gathered as keywords for content-based filtering, we may use the technique similar to recommending systems of other problem domains. Suggested recommendations on database queries then might be utilized by users as is or with certain changes. The idea of application the content-based filtering to database queries recommending procedure includes assumption that SQL statements are inquiring stored procedures deployed on the database server and used as data sources with given parameters. Then, SQL statements that call such stored procedures could be considered as documents, while pairs of procedure parameter names and values could be considered as terms. In content-based filtering, the TF-IDF measures are used to evaluate terms within separate documents and within documents collections in total. These measures are well known. Therefore, their calculation and normalization formulas are presented only in the full text of our paper. In order to compare SQL statements represented as vectors of normalized TF-IDF measures, we can use cosine similarity. This example demonstrates application of the content-based filtering technique to SQL statements that call stored procedure, returning a list of students by two parameters, year of admission and country of origin. Let's assume such procedure was called 10 times with varying parameters. Gather statistics of query execution is demonstrated in displayed table together with vector-based description of parameter values used in executed queries. After TF-IDF calculation and normalization documents 1 and 4 could be described using outlined vectors, which similarity is equal to 0.61. Another document which similarity to the first document is greater than 0, it's equal to 0.42, is seventh document. Therefore, we have found two queries similar to the first one, which could be recommended to a user as irrelevant. Proposed recommending procedure summarizes all previously outlined assumptions. It defines the sequence of steps necessary to select interested data source, represented by a stored procedure, process statistics of query executions for this data source, calculate TF-IDF measures, find normalized vectors that represent SQL queries, and detect three most frequently used queries as the most relevant ones. After that, for each of these three queries, the two most similar queries are found using cosine measure and included into the list of relevant database queries suggested to a user. Formulated functional software requirements consider categorization by two user roles, database administrator and data analyst. Database administrator should be able to manage connections so users may access different database servers, manage stored procedures so users may access different data sources, and manage data analyst profiles, so users may be granted with permissions to access certain data sources. Data analysts should be able to run analytical queries, explore data sets returned by executed queries, get recommendations based on the proposed procedure, and search for available data sources. Software quality constraints include performance, usability, security, and reliability requirements. System design artifacts include case management model prepared using CMMN notation, which represents user-centric description of system usage activities. Since database querying activity does not feel well for traditional workflow-based description, this novel technique of ad hoc process description was used. System interaction in response to users' actions and interface structure from both static and dynamic perspectives is demonstrated on the interaction flow model prepared using IFML notation. The software architecture is based on the traditional three-tier client-server interaction model. Client-side is the thin client implemented by a web browser that provides user interface. Web server contains Node.js application that implements all business logic and works with database servers. As part of software tool, the database is deployed on Microsoft SQL Server and stores user profiles of data analysts and granted permissions, data sources connection properties, created analytical queries, and gathered usage statistics. Software prototype was developed according to the demonstrated system design models and chosen software architecture. At first, it allows users to create connections to databases. For now, only Microsoft SQL Server is supported, and configure required connection properties. When connection is established, available stored procedures for certain users could be displayed for each of attached databases. Then, for each of stored procedures could be displayed a list of recommended queries which are already prepared with parameter values. Recommendations are demonstrated as querying forms already filled with respect to obtained suggestions. Obviously, querying forms could be altered if some new querying parameters should be used.
To conclude, in this study, we have proposed an approach to development of interactive adaptive software solution for data analysis. This solution is based on content-based filtering, adapted to work with SQL queries that call stored procedures used as data sources. Proposed recommending procedure uses gathered statistics of database query executions and suggests the most relevant queries by frequency and similarity criteria. For now, the software is implemented as a prototype with limited functionality, which is compatible only with Microsoft SQL Server databases. However, in future, we plan to complete the software tool development and consider usage of advanced recommending techniques. Thank you for your attention.
Good day, dear participants of the conference. With your permission, I present a work Control and Diagnostics of TV3117 aircraft engine technical state in flight modes using the matrix method for calculating dynamic recurrent neural network. Now, in the world, there is an active development of promising artificial intelligence control technologies that imitate natural processes, such as the activity of brain neurons. Artificial neural networks are becoming more widespread in applied problems. The field of aviation transport is not an exception. One of the main tasks in which is monitoring the technical state of aircraft engine of an aircraft helicopter during its flight. This work is based on a Markov discrete network that displays all kinds of changes of aircraft engine technical state as part of a helicopter power plant during its flight. For further processing of this network in this work, it is proposed to implement its representation in the form of a neural network in which each state of the engine is characterized by a separate neuron and the interconnection between them by graphs. For neural networks, graphs are interesting for their matrix representation. A convenient neural network description is the signal graph adjacency matrix. Elements of adjacency matrix are the storage of associative memory of a neural network for various purposes. This figure shows signal graphs are their corresponding adjacency matrix for forward and recurrent neural network. It follows from graph theory. If the column of the adjacency matrix is 0, then the vertex of the signal graph is a sink. And in the neural network, this neuron is an input 1. The 0 line points to the top of the source of the signal graph, and in the neural network, this neuron is the output. This is no formal concept of layers is in a recurrent neural network. Any neuron can be both input and output. The topology of fully connected neural networks is interesting for maximum intelligence when linear. It is well formalized and convenient for the algorithmization of matrix transformation operation of expression presented of the previous slide. In matrix form, these calculations are convenient because in a fully connected recurrent neural network, the number of synaptic weight is equal to the square of the number of neurons, and in the network, any neuron, including the input 1, can be used as an output 1.
For dynamic neural networks oriented to work in regulation and control systems, an important property is their inertia. In this work, the neural network was trained in the identifier mode using test graphs of the object's response to a step effect and to harmonic oscillation of the same amplitude at 3 frequencies. Test signals were generated by a circuit from recurrent expressions of sequential connection of simulation models of aperiodic links, A-links, and a circuit from recurrent expression of sequential connected of A-links and integrating I-link with negative feedback. The input data for the study of a neural network model of a helicopter aircraft engine, for example, TV3117, is a graph of the transient process of fuel consumption, which is responsible for the transition from one state of the engine to another with the settings of the structure element, pump regulation, obtained in the Dweck-Otlatka simulation. These two slides show the results of the graphs of the results of studying the learning processes of a neural network with 2 neurons, with 3 neurons, and with 4 neurons. It can be seen that the identification accuracy depends on the number of neurons, and the dynamic error of the neural network depends on the rate of change of the modeled process. The minimum dynamic error of simulation of transient processes is no more than achieved by a neural network with 4 neurons. In this work, a neural network with 4 neurons is tested for the identification of graphs under various stepwise disturbance. This slide shows the test results for various perturbations. It can be seen that the neural network is in good agreement with analytical calculation with a satisfaction error. This slide shows neural networks and graphs of transient process obtained at the output of all neurons obtained after training the neural network to identify transient processes at the output of the second neuron. 1. Output from a neuron which characterizes the engine operation mode. 2. Output from neuron 2, which characterizes the normal operation of the engine, nominal 1 cruising, 2 cruising. This slide summarizes the main findings of this work. Thus, in this work for calculation dynamic recurrent neural network, a step-by-step matrix method is proposed that use the signal graphs adjacency matrix as a storage of associative memory. Thanks for attention.
Dear colleagues, today we want to present our work on classification of hidden concepts in scientific texts. It's a long-term work that was conducted in collaboration with our colleagues from Khmelnytsky National University and was led by head of our laboratory in Institute of Cybernetics,
National Academy of Sciences of Ukraine by Dr. Yuri Krok. Now let's proceed to our related work that help to create this work and to present it today. So we studied semantic terms in scientific texts. We defined information core of the document for text classification. We studied amplitude and phase characteristics of the text. And we also studied informational density and meaning of the text. Now skip to our task. Our task in this specific work is following. First is to find inefficient features in the text. Second, to propose a compact feature representation. Third, to find hidden structures in text data. Fourth, to group data points in separate clusters. Fifth, to propose an efficient band classifier. Then sixth, to test a method for text classification. Seventh, to present hidden structures in visual form. So, in order to fulfill these tasks, we form our dataset. This dataset consists of our scientific works, articles, and abstracts on 3 different topics: emotions, gestures, and natural language processing. We made this data available to read and parse. We presented different topics, and also we make use of different authors. So now let's proceed to feature representation. We use well-proven in our previous works frequency features. We created a vocabulary of tokens and affixes, and also vocabulary of stop words in order to parse our text and remove all not necessary information. After we have got features for text, we make use of 2 types of methods in order to process these features and apply methods for classification and clustering. We use agent vector decomposition and the stochastic grouping of features. These methods gave us a possibility to visualize our data in 2-dimensional form and to create very fast methods for classification of our text data in such 2-dimensional representation. So first, our study before we tried to classify our text was studying informational density. We made different plots of our data points in 2-dimensional form and tried to find areas of greatest informational density in our data sets. And so we used 2 methods: random sample consensus and linear regression. Here in this slide, you can see how our data points are represented on the diagram and where are the areas of maximal density, which we call also concepts of the text. Now we'll proceed to sentence classification. We make use of Bayesian classifier. Our dataset consisted of 460 sentences, and in this study, we got an average classification rate around 89%. As you can see in this diagram, there are more detailed data about this test. The next test was testing of algorithm stability. We know that making some changes in our data, such as perturbation, can affect the algorithms, and thus we can see that different classification algorithms behave differently on data that has perturbation. In order to do this, we make use of variational autoencoder that converts our data points in other form where the bias and variance are changed and separation band decreases. Because of this, as you can see on the next slide, other algorithms behave differently. We studied support vectors machines, decision tree algorithms, random forest algorithms, neural networks, adaptive boosting, extreme gradient boosting, and naive-Bayes classifier. As you can see, different algorithms act differently, and some of them fail to converge. So the conclusions of this work are following. First, the use of dimensional reduction and data grouping are an efficient techniques, and we hope they can be used to assess the author style. Second, the classification of hidden concepts or cluster of data points gave us a promising result, around 89% on average classification rate. Third, perturbation of regional data shown us which algorithms are best suited for classification of hidden concepts of the data. And fourth, it's our further study. In our next works, we should study other samples of scientific texts on other topics and authorial styles, as well as other methods of classification and clustering.
Hello and welcome. My name is Dmitry Lubyanov, and I'm going to present you my work, which called A Reasonable Smart Home Technology on the Arduino for the 4th International Workshop on Computer Modeling and Intelligent System 2021. The purpose of presenting work is to program remote control gadgets with which the user has the ability to control all devices that supports infrared signal technology. The scientific novelty of the work result is the developed set of programmable gadgets can replace a significant number of different remotes and switches by using only one gadget, in the case a smartphone, as a control device, which is an alternative to a smart home. The practical value of the work result is that the developed set of programmable gadgets will ease the trivial life of the handicapped and the elderly. As the base of the developed system was chosen an Arduino board, which has enough option to deploy it. This FPGA has rich logic and can be programmed to execute different operations. Also, we need some additional components such as an infrared receiver, LED, and Bluetooth model. The first component is needed to get a list of the signals from a further remote to add all of them into an improvised database. The second one is used to send a received signal from the Arduino board to a control device. And the last component is needed to receive a Bluetooth signal from a smartphone. The example of compound of the models is shown on this slide. Basically, we need to connect both a Bluetooth model and
an infrared receiver to the Arduino board. In the table, you can see the result of the received signals from two remotes in the hex code format. The main algorithm includes next steps. Users select a button on his smartphone. The chosen button converts into a command which sends through Bluetooth. The Arduino board receives the command and converts it into a signal, which sends to a control device. The device recognizes this signal, executes it, and shows the result. In this slide, you can see the appearance of the main menu of the Android app to control devices. Also, you can see the structure of the developed smart home technology, which was deployed for complex testing on devices such as TVs, media players, and so on. And to show the result of working, I connected a laptop to display all the signal that the Arduino board receives. To summarize, the result of research work is a universal complex for controlling devices with an infrared sensor, which opens up a wide range of opportunities for its users. Devices are controlled by a smartphone, even if it doesn't have an infrared port. This allows the users to set up the technology of a smart home. Besides, the developed set of programmable gadgets will help the handicapped and the elderly, who find it very difficult to operate multiple remotes or master a new one. As a result, the reasonable smart home technology for controlling household appliances has been deployed, programmed, and tested. Thank you for your attention.
Hello everyone, my name is Anastasia Sergeyenko, and today I will present you work which is called Handwriting Digit, a digits recognition using SVM-KNN, RF, and deep learning neural network. Handwriting recognition is the ability of a computer or device to accept handwriting text as input from various sources. There are several examples of technical application for optical recognition digits or numbers from photographs, for example, recognition of car numbers, car number plates, product labeling, and recording device readings. In this work, its comparative analysis of several classification algorithms was carried out using the example of number recognition in photographic images or with manual input. And the influence of methods for preparing images and highlighting the area of interest in the photographic image on the recognition accuracy of handwriting numbers was analyzed. The main tasks of this work are presented on slide 2. The list of used image classification methods is presented on slide 3. The comparison of the selected algorithms is based on the characteristics chart of each algorithm on common ground like dataset, the number of epochs, complexity of the algorithm, accuracy of each algorithm's specification of the device, Ubuntu 20.10, i5 9th gen processor, 2 GB memory, used to execute the program and runtime of the algorithm under ideal condition. To build and train the model, a well-known and very complete base of handwriting and digits MNIST was selected. Some images from the MNIST set are present on slide 5. When testing various recognition models, some features on the MNIST dataset were established. All images of numbers have a correctly defined border area. Images are grayscale. The brightness of pixels varies across the width of the digit image. The images of the number are centered in relation to the 28 to 28 area. Many works have noted the importance of the image preprocessing for recognition handwriting numbers or letters. Translation, rotation, and elastic deformation have been studied for a variety of tasks in the area of machine learning goals. Many of today's OCR systems are built according to the traditional approaches to image preprocessing, and these systems work well with printed text. But using them for handwriting text recognition, images can have unexpected results.
for pure quality of recognition. There are known ways to improve the quality of handwriting digit recognition as a result of expanding the MNIST dataset through the use of FN transformation and prior knowledge of the invariant properties of the transformation. The algorithm was pre-processing photographs containing numbers used in this work is presented on slide 6. The important stages are image binarization and selection of the area of interest. Both of these operations are performed using the OpenCV library. A comparative study of the image classification methods carried out in this work showed that with correct settings of the methods shown on slide 3, the accuracy of the MNIST test sample estimation was 98.5%, which is only slightly inferior to the best result achieved using preconfigurated and or convolutional neural network. The result of the SVC classifier as part of the scikit-learn package are shown on slide 7 and 8. You can see from this slide that the highest accuracy of image recognition from the MNIST sample using the SVC classifier is achieved for the RBF kernel and the regularization parameter of at least 50. Similar studies carried out for the other classification options, KNN classifier, random forest classifier, multiple perceptron classifier. The analysis result of the influence of the KNN and random forest classifiers during parameters are shown on slide 9. As can be seen on this slide, the decrease in the number of nearest neighbors for the KNN classifier or an increase in the number of trees in the forest for RF classifier leads to an increase in recognition accuracy. However, both of the considered classification algorithms don't have any reserve for improving the recognition accuracy by raising the settings. The settings of the multiple perceptron had a great influence of the recognition accuracy. The results of the computational experiments are shown in slide 10. As can be seen from the graphs presented, the recognition accuracy was digit samples from the test sample increase with the increase in the number of neurons in the hiding layers. It was assumed to be the same for all layers, and with an increase in the number of hiding layers. The implementation of handwriting digits recognition by convolutional neural network was done using TensorFlow and Keras. Variants of structures of the deep learning neural network based on Keras framework, which were used to recognize handwriting digits or car number elements, are shown on slide 11. In the previous work of the authors, in the sample of 50 little car numbers, which included a total of 42 digits, 23 digits, and 3 two-digit images, 41 digits were correctly recognized using a convolutional neural network, so that the recognition accuracy was 97.6%. Recognition errors are connected with purely written numbers. However, when trying to use the classification method discussed above, including those based on CNN, for a wide range of images, for example, samples of handwriting numbers, the number of errors increased sharply, up to 40-50%, depending on the data set. To improve the recognition accuracy, it is necessary to perform 2 additional stages of image preprocessing. After highlighting the area
of interest contour exactly along to the boundaries of the digit, this part of the image is centered in the square area. The border of the image is added with a width of 50 to 25% of the square area size. The width of the border area significantly affects the reliability of digit recognition, both printed and handwriting. Study results of influence of the border area added with the width in the recognition accuracy set of handwriting characters 0 to 9 are shown on slide 20. A computational experiment for construction the curve with performing using scikit-learn implementation of the SVC algorithm. And then an analysis of the influence of the border area added was carried out for variants of digit recognition using neural network. The shape of the curve in slide 20 for variants with multi-level perceptron or CNN neural network remaining exactly the same as for the classification algorithms. An example of recognition as set of handwriting digits 0 to 9 is shown on slide 30. To access the reason of the recognition failure, a test program in Python was developed that allows to visually draw the numbers and monitor the stage of the recognition area and the results. It is clearly seen that centering the region of interest and forming the border region of optimal width allows accurate recognition of handwriting numbers. After building recognition models using all the algorithms mentioned above, the recognition accuracy of handwriting digits on the test program turned out to be in the range of 98 to 100%, one or no errors per 50 draw digits. Another result for improving the recognition accuracy is setting up the base for building models to work with black and white images. For these images from the MNIST dataset were converted to the black and white. The results obtained largely related to the peculiarities of highlighted areas of interest containing digits in the image. The selection of the contours, the find contours function on OpenCV is carried out exactly along the border of the founded contours. The selected area in the shape of a rectangle circumscribed around the contour of the digit without area of interest. Additional processing and unnoticeable differs from the base for recognition, MNIST. A similar result has been achieved in industrial images. Regardless of the used neural networks version, the recognition accuracy was 96 to 98%. For elements of the little car number binarization and morphological closing operation, more close in terms of the OpenCV library, were performed before recognition. The conclusion of this work are presented on slide 15. Thank you very much for your attention.
Good day. We present an article on the topic algorithm of analysis and conversion of input data of a two-factor
multivariative transport problem with weight coefficients. The authors of the article are Alexey Chizhmotrya, Olena Chizhmotrya, and Tetiana Vakaluk. One of the types of transport problem is a two-factor problem in which it is necessary to minimize costs simultaneously for two factors. There is a common method of pairwise multiplication of the corresponding values of factors with subsequent selection of the smallest of the obtained values. In the case of several variants of pairwise values of two factors for the pair supplier-consumer, the mentioned method of pairwise multiplication of the corresponding values of factors with the subsequent selection of the smallest of the obtained values remains valid. The selected value will be used in the future as the best option for the existing pair supplies consumer. Suppose we have two factors and three transport options from supplier to consumer with different values for each factor. For the minimization problem, it will be enough to choose the minimum value from three pairwise products of the values of factors formula number 1. The value of R will be the resulting criterion and the corresponding transportation option, the best of the proposed. In real conditions, different suppliers and different consumers may have different priorities than transporting goods. Someone needs to receive the goods as quickly as possible. Someone needs to minimize the cost of transportation. Someone is looking for a balanced solution, etc. Thus, there is a need to vary the weight of factors for each pair supplier-consumer within one transport task. Assuming the presence of weight coefficients for each of the factors, there is a problem of choosing an objectively better option from the proposed for each pair of supplier-consumer. Note that for each variant of 13 pair supplier-consumer, weight coefficients are constant values. Taking into account the weight coefficients, Formula 1 takes another form, formula number 2, or after mathematical transformations, formula number 3. From formula 3, it can be seen that the resulting best option is still chosen as a minimum of three pairwise products of the values of factors. The weight coefficients only equally increase each of the products and in no way affect the choice of the best option. This method eliminates the very essence of weight coefficients as levers of influence when choosing the best option. Simple pairwise multiplication of the values of the factors and their weight coefficients with the subsequent choice of the smallest of the obtained values does not allow to choose the objectively best of the proposed options. Consider and analyze the following method of choosing the best option taking into account the weight coefficients. The essence of the method will be to add the values of the two factors multiplied by the corresponding weight coefficients. The following example 1 should provide an answer to the feasibility or inadmissibility of this method. In example 1, we will deal with two options for transporting goods from point A to point B. The weight coefficients will change in the range from 0 to 1 in steps of 0.1 tenths. The sum of the coefficients will always be equal to 1. The best option for transportation and the value of the resulting criterion will be searched by the formula 4. The result of calculations are summarized in table 1. Let us analyze the data in table 1 according to which it is seen that with a decrease in the influence of factor C and the corresponding increase in the influence of factor T, the difference between the values of the resulting criteria R1 and R2 decreases. But even then the weight of the factor T requires a conditional 90%, still the smaller of the two values of the resulting criterion remains R2. And this, even though under the condition of the example, the value of T2 is 5 times greater than the value of T1. This result can be considered distorted and biased. It should be noted then is in this example we were dealing with two different numerical ranges, one of which was hundreds of times larger than the other. From the very beginning of the calculations, this range of values dominated and accordingly the corresponding factor dominated. Thus, the reason for the biased results was a large difference in the values of the numerical ranges of the two factors. In this study, we consider an algorithm that will get rid of the distortion of the result due to the difference in the values of the two numerical ranges. The essence of the algorithm will first be represented schematically. At the first stage of the algorithm, it is necessary to determine the largest value for each factor. In the second stage of the algorithm, it is necessary to calculate the least common multiple for the values. In this formula, GCD is the greatest common divisor. In the third stage, additional factors are determined for each of the factors. In the last fourth stage, each value of each of the factors must be multiplied by the corresponding additional factor. At the end of the algorithm, you can proceed to search by formula 4 the value of the resulting criterion and choose the best option. Let's return to the above example 1. According to the algorithm for bringing data to a single numerical range, step by step, we get the results. The value of the resulting criteria and the best option for transportation will be sought by formula 4. The weight coefficients will be changed in the range from 0 to 1 in steps of 0.1/10. The result of the calculations are summarized in table 2. The results shown in table 2 are radically different from the results in table 1. From table 2, we see that after reducing the initial data to a single numerical range, even the minimum effect of factor T was sufficient to the resultant criterion was the criterion R1. It will be recalled that before that it was a question of transportation of cargo from supplier A to consumer B. However, the transport task assumes the presence of several departure points and several consumers. For each pair supplier-consumer within the research topic, the variability of the values of each of the two factors is allowed. Also, each pair supplier-consumer for the problem may have different values of wage for these factors. Thus, there is a task of developing an algorithm for bringing a two-factor multivariate transport problem with weight coefficients to a unified form suitable for the application of one of the existing methods for solving problems of the corresponding type. Separate questions are the possible influence of factor values of one supply-consumer pair on the resulting criteria of other pairs and the probable different numerical ranges of factor values for different supply-consumer pairs. For further analysis and development of the algorithm as example 2, consider a fragment of a two-factor multivariate transport problem given in the tabular form. To begin this, we determine the best transportation option and the value of the resulting criterion separately for each pair A1, B3 and A3, B2. To do this, we use Formula 4 and the algorithm for bringing data to a single numerical range. For the A1, B3 pair, we have two options for cargo transportation. According to the algorithm, step by step, we get the results. Weight coefficients will be changed in the range from 0 to 1 in steps of 0.1. The results of calculation according to Formula 4 are summarized in Table 4. For the pair A3-B2, we have four options for cargo transportation. The results of calculation according to Formula 4 are summarized in Table 5. For both pairs A1-B3 and A3-B2, the algorithm for calculating the value of the resulting criterion and finding the best option yielded results. They can be considered objective, but only separately for each couple. If we analyze and compare the calculations for both pairs, we see that the values of the factors in these pairs were in different numerical ranges. To solve this problem in this study, it is proposed to combine the values of each of the factors of all options from both pairs, supplier, consumer of the current problem. The results of calculation according to Formula 4 for the pair A1-B3 are summarized in Table 6. The results of calculations according to Formula 4 for the pair A3-B2 are summarized in Table 7. Let's analyze the results. For pair A1-B3, we compare the data of Tables 4 and 6. In Table 4, at weight coefficients of 0.5 and 0.5, both variants of transportation of freight have identical result. After combining the values of each of the factors of all options from both pairs, supplier consumer, of the current problem, at the same weight coefficients, the resultant criterion was chosen R2. Given the invariance of the initial data in the pair A1-B3, it is possible to draw an unambiguous conclusion about the direct impact on the result in the pair A1-B3 values of the second pair A3-B2. For the pair A3-B2, we compare the data from Tables 5 and 7. Here we see even greater differences in results. For 6 of the 11 pairs of weight coefficients, the best option for transporting cargo from the 4 existing ones has changed. Here too, with constant initial data, the significant influence of the values of the pair A1-B3 is obvious. Conclusions. For a two-factor multivariate transport problem with weight coefficients, the method of pairwise multiplication of factor values and their weight coefficients with subsequent selection of the smallest of the obtained values does not allow to choose the objectively best of the proposed options. The difference in the values of the numerical ranges of the two factors leads to biased results. Therefore, it is mandatory to bring the values of the numerical ranges of the two factors to a single. The proposed algorithm for bringing the initial data to a single numerical range has fully performed its function. The obtained resulting criteria are ready for use in the further solution of the transport problem by one of the existing methods. The algorithm allowed us to draw an important conclusion about the influence of the values of the factors of a single pair supplier-consumer on the resulting criteria of the pairs. Thank you for your attention.
I welcome all participants of the workshop. Your attention is a report on the topic Methodology for Performance Analysis of Distributed Knowledge-Based System. Authors are Natalia Kulikovskaya, Artur Timenko, Svetlana Hrushko, and Stepan Skrupski. All authors are from Zaporizhzhia Polytechnic National University. Performance analysis is understood as the study of values of various performance metrics. The following goals of performance analysis are listed: determination of system performance under certain conditions, study the system performance when varying parameters, comparison of performance of different systems, performance debug, identify the reason why the system's performance does not meet expectation. To analyze the performance of distributed knowledge-based system, direct performance measurements with tracing of web services functions call is most often used. The main advantages of this approach is the preservation of complete information about the interaction of process in the trace, which makes it possible to analyze the performance of web services in detail. Improving the performance of a distributed knowledge-based system by directly measuring its performance, including solving the following problems. First, choose a metric for evaluation the performance of the web services. Collect performance data. Visualization of performance data. Identify performance problems, finding ways to fix performance problems, and troubleshoot performance problems. As noted above, the metric of measuring performance can be considered such device indication as total execution time, parallel efficiency, scalability, and others. Collecting performance data consists of tracing the call of the web services function. Depending on this selective presentation, one or several launches of the web services with representative data and certain parameters are performed on a particular computer system or different systems. The visualization of the collected performance data is usually done when identifying performance problems and finding ways to fix them will be done manually. There are various tools for visualization performance data, for example, space-time diagram, function, statistics, and others. Apache GMeter, Hewlett-Packard Load Runner, Microsoft Visual Studio, TestYoung, and are used for performance testing. Apache GMeter is a load testing tool developed by the Apache Software Foundation. The advantage of these tools include conduction tests with complex logic and correlation of dynamic parameters. Performance testing of web application includes IPs, web services, and data bus connectivity. The ability to reproduce the behavior of several users with parallel threads. Hewlett-Packard Load Runner has a distributed architecture. Provide a set of tools for working with various protocols. Provide details logging of the action of each virtual user.
Microsoft Visual Studio provides the following advantages: storage of test results in MS SQL Server database, and they are convenient structure. No restriction on the number of virtual users with alliance. This young support for different protocols and database, convenient in testing a peer quiz, low distribution of their cluster from client machine. The table provides an analysis of tools in the area of performance assessment. On slide 5, you can see the formal model of distributed system. A web services in distributed knowledge-based system shown in figure 1 is considered as a set of interaction processes. This is a formula 1. The interaction of processes is carried out using action in linear process in the certain sequences. This is formula 2. Each action of the proposed considered is called the function of the web services. Each function is characterized by input and output arguments. This is formula 4. Thus, each process action is characterized by a web services function, the value of its arguments, and called indeterminate. This is a formula 5. The work proposed an expert methodology for solving this task, including the following stage: systematization of topical productivity problems and establishment of the reason for their occurrence. Development of recommendation of eliminate these cases. A description of the identified performance problems, rules for determination in case of their occurrence, and a recommendation of the eliminate in the knowledge base. The work used the following model of the problem of web services performance, where PB, verbal description of the problem, duration of the appearance of this problem, their rules for tracing the action of the problem, and rules for recognizing the problem, recommendation of its elimination, and function and describe of the action that led to the problem. The analysis flow chart is illustration in figure 2. The initial data of the analysis in the services message trace formed as a result of the trace and contains simple event. And the analysis result is a set of identified performance problems. The analysis is carried out in 2 stages: constructing event as conditions for specific type of performance problem, identify performance problem for multiply constructing composable events. For a practical solution to the problem of increasing productivity, special systems are being developed that overlay the performance of web services and identify the most heavy parts of the code, performance problem. Based on this data, the expert can make a discussion to optimize the program code in order to reduce losses in this area. A common disadvantage of this system is that the task of identifying performance problem remains quite difficult due to large volume of information being processed and the complexity of the links that generate individual problems. In addition to the performance problem identified by the expert, the practical value of this methodology is the development of a system capable of accumulation expert knowledge on identified typical performance problems of distributed knowledge-based system and ways to eliminate them. All stages of performance analysis are implemented in software environment, working with ontology and the knowledge base of distributed knowledge-based system. Description of typical performance problem were included in the knowledge base of the system and shown in table 2. The general scheme of system operation is shown in figure 3. Working with the system consists of 2 stages: preparatory, training stage, and application stage. The preparatory stage is performed by an expert after he identifies the next performance problems. In this stage, the expert describes the action of the process, then can lead the emergence of the identified problem. Action are described in the form of description of the function of web services, the use of which is associated with the executing of the actions and the rules for tracing these functions. The expert describes the rule for tracing actions and the rules for recommendation that identify the problem. The rules described by the expert are added to the knowledge base of the system. The application phase is performed by user. At this stage, the system traces launches along with the application. During the execution of the application, the tracer, guided by the tracking rules, generates a trace in which all the necessary actions of the application process are recorded in the form of sequence of events. After executing the application, the trace analyze, guided by the rules for recognizing known problems, determine the presence of problems, generate a list of them, and a recommendation for their elimination. This article discusses exciting methods for analyzing the performance of distributed systems and method for measuring performance. The scientific novelty of the work lies in the presentation of the model of the performance problems of the web services, a set of a process action, certain combination of which, under certain condition, can lead to an identifiable performance problem. An overview of exciting tools for testing the performance of web services is given. It's known that most modern tools are based on visualization performance data, and the rest of the tasks are solved manually by users. Currently, systems are being developed that allow solving problem of identified performance problems and finding ways to eliminate them in an automatic mode. It's necessary to set a fixed set of problems that they can analyze, as well as add new problems without reprogramming the source code. The practical value of this methodology is the development of a system capable of accumulation expert knowledge on identified typical performance problem of distributed knowledge-based systems and ways to eliminate them. All stages of performance analysis methodology are implemented in the software environment for working with ontology and knowledge-based distributed systems. Descriptions on typical performance problems were included in the knowledge base of the system. In this stage testing of the software environment developed on the basis of the proposed methods is carried out. Thank you for your attention.
Hello, the theme of this project is the neural network for emotions recognition under special conditions. The purpose of this work is to develop an algorithm that determines the emotional state of a person without a large expenditure of resources based on his facial expressions presented presented in the input image. Emotion is a mental process that reflects the subjective evaluative attitude of a person to various situations and objects. Each person expresses emotions in slightly different ways. The famous American psychologist Paul Ekman established that a number of emotions, namely anger, fear, sadness, disgust, contempt, surprise, and joy, are universal and can be understood by a person regardless of his culture. Emotion recognition is a hot topic in artificial intelligence. The most interesting areas of
application of such technologies include driver recognition, marketing, research, video analytics system for smart cities, human-machine interaction, monitoring of students taking online courses, wearable devices. To achieve this, tech companies like Microsoft, IBM, and Amazon all sell what they call emotion recognition algorithm, which infer how people feel based on facial analysis. Facebook has developed its own system for recognizing a human face and emotions. It's called DeepFace and uses artificial intelligence technology and has also trained on millions of images taken from the internet. An almost similar system, FaceNet, was also developed by Google. The simplest way to determine emotion from a face image is based on the classification of key points of facial landmarks, the coordinates of which can be obtained using various algorithms, PDM, CML, AAM, DPM, or CNN. Usually from 5 to 6 to 8 points are marked, tying them to the position of the eyebrows, eyes, lips, nose, jaw, which allows you to facially capture facial expressions. Normalized coordinates of points can be directly fed into a classifier, for example, SVM or random forest, and get a basic solution. Naturally, the position of the faces should be aligned. The simple use of coordinates without a visual component leads to significant loss of useful information. Therefore, to improve the system, various descriptors are calculated at these points: LVP, hog, sieve, large. After concatenating, the descriptors are reducing the dimension using PCA. The resultant feature vector can be used for classification emotions. However, this approach is already considered obsolete, as deep convolutional networks are known to be the best choice for analyzing visual data. Since the method of key points has a number of disadvantages, a replacement was proposed using convolutional neural network. I will not explain what a convolutional neural network is. This is a well-known machine learning algorithm, so I will only say about the main advantages. First, the number of parameters for training doesn't depend on the size for the image. Works with an image matrix and is able to take into account for spatial structure of the data. Each neuron works only with a part of the previous pixel or neurons. This principle of local perception reduces the amount of information perceived by each neuron. Due to the laws of pooling, the principle of dimensionality reduction is applied. Thus, with each next layer, the neural network receives more and more high-level image features. The data consists of 48 on 48 pixel grayscale images of faces. The faces have been automatically registered so that the face is more or less centered and occupies about the same amount of space in each image. The task is to categorize each face based on the emotion shown in its facial expressions into one of 7 categories: angry, disgust, fear, happy, sad, surprised, neutral. Train C3 contains 2 columns, emotion and pixels. The emotion column contains a numeric code ranging from 0 to 6 inclusive for the emotion that is present in the image. The pixels column contains a string surrounded in quotes for each image. The contents of the string, a space-separated pixel values in row major order. Test C3 contains only the pixels column, and your task is to predict the emotion column. The training set consists of
30,000 examples. The public test set used for the leaderboard consists of 3,000 examples. The final test set, which was used to determine the winner of competition, consists another 3,000 examples. Data has been normalized and converted to float 32. In total, the neural network will have 3 convolutional layers, 3 max pooling layers, a flattened layer, and 2 fully connected layers. The first layer will be convolutional. On the first convolutional layer, the number of different convolutional kernels to be applied will be 32. At the same time, this is number of feature maps that we get on the next layer after convolution. Next comes the size of the convolutional kernel. This architecture uses 3 on 3. The size of the input data is determined from the image size, that is 48 on 48 on 1, used only in the first convolutional layer. Next comes padding. Padding can have 2 values, valid and the same. The default is valid, which minimizes the image. Next comes the layer that normalizes the input data. Batch normalization. ReLU is used as the activation function, and activation function is a function that accepts the result of an adder as an input and performs some kind of transformation to turn the sum of the weighted inputs into adequate output that can be interpreted in terms of solving the problem. It's a good approximator. Any function can be approximated by a combination of ReLU. The next is a pooling layer. The max pooling layer is 2 on 2. Other values are possible. Most often this value is used. Typically, a convolutional layer followed by a pooling layer is called a convolutional block. After 3 convolutional blocks come to the flattened layer, it doesn't have any parameters but simply converts multidimensional data into a flat vector, which can already be given as input to a fully connected layer. Convolutional blocks will not give us probability of sending an image to any class. The fully connected layer is responsible for this. In total, this architecture has 2 fully connected layers. In the first fully connected layer, 132 inputs to the neuron. In the second, these are 7 inputs to the neuron according to the number of classes that need to be predicted. On the last layer, there is a softmax function. Since there are 7 inputs to the neuron on the last layer, this is a number of classes. After creating the model, it needs to be configured with losses and metrics. The categorical cross entropy was chosen as the last function. Adding with learning rate is used as an optimizer. This is a good default algorithm. Good convergence accuracy is used. A quality metric accuracy is one metric for evaluating classification models. A training dataset was used to train the neural network, and validation dataset was used for validation, batch size 64, epoch 20. The model works ineffectively if it is given as input and training from images at once. Therefore, the data was divided into 64. In order for the network to learn many iterations of 64 must go through. The larger the batch size sample size, the more memory is required from the computer. Below are the training schedules. They show that 20 epochs, even 11 epochs can be taken is quite enough. A little more and there would be overfitting. Figure 1 shows the accuracy at each epoch of the training and validation data. Figure 2 shows the change in the growth of the loss function on the data.
Results. The training phase is followed by the testing phase. The following results were obtained that only one figure did the predictions turn out to be wrong. In the remaining figures, the neural network correctly predicted all emotions. Above is a label for each emotion. The model does not always make accurate predictions. It is especially difficult to recognize the disgust emotion, and there were few examples of this emotion in the dataset. Conclusion. In this work, a convolutional neural network is implemented that is capable of detecting emotion in low light conditions, with objects on the face, places, for example, and at an angle of inclination. This is what distinguishes this algorithm from the previous ones. For this, was found a dataset suitable for this task. All data from the datasets was normalized. A model was built and trained. Metrics with optimizers and loss functions was selected. The model is also tested on the test data, and the model parameters are selected on the validation data. Also, the model can be saved and integrated into any system, such as a video camera. This can be used for commercial purpose. Training this network proved to be optimal for the available machine resources, and at the same time, it trained 10 times faster than a central processor unit. The convolutional neural network model is also capable of identifying features and reducing unnecessary features. Also, a convolutional neural network is able to adapt to image resizing, scaling, rotations, unlike other algorithms. Thanks.
Hello, my name is Svetlana Ignatieva, and I am present object detection algorithm for high-resolution images based on convolutional neural network and multiscale, written by Richard Bogush from Polish State University, Sergei Oblomik from Belarusian State University, Svetlana Ignatieva from Polish State University, and Igor Adamovsky from Polish State University. Currently, video surveillance systems have a fairly wide range of applications and are used in such areas as the detection of pedestrians and vehicles, robots, autopilots, and other. Modern systems are increasingly using high-definition video from 4K and higher. The use of high-definition video allows for more accurate object details identification and increases the probability small object detections and more accurately identifies the boundaries of large objects. However, there is also a negative side. High-resolution video and images have a large information capacity and computationally intensive. Modern systems are increasingly using convolutional neural networks for image processing, which are pre-trained on large image datasets. For processing big-size images with a resolution of 2K or more, the computing power of a computer may not be enough, and the use of convolutional neural networks involves image scaling. This leads to a decrease in information content and often makes it impossible to detect small objects. To solve this problem, we propose an approach that uses a pyramidal representation of an image as a set of different scale copies. The pyramid levels number is determined by the formula presented on the screen, where W and H are the width and height of the original image. L by L is the size of the input layer. Square brackets indicate that the nearest wall number is taken. After scaling, each pyramid image is divided into overlapping blocks. Blocks number is determined by the formula at the bottom of the screen. P is the pyramid level numbers, K is the amount of block shift in pixels. Each image block is processed using convolutional neural network to detect regions of interest that may contain an object or an object fragment. Each region of interest
is described by such parameters as x1 and y1. This is upper left corner coordinates of the found regions in the image. x2 and y2 lower right corner coordinates of the found regions in the image. E is convolutional neural network confidence in the correct classification, and CL is the selected object class. To measure the detected regions of interest, an amount of overlap analysis at each pyramid level for each block is carried out, as well as belonging to the same class. After that, a descriptor to the merge area is generated. When using block processing, a situation may arise that the same object or its fragments will be detected with a coordinate shift in image at different scales or in neighboring cells. It's also possible that the features of a small size object fragment may differ from the original object features and even be closer to the descriptors of another class. Therefore, when merging, post-processing is additionally applied. For this, it's proposed to use the rule according to which all errors obtained in the previous step are analyzed and combined. The intersections of a union value must be greater than 0.2. The detected errors classes must coincide, and the value of the difference between the size of the regions of interest might be greater than the threshold level. This screen shows a proposed algorithm diagram. The input image is transferred to the block where the image pyramid is built in according with the initial parameters. Each pyramid image, after dividing into blocks, passes through the YOLO V4 convolutional neural networks. Objects are detected, their position on the image is determined. As a result of post-processing, we get the final detected object coordinates and the name of the object class. We calculate the intersections of a union metric for each object, and we calculate the mean average precision. To test the algorithm, we used a dataset consisting of 820 images with 4K resolution, which were obtained under different weather conditions, with different heights and angles of cameras. The label image tool was used to annotate the data. A total of 6,125 objects of two classes were annotated: person and vehicle. The vehicle class is composite because it combines the classes bus, car, and truck. The smallest of the market objects has a size of 24 by 14 pixels. The largest is 322 by 780. The algorithm accuracy was evaluated for various block overlap and CNN threshold value with a step of 5%. It should be noted that for the minimum regional image scale, the threshold value of T is equal to 50%, which corresponds to the most effective for the used CNN. The experimental results are presented in Table 1. The analysis shows that for any alpha and T values, the considered algorithm mean average precision is higher than the mean average precision of the CNN used. The best result is provided with alpha is equal to 50% and T is equal to 75%, and mean average precision is equal to 68.3%. The figures show a 4K image fragment where it's clear seen that the proposed algorithm allows more accuracy detections of the objects than YOLO V4. With the help of YOLO V4, two objects were detected. The proposed algorithm made it possible to detect 4 objects. The proposed algorithm was tested on 4K and 8K images. In left figures show the object detections result by the proposed algorithm with parameters which were determined as a result of experiments. Image 4K with resolution 3840 by 2160. Input layer size 1024 by 1024. Number of pyramid levels P is equal to 3, alpha is equal to 50%, and T is equal to 75%. In this case, 90 objects were detected. The minimum size is 33 by 11 pixels. In right figures shows a reduced copy for 8K image with resolution 7360 by 4912. The 8K image has a huge size, so object detection's result is presented only for bottom right part of the image. Our algorithm detected 114 objects and their minimum size is 26 by 31 pixels on this image. Figure shows the object detection's result by the proposed algorithm with parameters which were determined as a result of experiments. Input layer size 1024 by 1024, number of pyramid levels P is equal to 4, alpha is equal to 50% and T is equal to 75%. We can see that the presented algorithm even detected the drivers on vehicles who stopped in front of the pedestrian crossing. Thank you for your attention.
Ladies and gentlemen, good day. My name is Evgeny Klimov. I am a co-author of the work and I am going to present today. The title of the research is Using of Intelligence Analysis of Technological Parameters Database for Implementation of Control Subsystem of Hot Blast Stoves Block ACS. The authors are Alexey Koifman, Alexander Simkin, Sergei Sherbakov, and me. We all are from Berezovsky State Technical University, Mariupol, Ukraine. To intensify blast furnace melting, hot blasting is supplied to the furnace, which is heated in the block of hot blast stoves to a temperature of 1200 to 1300 degrees Celsius. The required value of the blast temperature is determined by the blast furnace technology. Hot blast stove, hereinafter referred to as HBS, is a regenerative unit of periodic action up to 40 meters high. During the on-gas mode, the heat from the combustion of the fuel gas is transferred to the refractory checkerwork. During the on-blast mode, the heat from the checkerwork is transferred to the blast. A standard block of hot blast stoves, hereinafter referred to as HBSB, consists of 3 to 4 units. The main task of the HBSB control system is to maintain the hot blast temperature at a given value. The operating modes are determined by the parameter chart, in which the time characteristics of the on-gas and on-blast modes of the transfer of the hot blast stove from mode to mode are determined. In this case, the deviation of one of the parameters of the parameter chart from the established ones leads to the change in the operating modes of all hot blast stoves and fluctuations in the value of the blast temperature. Most of the HBSB are equipped with automatic control systems, in which the values of technological parameters are recorded in a database which allows to study the state of hot blast stove over a long period of operation, including the state of the checkerwork when changing its operating modes. At the same time, the actual problem is the stabilization of the hot blast temperature at the set value, taking into account the aging of the HBS. A review of scientific publications over the past few decades related to the automation of blast furnace production units shows that one of the main trends in the development of control systems is the use of the intelligence analysis in order to intensify new dependencies between technological parameters. The goal of the work is the application of the intelligence analysis of technological information from a database about the state of the hot blast stove during the periods of its switching from mode to mode, for timely adjustment of the set values of technological parameters in controlling of the hot blast heating. The objectives of the research: development of an algorithm and program for extracting from the archive database the values of the parameters of technological process of heating the hot blast to analyze the states of the hot blast stove when it switches from the mode to mode. Development of the structure of an automatic control system for blast furnace blast heating using a data mining subsystem has been proposed. In the automation system of the studied block of hot blast stoves, the values of technological parameters are recorded in two types of database files in .dbf format. In the file of the first type, figure 1, 175 values of technological parameters of 4 hot blast stoves of the block are recorded every 10 seconds for the whole day. One file contains over 1.5 million records. The data is stored in a rather inconvenient way, in a column.
The file of the second type, the so-called wide-based figure 2, already has several dozen of columns of data, which greatly simplifies the work, but the data recording period is now 20 seconds. In the base of the first type, there are certain variables corresponding to the on-gas mode and the on-blast mode, therefore it is easy to determine in which of three modes the HBS is located. However, in the wide database, there is only one variable characterizing the on-blast mode, which complicates the determination of the on-gas mode and the on-switch mode. In doing so, nothing is written to this variable for one of the hot blast stoves of the block. The complexity of information processing is that in databases of various types, due to the imperfection of instrumentation installed on hot blast stoves, not all parameters values are presented for the same period of time, and part of the parameters are recorded with a period that does not coincide with the record period in another database. To process such huge and complex amount of information, it is necessary to create a specialized software tool for opening a database of two types, extracting the necessary data from them, exploring parameter values from one database to synchronize time intervals with the records of another database. The result should be an array of data for data mining of the parameters and operating modes of the hot blast stove. For each HBS of the block, a separate Microsoft Excel file should be generated containing three tabs with the corresponding information about the on-gas mode, the on-blast mode, and the on-switch mode of the HBS from mode to mode. In the base of the first type, there are corresponding variables vn and vnd to determine the on-gas mode and the on-blast mode, so there was no difficulty in dividing the database into three operating modes of hot blast stoves. Preliminary statistical processing of the database showed that the values of technological parameters were correctly recorded in the database. Figure 3 shows a block diagram of the analysis of the base of the first type. However, in the database of the second type, there is one variable describing the on-gas mode, vn\d, while the open hot blast valve corresponds to the value vn\d equals 1, and the closed valve corresponds to vn\d equals 0. Based on the valve switching cyclogram, if the parameter values are correctly recorded in the database, the periods can be determined as follows. When compiling the algorithm for dividing the database into modes, preliminary analysis revealed incorrect records of parameter values, which are summarized in Table 1. It was decided to implement the program in the modern programming environment IDE Microsoft Visual Studio 2019 in the object-oriented programming language C#, which is quite simple but with a lot of convenient features and extensions for various tasks. The program connects to the directory in which the database files are stored, extracts the necessary information from it and submits it in an easy-to-read form to a new structured database or to an Microsoft Excel file for further intellectual processing. According to the algorithms included in the program, slides 3 and 4, the information from the database is divided into files of XLSX format, each of which contains information on the operating modes of the hot blast stoves block. The on-gas mode, the on-blast mode, or the on-switch mode. The values of the dome and gas temperature in the checkerwork, as well as the hot blast temperature, were chosen as the studied parameters characterizing the thermal state of the hot blast stove checkerwork. In the course of analyzing the database for a long period of operation of the hot blast stove using the developed software, in addition to typical switchings, figure 7AB, 8AB, which correspond to the correct sequence of actions of the gas operator when switching operating modes. Atypical switching were also found, figure 7CD, 8CD. The graph of the dome temperature change for each switching, figure 7.8, consists of three parts. In addition to the switching period, 50 values of the previous and subsequent modes are added. Typical switchings from the on-gas mode to the on-blast mode, figure 7AB, have a similar character. While lasting about 8 to 10 minutes, the dome temperature decreases by 15 to 25 degrees Celsius.
Typical switching from the on-blast mode to the on-gas mode, figure 8a-b, have the same character for all whole blast stoves. Switching takes about 5 minutes, while the dome temperature drops by 15 to 20 degrees Celsius. During the on-switch mode, a drop in temperature can be observed within the range of 30 to 40 degrees Celsius and sometimes up to 50 degrees Celsius, which must be taken into account when automatically controlling the subsequent operating mode of the hot blast stove. Using the developed program, the database has been studied over a long period to obtain and further analyze the averaged graphs of the temperature variation of the dome of hot blast stove of two blocks of different blast furnaces during the on-switch modes, figure 9. The change in the dome temperature during the on-switch mode from the on-blast to the on-gas modes has the same character, and the duration of the on-switch mode corresponds to the parameter chart of operation of blocks adopted for the period under study, figure 9bd. The duration of the on-switch mode from the on-gas to on-blast modes for HBS4 and HBS3 of the blast furnace number 3 corresponds to the parameter chart, and for HBS it lasts twice as long as in the parameter chart. The duration of the on-switch mode from the on-gas mode to the on-blast mode for all hot blast stoves of the blast furnace number 2 is much longer, which is indicated in the parameter chart. The obtained results must be taken into account in drawing up a new corrected parameter chart to optimize the operation of the hot blast stove block. Of particular interest is a complex analysis of the on-switch modes of the block operating in parallel mode and their impact on the hot blast temperature, figure 10. Prior the on-switch mode, the block of hot blast stoves was in parallel operation mode. HBS1 and HBS4 operated in the on-gas mode, HBS2 and HBS3 in the on-blast mode. Let us consider the on-switch mode sequence. HBS1 was the first to switch to the on-gas mode. No blast temperature fluctuations were observed. Then HBS2 and HBS3 began to switch to the on-blast mode. There is a sharp jump in the blast temperature by about 15 degrees Celsius for 2 minutes. HBS4 was the last to switch to the on-gas mode. In this case, a sharp drop in the blast temperature by 25 degrees Celsius is observed. After the end of the on-switch mode, the temperature of the hot blast stabilizes. Stabilization of the blast temperature during the on-switch is one of the most important tasks of today, since fluctuations in the blast temperature negatively affect the course of blast furnace smelting. Therefore, information on the nature of fluctuations in the hot blast temperature should be transmitted to the automatic control system. The authors propose a new structure of the automatic control system for the hot blast stoves block based on the data mining subsystem, figure 11. Developed on the basis of information, dome and flue gas temperatures, hot blast temperatures, valve positions, obtained from the archive database, and the results of the performed research of the state of the hot blast stove during the on-switch mode. Current values of temperatures of the dome, T1, flue gases, T2, and hot blast, T3, flow rates, F, and mixed gas pressure, P1, combustion air pressure, P2, information on the position of valves from the valve control circuit are controlled in the local automatic control system, LACS, and are recorded in the current and archive database. The data mining subsystem, based on the current technological information, monitors the change in the operating modes of the hot blast stoves, analyzes the state of the hot blast stoves during on-switch, compares with the archived information, and makes adjustments to the operating modes of the hot blast stoves block. If an increase in the duration of the hot blast stove switching to the on-gas mode is detected, a decrease in the dome temperature and an increase in heat losses to the environment, which leads to an increase in the duration of the on-gas mode, the data mining subsystem will send corrections to the set mixed gas flow rate to the LACS system, which will ensure the achievement of the set heating duration of the checker work. Data mining of the database containing current and archived information on the technological process of blast furnace heating must be used in automatic control systems. The usage of the obtained results of the analysis of the on-switch mode of the hot blast stove will allow to make timely adjustments to the parameter chart of the hot blast stoves block to clarify the initial values of modeling the operation of the hot blast stove. The authors have developed an algorithm and software for data mining of technological information, which allows to access the state of the hot blast stove during the periods of the on-switch mode. The analysis of the change in the dome temperature and the smoke temperature during the on-switch mode of the hot blast stove and the effect of switching on the blast temperature has been performed. The application of the proposed method of data mining of the current technological information about the heating of the hot blast is a new approach in the design of automatic control systems for the hot blast stoves block, which allows to maintain the set temperature of the hot blast without impressive capital costs for the reconstruction of the hot blast stoves block.
Dear colleagues, I would like to present you our investigation in the field of data cube national scale development based on modern OLAP technology. My name is Lukashevich Pavel. I am from United Institute of Informatic Problems of the Academy of Sciences of Belarus. As you know, Earth observation is a very promising task for data processing. There are a lot of Earth observation data and open access data also. For example, American Landsat and European Sentinel satellites provide us for free a lot of such data. Nowadays, there are a lot of other services with more complex and more challenging task for Earth observation is presented. In addition to open data, in our country we have own satellite, BKA satellite. This satellite operated by Geoinformation Systems, which is the daughter of our company. BKA equipped with an panchromatic and multispectral imaging system with a resolution of 2 and 10 meters respectively. Also, Geoinformation Systems has access to Russian Canopus V satellites from the same Earth observation constellation. Now we have plans to launch a new generation satellite with much more better resolution. In addition to high resolution data, our Geoinformation System operator has developed and maintained Meteor-Eye service. This service allows us to obtain up-to-date meteorological data from the variety of meteor satellites. You can see on the slide which satellites are supported, and the main advantages from this approach is that our data is achieved close to real-time mode during the satellites fly over the receiving station in the Belarus. At present time, collected data are used for various expert systems developed in our institution, mainly for large government customers such as Ministry of Natural Resources, Forestry, Cadastral Services, Agro-Technical Enterprises, Ministry of Emergency Situation, and other big major stakeholders. However, for a single researcher, it is a challenging task to take and process this data because of difficulties in data acquisition, difficulties in format and representation, space resolution, and so on. Fortunately, this problem can be solved by the modern technology called OLAP, Analytical Data Analysis and Processing. OLAP technology, or data cube geodata analysis, based on new SQL multidimensional array standards, and it's capable to process data in place
on the cloud. For example, there are 5 big Copernicus data processing services called DIAS, Data and Information Access Services, you see on the picture. And the other big marketplace, for example, Google and Earth, also have the similar approach for geodata processing. For example, Google Earth Engine and Amazon Web Services. There are a lot of other regional DataCube services you see on the slide. Lab DataCubes provides not only the data storage, but also data processing, data analytic, data visualization, and so on. In addition, DataCube is the only way to process Earth observation big data. For example, Copernicus program generates about 12 terabytes of data every day, and it isn't possible to process the data locally. However, it is essential to distinguish such commercial data cubes from science and education data cubes, which is much more convenient for individual researchers. Here you can see the sample of such a DataCube platform on the basis of Google Earth Engine. In the right upper side, you see the Google Earth Engine API interface on the basis of JavaScript API. You can see the development environment and the results, which is shown on map. On the bottom side, you see the interface of Python API and the sample of images which is taken by the Python code from Google Earth Engine. You can use these services for free, and you can use also Google Colab abilities to process this data. Our colleagues from Armenia already built regional scale DataCube, and now this is the valuable application of Armenian national infrastructure. Armenian DataCube enriched with complete up-to-date archive of Earth observation data, and now it successfully works with different tasks such as ecological monitoring and so on. This resource provides full operation and provides access to official data, which can include the Creative Commons license and digital identifier. On this slide, you can see the fundamental structure of proposed system of regional DataCube by cube. On the left side, you can see the infrastructure of our GIS, Bioinformation Systems Operator. You can see the receiving dish. You can see the storage and the database and the satellites which are supported. On the middle side, you can see the Open DataCube based solution. We are hosting this solution on the BusNet resources. BusNet is our data organization, and the main benefit for us is that we can take these resources for free. In conclusion, I should say that now we are at the early beginning of development of such DataCube system in Belarus. But international experience and the experience of our Armenian colleagues shows that implementation of such DataCube technology will significantly increase the value of received Earth observation data due to minimization of time and special knowledge for data access and processing, due to accumulation of actual local satellite data in one place
providing easy access to this data, providing easy access to modern software solution and tools for Earth observation data analysis, providing access to community tools for code contribution and sharing. We are planning to scale our BiCube algorithmic base by active science and technology community users. We allow access to our system from the specialists, from other organization, from educational and research organization, and so on. We're waiting a lot from this system. Thank you for your attention.
Hello everyone, my name is Karina Melnik. I would like to consider today the topic about towards designing of recommendation system for recruiting of software development teams. My colleagues Natalia Borisova, Zoya Kachuyeva, Dina Gulieva, and me are going to share with you some of the ideas that we have discovered in this area. In our research, we proposed using recommendation system for automation of the process of recruiting software development team based on their members' technical skills and psychological compatibility. An analysis of domain area demonstrates that the potential of recommendation systems in the field of project management has not yet been fully disclosed. Today, the team building problems are mostly solved by HR managers manually. The subjective opinion of the HR manager about a particular employee can influence on the process of team formation. Therefore, there are many benefits of our approach. Firstly, it will speed up the decision-making process on this issue, because a computer takes much less time to process large amounts of information than a human. Secondly, automating this process will free up the PM's and HR's time for other tasks. Thirdly, there is no lack of subjectivity in the decision-making process by the recommendation system. Consequently, the relevance of this task is obvious. So, the object of the study is the team-building process. The subject of the study is a theoretical and methodological tool for solving the recruiting task of software development teams. And the purpose of this work is to resolve the recruiting task of software development teams according to suitable technical appraisal using the recommendation system. Let's consider the formulation of the recruiting task of software development teams. If C is a set of potential candidates with suitable technical skills for the software development teams from employees and non-employees, and T is a set of possible teams, then the task of team building based on psychotypes is a mapping of one set to another. To achieve the goal of the given research, it is necessary to conduct analytical review of methods for creating recommendation systems, choose a method for recommendation system for team building, develop a method for the recruiting task of software development teams, conduct numerical research, assess the proposed approach of team building. There are some traditional approaches to creating of recommendation systems: content-based filtering approach, collaborative filtering approach, and hybrid approach. Content-based filtering approach provides recommendation based on comparing information about the user and the object of recommendation. Collaborative filtering approach provides recommendation based on comparing information about the preferences of different users with various characteristics. It makes recommendation to new users with similar characteristics. Hybrid approach combines both of the previous approaches, trying to use their advantages and neutralize disadvantages. To solve the given problem, it is proposed to use the content-based filtering approach, because a profile of a candidate is compared with a profile of the ideal team member for this project or with a set of requirements for a vacant position. The methods of such approach have been divided into two main groups. The first group of methods calculates different similarity measures
between the considered objects. The second one is data mining methods. The choice of the method in this case depends on the domain area, the available statistical material, and the power of the computing system. Input data for given task is a psychological portrait of some potential candidate to appropriate job. According to Spencer's model, each characteristic from the psychological portrait is measured from 1 to 10, depending on the degree of manifestation of a particular characteristic. Therefore, the conducted analytical review of methods and features of the domain area allows choosing the Euclidean distance as a measure for the research. To implement an effective business process of team recruiting, it is necessary to create a model of this process. To formalize the process, it is proposed to use business process modeling notation. The team recruiting process begins with the formation of a set of requirements of the team. In order to create a list of requirements for potential candidates, it is necessary to hold a kick-off meeting. Project scope and project charter should be formed during this meeting. These documents are the basis not only for team requirements, but also for software requirement specification. The requirements to technical skills or the competence profiles of IT specialists for this project are drawn up according to the wishes of the product owner and the existing working conditions in the IT company. The next step is the recruiting process of potential members. The HR manager firstly checks the resumes of employees. If a proper candidate were not found in the company, the HR manager would search for potential candidates on the internet. The task of evaluation potential candidates for the software development teams is considered in other works. As a result of this stage, potential candidates are screened and set of candidates are formed for each position in the project team. The next step is to solve the problem of team recruiting for new project. Depending on the needs of the product owner, it could be recruited one or more teams with different team members. Let's consider the task of team recruiting in more detailed way. The project manager is the most important and responsible specialist for the project, who is the connecting link between the client and team members. Therefore, he or she is the basis for the selection of the rest of the team. The formation of the team is carried out according to the principle of choosing the candidates who are close to the project manager in terms of psychological characteristics. The next step is an appointment of specialists of the next management level. If there are proper IT professionals, then they are immediately assigned to selected roles. If several potential employees are equally suitable for one position, and the PM is ready to work with any of them, then the decision about the appointment is made after the possible teams have been selected and analyzed. If employees and non-employees fit for the position, then the choice is based on calculating the similarity measure between the project manager and possible candidates. In the face of uncertainty, 3 lists of candidates are formed. The first list corresponds to the group of people applying for the development leader role, where top names from the list belong to people with the highest priority. The second list for quality assurance leader, and the third one for architect. The next step evaluates the set of potential candidates for the particular role according to comparing the cardinality of the set with the number of required employees. This action leads to recruitment of specialists for the particular role according to the calculation of the similarity measure between the top-level manager, for example, quality assurance leader, and the corresponding candidates. The choice is carried out from a ranked list based on the smallest values of the similarity measure. If the team is not formed, then go to the assessment of the set of potential candidates. If the team is fully completed, then go to the previous step to form an alternative team. If all possible options are considered, then the recommendation system has to provide a list of possible teams for evaluation and analysis to project manager. The following architecture of the software component for recruiting task has been proposed. It is presented in the form of a deployment diagram. A three-tier architecture to deploy the software component has been chosen. The advantages of the chosen architecture are scalability, high level of security and reliability, low requirements for network speed between clients and the application server, and low requirements for performance and technical characteristics of clients. For storing, changing, and processing information about the subject area, the database was developed. The model of this base is represented using the IDF1X notation. This part contains information about employees and projects of the IT company. The entity candidates contains information about employees and non-employees who took a part in a job interview. The clients contains information about all clients of the IT company, including the country and the time zone. The competencies from job competency profiles are described in competencies, job profile, and employees' competencies. Let's consider the use of the develop recommendation system for recruiting of software development teams. One foreign company has ordered a software from an IT company. The names of candidates have been hidden. Management of the IT company has assigned particular project manager to this project. According to the proposed method of the team building, first step is done. Project manager and HR have chosen the structure of the team from 10 IT specialists. The input data is the information about employees and non-employees based on the Spencer's model with suitable technical appraisal. The snippet with calculation of the similarity measure between potential candidates are presented here. It is the base for forming the development teams. The best candidates for the team are highlighted in bold. The recommendation system allows forming a set of alternative teams. It is a framework for the project manager who forms the final structure of the team for the project. For checking the adequacy of working of recommendation system, it is possible to assess the quality of the recommendation system work based on a set of characteristics, which shows the degree of achieving the goal. To assess the quality of the forming process of the development teams, it is necessary to match the results of work of the HR and project manager before applying the recommendation system and after. Process quality is a set of process indicators that reflect the degree of achievement of certain goals. To assess the quality of team building process, the following criteria or features can be used. Each feature should be evaluated by a 7-point scale, where 1 is the minimal value for metrics and 7 is the maximum accordingly. To obtain the numerical values of the criteria, the experts have evaluated the complexity of solving the given task manually and using recommendation system according to the proposed scale. In this study, a weighted average quality metric PQ is proposed as a convolution criterion. If criterion makes a positive contribution to the quality assessment, then we should use this formula. For negative features, it is necessary to use this one. The results allow us to notice that the quality of the process of forming the project team, based on the use of recommendation system, has increased by 49%, which confirms the research hypothesis stated earlier. So, in this study, all the tasks were solved and the goal was achieved. Thank you for your attention.
Welcome to our presentation. Our study is about topology properties of hierarchical honeycomb meshes. In the introduction, I will show you the studies about hierarchical networks and also about honeycomb meshes. For the preliminaries, I will give the definition of honeycomb meshes, hierarchical honeycomb meshes, and hierarchical extended Fibonacci cubes. Then I will explain construction of HHM, topology properties of HHM, and routing of HHM. Lastly, in the conclusion, the results obtained in this study will be given. A hierarchical network is a type of network that consists clusters that are disjoint group of nodes. And every cluster has one or more hubs that's connected to other hubs by backbone links. And similarly, inside of these clusters, nodes are also connected by cluster links. Here, different type of topologies can be used for cluster and backbone structure for hierarchical networks, such as clusters are sparse, like a star or a tree, while backbone networks are denser, like mesh, ring, or fully interconnected. These are some studies about hierarchical networks. Viatel works diagnosability and connectivity of hierarchical star network for forbidden fault sets, while Quag et al. Works on torus ring on multiprocessor. Hierarchical spanning tree is used for network designing by Metaheuristic with Nash genetic algorithm, and hierarchical mesh tree is used as a protocol for multi-hop data collection efficiently. Mesh tree is also used for designing wireless network on chip for multi-core systems. Hierarchical cubic network used for an interconnection network design. Yun and Park shows hierarchical hypercubic network is more suitable for building massively parallel computers. Honeycomb structure is also used for hierarchical networks studies. Honeycomb structure is nature-inspired pattern, so in engineering it's also important for design materials because it's rigid, strong, and lightweight. These are some examples. For example, NPG engineering, computer graphics, chemical engineering, station on positioning for cellular phones, satellite component research, multiprocessor interconnection networks design. In these areas, honeycomb structure is used. Honeycomb mesh properties are also studied, like Hamilton properties, topological properties, and communication algorithm of honeycomb networks, fractal properties, honeycomb networks in higher dimension. In hierarchical honeycomb network, there are many studies, and each of them have different way to form hierarchical honeycomb network. Here you can see 4 different studies. And the first one, it's called honeycomb hierarchical honeycomb network construct by changing all 3 edge vertex of a main honeycomb network cell with a smaller one and repeating the procedure. In the second one, also replace every 3 edge vertex of a base hexagonal network with a smaller hexagon, but the construction of hierarchical network results differently. In the third one, Fang et al. Use different strategy. And the last one, in the study of Xu, a self-similar hierarchical honeycomb structure is created by iteratively inserting subhexagons at the corners of the base hexagon. Here you can see in the figure. Assume that the center of the honeycomb mesh is the origin of the x, y, and z axes, and these axes are parallel to 3 directions of the edges. There are 2 groups of edges, and each node is one of the groups that is black. Here, some are black and white nodes. If the edge is black, then there can be 3 vectors to the white nodes. And if the node is white, then there can be only 3 vectors to the black nodes that have coordinates like this. It's known that nodes of honeycomb mesh of dimension t can be coded by integer triples such as u, v, w. And this is the expression for dimension t. 2 nodes are connected by an edge if and only if between those 2 nodes there are only 1 bit difference. And you can see axis of honeycomb mesh and brick drawing honeycomb mesh tree. And in figure 3, 3 order of honeycomb mesh and their coordinates. Honeycomb networks can be used for hierarchical fractal structure. As you can see in figure, hierarchical honeycomb mesh 0 order, first order, and second order. And the 0th order used in first order, and the first order honeycomb mesh used to construct second order. hierarchical honeycomb mesh. For hierarchical extended Fibonacci cubes, at first let's look at the extended Fibonacci cubes. This is the definition for extended Fibonacci cubes. In EFC, two different nodes can be connected to each other with an edge only if the label of those two nodes are similar except for one bit. And the starting point for the recursion, V3 is 0, 1, and V4 is like this. In terms of edges and nodes, interconnection networks can be described hierarchically if that's between hypercube and EFC. An hierarchically extended Fibonacci cubes is an interconnection network graph containing EFCs as basic building blocks and the node label ij, where I is the label of building block and j is the node number in the ith block. As you can see here, these are the cluster, and between inside of the cluster, these are horizontal links, and between clusters, dashed lines are diagonal links. Construction of hierarchical honeycomb meshes. The nth-order hierarchical honeycomb meshes can be constructed with using n-1 order hierarchical honeycomb mesh graph. And you can see the definition of HHM. HHMN is equal to HHMN minus 1 concatenate with HHM0, where V0 is equal to 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, and 1, 0, 0. Vn is also similar with this one. Vn is equal to Vn minus 1 concatenate with V0. En concatenate with each starting value of the V one by one and union of these edges with external edges. And between the external edges, neighbor edges, there are only one bit. And assume that V1 and V2 are two nodes whose labels are A and B respectively, and each bit of the XOR is equal to 1. That means there is only one bit difference between these two nodes. Algorithm 1 shows the labeling algorithm on HHMN, and the recurrence relation can be written as Tn is equal to Tn minus 1 plus theta 1. So the running time is theta n. This is the function. In the base case, start with initial value. And if it's not the base case, then Vn is equal to Vn minus 1 concatenate with V0. Here you can see the figure 7 labeling of HHM0 and 1, and in figure 8 labeling of HHM2 can be seen. As you can see, each edge from 0th order, 1st order, and 2nd order will concatenate to each other to represent outer HHM. This is the example for the construction. HHM1 can be constructed with integration of 6 HHM0 graphs, so there will be 36 nodes by concatenating these partial binary labels to all labels of the nodes of HHM0, where the initial value of V is like this. The labels can be illustrated by C1 and C0, D1 and D0 respectively. So between those edges Ci and Di, there is only one bit difference. We get the labeling of the nodes and edges like this. And this is for node. V1 is equal to V1 concatenate with V1. So we can get 36 nodes. And the edge is like this one. At the end, we get 36 edges union with external edges. Here the external edge is like this. Topology properties of HHM. For this one, we will look at the Hamilton graph and the number of nodes in HHM. In theorem 1, HHM graphs are one type of Hamiltonian graphs. So, by using mathematical induction, the proof can be shown like this. The base state is k is 0, 1, or 2. For the hypothesis step, we are assuming that HHM k minus 1 is a Hamiltonian graph, and in the final step, HHM k that includes 6 Hamiltonian HHM k minus 1 graph, and as you can see in figure 10, this is HHM k, and each of these smallers are HHM k minus 1. These are Hamiltonian, so between those graphs there are external edges. So that means for HHM1k there is Hamiltonian path. For the theorem 2, number of nodes in HHMN is 6n, and the recurrence relation to calculate these edges with initial value 0 is En equal to 6En minus 1 plus 6. Proof using mathematical induction, we can prove this theorem, and you can see it in. For labeling, we use gray code, but for HHM, requires to use excess bits. N is equal to 3, we use 9-bit gray code for 216. But for 216, normally 8 gray code is enough. Routing of HHM. There are several routing techniques in honeycomb structure. Here are some of them. First, the two examples are given. It seems that the path cannot always be found in hypercube in example 3. In example 3, this node is not defined, so actually there is a deadlock. In the first example, the source node and the destination nodes are like this, and it can be found with using these operations. After doing each step, the root will be found as S1 to S2 to S3 to S4. Here is the algorithm for unicast routing. It takes G graph, source, and destination and calculate the root like this. The running time of the algorithm is theta 3n. In conclusion, HHM has a fractal structure, and the second one is HHM is a Newtonian graph. HHM is scalable. Number of nodes of HHM is 6n, and the recurrence relation for the edge En is equal to 6En minus 1 plus A with initial value 0. Deadlocks can occur when the unicast routing algorithm. The reason is all the nodes are not defined, so if undefined nodes is found, the deadlock will occur. HHM is basically defined a similar structure to HAFN. Both are built over the hypercube. Also, HHM and HEFN are isomorphic graphs. Thank you for listening.
Dear participants of the conference, I present the results of my research work, Intellectual Property Assurance Method for Digital University Ecosystem based on blockchain technology. In the university digital ecosystem, it is very important to have a proper process of collecting, processing, and storing the data about students' educational results, which could confirm the level of the achieved outcomes within their study. In the modern universities, the learning process should be based on the principles of academic integrity. The digital university infrastructure should provide safety and security for staff and students, especially provide the intellectual property of the created academic materials, as some of it according to the national law should be stored from 5 to 10 years. The primary reason for storing all the individual academic materials is the need to confirm the level of education by a certain student. In 2012 year, the Ukrainian government introduced the Unified State Electronic Database on Education, which is an automated system for collecting, registering, and protecting educational information. Since that the diploma as a physical object is not the main goal, the main achievement is the record in this database. It confirms the preference of education degree of a certain level in a certain specialty. There are many similar systems and databases in the world with arms. To obtain data for statistics about education and to confirm all the authenticity of educational documents. Most of these systems are oriented on the verification of documents and certificates, which were issued by universities and other education organizations, and information about this organization, formal and statistical. But there is a lack of information how universities could record information about the learning process that leads to the diploma obtained. To confirm learning outcomes, competences, and skills of each student, a university should take into account a lot of information, which must be trustable and with the highest degree of protection against fake. For example, storing academic information in learning management system like Moodle does not guarantee that there is no threat or data loss, since the method of storing data in the blockchain is devoid of these disadvantages. In our articles, the methods for saving intellectual and personal data in the education based on the blockchain technology were analyzed. And intellectual property assurance method for digital university ecosystem based on blockchain technology was proposed. It consists of the following steps. Step 1, elicitation of the classes of the storing information. Step 2, deployment of file storing and implementation of data transferring process into a file server. Step 3, selection of the method and keys for encrypting private information and files. Step 4, creating an interface system for uploading files and information into the blockchain with the learning management system integration. Step 5, storing information into the blockchain. On the first step, we need to define the information for confirming the skills and educational level of the students. Upon admission, the applicant must provide a lot of documents which must be stored in an encrypted way during the entire educational process. Seals contain confidential information. After students are enrolled, the admission information is created. This information is public and must be stored without encryption to confirm the enrollment process. The educational process generates the following set of files and data. Methodological support, learning outcomes in the form of completed project and diploma thesis, laboratory and practical work, etc. Transport of records, received learning outcomes, students and teachers' certificates and diplomas. In the second step, it is proposed to store the files on a backup server where each file will be assigned a unique number. Thus, a link to the file uploaded to the server will be saved in the blockchain. Depending on the file class, it will be stored
its original or encrypted form. To encrypt private files in the third step, a unique key should be chosen. In each particular university, this key can be selected based on their own preferences. As an example, in the Ukrainian universities, it is proposed to use identifiers from the Unified State Electronic Database on Education. In step 4 should be realized the integration with the used learning platform to avoid data duplication and integrate the process of saving files and data into the blockchain without the need for additional actions. In the fifth step, information which was elicitation at the first step should be saved into blockchain. At the data layer, information about data block, chain structure, timestamp, hash function, Merkle tree, and the encryption is stored. The information shown in figure 1 is entered into the blockchain transaction. The proposed blockchain architecture consists of the transaction head and the transaction data. The transaction data contains the 9 columns with the data about the education process. For producing a digital fingerprint of the transaction, proposed to use the hash of the data from figure 2 using a SHA-256 cryptographic hash function. At the blockchain application level, the interaction between applications and the blockchain is described. The process of saving student project, this is with intellectual property data in the blockchain is shown in figure. For application layer realization, an interface system for uploading files and information into the blockchain should be developed. One of the features of this system is the learning management system integration and API integration with the database with information about students and teachers. The learning management system integration should be used for a simple, protected and user-friendly process of data and files transfer. API integration with the database is requested to obtain data about the student's personal code and education code. The specification for the development of this system will depend on the learning management system used in university and the access to the database with students and teachers' information. Taking into account the systems used in National University Zaporizhzhia Polytechnic, the following application integration is planned. It should integrate information from the university model system, the Unified State Electronic Database on Education, and data from the e-learning community server, which is supporting international projects WiMAX and Workforce. This research was partly done within the framework of international project cross-domain competence for healthy and safe work in the 21st century. Thank you for your attention.
Hey, dear colleagues, my name is Konstantin Zishulkin. I am Associate Professor of Odessa National Polytechnic University. Topic of my presentation, steganographic resources of FPGA-based system for approximate data processing. In this work, we consider the problem of appending a digital watermarks into program code of FPGA chips in steganographic way. A digital watermark gives the possibility to place the extra information hidden from an outside observer in the FPGA program code. This can provide the integrity monitoring of FPGA program code process. Main principles of digital watermarks. The fact of digital watermark presence in a program code is hidden. Digital watermarks don't not change program code size and operation of device. And digital watermark can be read from the program code if someone has a sticker key, the set of access rules to elements of digital watermark. Assignment of steganographic methods to the type of stega containers. For multimedia stega containers, always use methods for non-equivalent change in the data of elementary container units. The base of steganographic methods in this direction is that multimedia data are analog and approximate nature. For containers with exactly represented data, for example, FPGA program code, always use methods for equivalent transformation of container data. Unlike multimedia stega containers, the FPGA code is not approximate data, but exact. Goal of this work is identify and estimate the volume of resources of FPGA program code, which allow performing non-equivalent embedding of additional data. The identification of these resources in this work is performed for FPGA chips, which carry out approximate data processing. Resource estimation is done for this task of steganographic storage of monitoring data necessary to monitoring the FPGA program code. Proposed approach to steganographic data embedding into FPGA program code. First kind of non-equivalent stega resource. Let A and B n bits operands and C 2 n bits complete result for multiplication operation. To convert the result C to the required format, when specified the same size of the operands and the result. The high order n bits of the result are retained, and the low order ones is discarded. In this way, the bits of complete result form two ordered set of most significant bits, and set of least significant bits, discarded bits. The main elementary units of FPGA structure are LUT, lookup table. Such chip contains essential LUTs that are used to calculate the least significant bit of the operation result and do not have any effect to most significant bit. So an essential LUT represented the first kind of FPGA code resources what we can be used to unequally embed additional data. The experiment part of this work aims to confirm the availability of these resources and estimate its volume. Second kind of not equivalent stega resources. We define the essential bits of the program code of the essential LUTs as a second kind of resources that can be used for unequal embedding of additional data. The experimental part of this work aims to confirm the availability also of these resources and estimate its volume. The purpose of experiment to prove the existence of two types of resources suitable for non-equivalent steganographic embedding of additional data into the FPGA program code. The initial data for this experiment were formed using the CAD system Intel Quartus Prime, Light Edition, and the software that we developed. FPGA project were created in the Intel Quartus Prime. Each of these projects implements a multiplier of the corresponding size. For the experiment, we use iterative array multipliers with operands of 4, 6, 8, 10, 11, and 16 bits. On this slide, you can see windows of applications that perform resources estimation, number of inessential roots, and number of inessential bits for experimental projects. On this slide, you can see experiment results. Table 1 shows size of appearance and final results, size of result before rounding, total number of roots in the project, and number of inessential roots. Also, you can see portion of inessential root units among all units. Also, this table demonstrates minimum and maximum volume of Stego container. Second table demonstrates of second steganographic resource. On this table, you can see size of appearance and result, size of result before rounding, total memory volume of root units, root units memory volume used, and amount of essential and inessential bits for binary code multiplication and normalized mantissa multiplication. The result of experiments made it possible to show that inessential roots are present in FPGA-based floating point multipliers. The portion of inessential root units ranged from 39 to 42 of the total number of units in the circuit. Since the distortion of the program code of such root units does not lead to distortion of the results, these units constitute resources for steganographic data embedding. Also, the results of experiments showed the presence in the studied FPGA systems of the second resources for non-equivalent steganographic data embedding in essential bits of the roots program code. The portion of essential bits from 16 to 26%. For codewords and 20 to 40% for normalized mantissa. Thank you for your attention.
I am Mikhailo Polyakov. Together with my colleague, I present a report on the concept of causality in control automata of systems. The logical model of control automata is FSM with three sets and two functions of relation between them. The logical model is the result of formalizing the verbal description of the control problem. The extension of the task solved by the control system makes it expedient to return to the thematic model. The purpose of this work is to provide research on aspects of the behavior of systems associated with a change in the technical state of the elements and parameters of the control object by expanding the knowledge base of system, detailing the interaction of the activity and control counter of the system through the state of the automaton. For the formation of the closed loop of cause and the effect relation, the functions of the object action and reaction are introduced into the automaton. The activity and control leads formed in this process interest in the states of the machine. To describe the relationship of the state with the rest of the machine, we introduce the following elements: even control inputs, even control outputs, activity outputs, and reaction object inputs. The following type of causal relation are possible. Activity is a consequence of the transaction, and transaction is the consequence of the reaction. Classification of states of control machine is supposed. The state of the S sub I machine can be described by a tuple where ECI is the set of inputs of control unit. RI is set of inputs of reaction to activities. ECO is the set of outputs of control units. AO is set of outputs of activity units. Mu sub S and T sub S is functions, activity, and state transactions. Models of switching combinational and automatic state are shown on slide 5. For the switching state, it is enough to list the relation. To describe the combinational state, you need to specify the output functions. In the automata state, the functions mu sub S and T sub S describe two automata, activities and transactions, each of which is a tuple similar to the tuple of classic FSM. We can write the function mu sub S and T sub S in the form of the information array. Graphic interpretation of causal relationship of the simple state of the control machine is shown on slide 6. Combinational and automatic state structure is shown. Functions of activity and state transaction are described in set theoretical and metric form. The control automata of the control unit in the system, slide 6, performs the function of a relay controller with thresholds of the temperature theta on and theta off. The control unit has two states, heat S1 and cooling S2. State S2 is initial. The operating machine of the system generates 4 events. For example, E1 with the current temperature theta greater than theta 1. The main function of the machine shown in the figure are represented. The signal on-off, the events E1, E2, not E1, not E2, and controller heat flow. The temperature at the input of the sensor. The contours shown on slide 7 contain chains of elements that are united by cause and effect relationship. In slide 8, these connections are described by predicates and rules that represent the knowledge base of the control automaton in form of a prolog program. Questions to this program allows you to form diagnostic signals of multifunction. Generalized counters of activity and controls are also shown in the slide 8. This slide shows the further generalization of the outline. The program slide 8 describes the relationship from the action at point 1 and event at point B follows. But in a closed loop, this is also an inverse causal relation with the interface elements of the states of the control machine. The structure of its connection and its presentation in form of the log program is shown on slide 9. The result of inference confirms the functional completeness of the automation structure. The introduction of the functions of the system object into the models of control automata means it's possible to close the counter of cause and effect relations in the system. These loops interact with the state of the control machine. In the state, interface elements are highlighted. Classification and state model are proposed. This makes it possible to describe elements of the elements by elements the activity counter, in which the activity continues determined by active state, and the control counter in which the state change occurs.
Hello everybody. I would like to present you the thesis named Face Recognition in the Presence of Non-Gaussian Noise, authored by Oleg Rudenko, Alexander Bessonov, and Denis Yakovlev. Let's consider some face recognition methods. Visual pattern recognition is one of the most important components of information management and processing systems, automated systems, and decision-making systems. Tasks related to the classification and identification of objects, phenomena, and signals characterized by a finite set of certain properties and characteristics arise in areas such as robotics, information retrieval, monitoring and analysis of visual data, and are the subject of artificial intelligence. The main task of artificial intelligence is to build intelligent information systems that would have a level of effectiveness in solving informal problems that can be compared with human capabilities or those that exceed them. The purpose of this work is the development and testing of a method for detecting faces and recognizing a person or a group of persons at pictures and videos that can be corrupted by non-Gaussian noise based on the use of convolutional neural networks. There are some stages of face recognition. So it is generally assumed that full face recognition consists of 4 main steps. First one is face detection, then preliminary processing, isolation of signs, and finally the fourth step is classification. In our work we use convolutional neural networks, and initially the structure of the convolutional neural network was created taking into account the structural features of some parts of the human brain and that are responsible for vision. And the development of such networks is based on 3 mechanisms: local perception, formation of layers in the form of a set of feature maps, shared weights, and subsampling. According to these mechanisms, to build a convolutional neural network, 3 main layers are applied: convolution, pooling or subsampling level, and fully connected layer. Now let's consider the task of training of convolutional neural network. Convolutional neural network training is similar to training of any direct propagation artificial neural network and consists in correcting its weight parameters based on minimizing some selected loss function, which are usually used as a quadratic functions or cross entropy. To train convolutional neural networks, both the standard backpropagation method and its various modifications can be used. This method is based on the stochastic gradient descent algorithm, or SGD. In practice, the most common neural network learning algorithm is usually used based on the gradient descent method, the propagation error method, and its modifications, like Adam, Adagrada, Adadelta, etc. One of the first methods of detecting faces was
HOG, or histogram of oriented gradients method. This method of information evaluation of spatial points of the image based on the calculating of the number of directional gradients in the space of these points. The basic idea of the algorithm is the assumption that the appearance and shape of the object in the image area can be described by the distribution of intensively gradients or the direction of the edges. Such a description is carried out by dividing the image into cells and constructing histograms of directional gradients of cell pixels. The result of the algorithm is a descriptor which includes a combination of the obtained histograms. HOG algorithm contains following stages. First one is gradient calculation. The second is calculation of the histograms of the image cells. Third one is forming and normalizing descriptor blocks. And the fourth step and final is to classify the HOG descriptors using a training system with a teacher. Another method that we used in our work, in our thesis, is SSD network. It's a very simple, quite simple convolutional neural network that is based on such CNN architectures, faster RCNN and YOLO. However, authors of this network took into account the shortcomings, and thanks to which SSD could achieve new peaks of accuracy and speed. The method is based on the feed-forward convolutional neural network, which creates a finite set of limiting rectangular frames and quantitative estimates of the presence of objects of various classes in these frames, at which it produced the suppression of maximums, or so-called non-maximum suppression predictors. The structure of this network is presented in figure 1. Also, we used MTSNN network in our experiments. It is a so-called multitask cascade convolutional neural network. Its structure is presented at figure 2. One more neural network that we used in our experiments is a retina phase network. The architecture of the retina phase network is shown in figure 3. This network is a single-stage phase detector that detects phases through collaborative, supervised and self-guided multitasking learning. The network has several features that improve the arc phase network's phase detection performance and surpass most network architectures in the vast majority of tests for such systems. Some results of different of our experiments where we use different phase detectors and phase recognition methods are presented in table 1 and table 2. So from these tables you can see that the most effective detector is retina phase, and the most effective phase recognition method is ARC 512D. And this method used 512 different points for identification of the face. And now some pictures and the results of our experiments. So first of all, we were trying to find a single face and to recognize it, or just two faces. So the first approach was to find and recognize a small number of faces. And some results you can see at these pictures. So we are trying to recognize some famous actors and actresses and to detect their faces at pictures. Then we tried to find and recognize a group of people, so a number of faces, quite big numbers, so up to 30 faces at a single pictures. And our system were doing well at these tasks, and we were able to detect all these faces and to recognize all people presented at the pictures that were present in our database of people. And finally, we investigated a problem of recognizing faces at pictures and videos that are corrupted by non-Gaussian noise, like salt and paper, for example. So our system was doing well in this situation, and we were able to detect faces and to recognize them even when about 50% of pixels were corrupted. To conclude, analysis of the obtained results allows us to draw the following conclusions. Increasing the number of more boxes leads to more accurate detection while reducing its speed. The presence of multi-box on several layers also leads to better detection due to the fact that the detector works with several resolutions at the same time. 80% of the time is required to perform computations on the VGG 16-core network. This means that with a faster and equally accurate network, the performance of an SSD can be significantly improved. SSD mixes objects with similar categories, for example, animals. This is probably because Q points are common across multiple classes. The worst performance of the SSD network is observed for small objects, as they may not appear on all object maps. Some increase in network performance can be achieved by increasing the resolution of the input image. The SSD network is quite effective for solving the problem of face detection, both in the absence of interference and in the presence of non-Gaussian interferences. Thank you for your attention.